Check, hey, check. Check one. Check, sound check.
Hello everyone, good morning and welcome back. We are JS Channel 2017, second day. We'll be starting with Francisca's keynote and maybe you like the talk. Thank you.
Well, good morning, everybody. It's such an honor to be opening the second day of this great conference. I thought the talks yesterday were just fantastic. My name is Franziska Hinkermann, and I want to talk to you about JavaScript engines. Just a little bit about myself. I'm an engineer at Google. I work on the V8 team. V8 is Google's open source JavaScript engine that's used in Chrome and Node.js and other embedding applications. And I'm also a member of the Node.js CTC. That's the core technical committee, so I'm a contributor and I'm involved in the technical decisions about the Node.js project. I'm from Germany and I work in the Munich office, so it's quite a long flight, but it's definitely not the longest flight of the people here. Our office in Munich, it's a fairly reasonable sized engineering office. There are 500 engineers. Some of them work on Chrome, and there's also internal tooling that we do there. And most of the V8 team, like almost all the V8 team, we're around 30 people, is located in Munich. So if you ever wondered if you have to move to Mountain View to work on cool Google projects, there's some excellent engineering going on in Germany. So the next 45 minutes, I want to give you, as much as I can, an overview or an introduction to JavaScript engines, specifically with the focus of what they do to create good performance for JavaScript. Why would you care about JavaScript engines? So any JavaScript code that you run, it doesn't matter whether it's in the browser or IoT or Node.js or a command line tool, any JavaScript code to go from source code to executing the machine code, that is done by the JavaScript engine. So basically it's the foundation of any JavaScript work that you do, no matter what. And I think it's important that you don't only understand how to use JavaScript, but also what it does under the hood, because that will explain to you a little bit of why you do certain things in a certain way. I really like to understand how things are working and not only be taught how to use it. So I want to share that about JavaScript engines so that it's less of a black box magic for you about what's happening when you load your source code in the browser to when it's being executed. What you learn in this talk, you probably will not go into the office on Monday and say, oh, I heard a talk and I'm going to apply this right now. It's not a library or a tool that you can easily add to your project, but I hope that it gives you a better overall understanding of how JavaScript engines, how they work, and how they are influenced by the code that you write. So by knowing that almost in like an intuitive way, you might be able to write JavaScript code that works better for the modern engine. So in the end, you have better performance. Or maybe at some point in your career, not necessarily next week on Monday, but maybe 2 years down the road, you have to track a nasty performance issue, and having this kind of understanding might help you there, getting a little bit more insight and then being able to fix that performance issue when it arises. I want to compare this maybe to sports. So I'm really into horseback riding, and you can learn horseback riding by taking lessons, and the instructor tells you, if you do this, the horse will do this, and you practice that, and they tell you what to do so you learn how to ride. But if you actually study a little bit the anatomy of the horse, so that'll give you a better understanding of why you're doing certain things. And you're not, like if you learn the anatomy, you're not learning a new lesson that you can apply right the next day and make your horse go sideways. You're just gaining like a deeper understanding that later on will help you. So I don't have to tell you that JavaScript is literally everywhere. It's on every operating system, it's on the web, it's on mobile, it's server-side, it's on IoT devices. It's everywhere, because it's a solution for a lot of problems. It works really well if you're just hacking something out and prototyping. It works really well for beginners or for kids because you have this instant feedback. You can make with kids a website with JavaScript in an afternoon and they can show it off to your parents. Like, that is really awesome, but it's also great for enterprise projects. I mean, I think most of you probably have production critical things written in JavaScript. We have React frameworks, Angular frameworks, we have enterprise node servers, and all of that is powered by JavaScript. And I think one of the reasons that allowed JavaScript to be everywhere is its performance. I want to give you this quote here. 100x improvement in JavaScript performance since 2001. So 100 times faster than it was at some point. The statistic where I got this from is already a few years old, so it's even faster now. But just imagine your JavaScript was still as slow as it was in 2001. You could never write a Facebook post, probably. Like, it would just take way too long. Like, all the tools that we have, they would be useless if JavaScript weren't as fast as it is. And without the tools, we wouldn't have the community, we wouldn't have the libraries. Like, it all goes together, and it is in big parts driven or enabled by the fast JavaScript that the browsers are giving us. And the performance of JavaScript, what it comes down to is what the JavaScript engine does, because the engine is executing your JavaScript, so if the engine is slow, you'll have a really bad experience using a JavaScript application. So JavaScript engines are what give us performance, and they have massively improved performance over the last 10, 15 years. And I want to show you some of the details what the engines are doing to get this speed up and why we're not stuck in slow JavaScript from 2001. There's more than one engine, luckily. I say luckily because having several engines means competition, and competition means that we keep working on improving the engine. So in the end, everybody benefits because it gets faster, it uses less memory, all those things. Just a very quick overview. So all the major browsers have their own engine. There is Chakra Core in Microsoft Edge, JavaScript Core or JSC in WebKit Safari. In Firefox engine is called SpiderMonkey, and then Chrome has V8. And you know, JavaScript's not limited to the web. Node.js obviously has a JavaScript engine. By default, that's V8, but you can also get the node with Chakra Core, and there's a Spider node fork. Electron has a JavaScript engine. And on Internet of Things, on IoT devices, sometimes you're forced to trade in performance for memory size. So on some IoT devices, if they're too small, you don't want to run a full-blown, super fast browser JavaScript engine. You use an interpreter one that is much smaller in memory size, but maybe a little slower. So there's there's duct tape and Samsung's JavaScript, for example. And since I work on V8, most of the details will be about V8, but the general concepts are the same in the modern engines. So things have different names, and the bytecode looks slightly different in the other engines, but overall, it's a very similar concept. So any compiler, doesn't matter what language, is usually built up like this. You have source code, and then the first step is that you pass that source code with a Lexan tokenizer into an AST. That's an abstract syntax tree. That's just a representation of your source code that is more approachable for machines to work on it. So that is just a different representation of what you wrote, which makes it easy for the compiler or interpreter then to work on that representation. So once you have an AST, then there's the part that generates the machine code. Sometimes that's called a compiler, sometimes it's called an interpreter. There isn't really much of a difference, it's more of a preference. In general, in compilers, anything that takes one kind of format and turns it into another kind of format. So you can compile JavaScript in general. When you have JavaScript, you compile it to machine code, or on a more specific level, you have the abstract syntax tree that you compile to machine code. And sometimes we also call this interpreter if it's not an explicit compile step. So that's what sort of every compiler looks like. And actually, I will not cover the first part here, so I will not talk about the parser, but my coworker Maya, she has an excellent talk on YouTube that goes into all the details of the quirks that you have to worry about when you parse JavaScript. So I recommend watching this talk and getting some idea about what the parser is doing. I will focus on the second half of this part. I will focus on the interpreter compiler part here and the machine code that is generated. So I keep referring to this over and over during the talk, so this is important. The compiler that JavaScript engines use is a just-in-time compiler. That's abbreviated as JIT a lot of times. You can JIT code, that means you're just-in-time compiling it. A just-in-time compiler, sometimes it's also called a lazy compiler. That means you compile the code just in time as you run it. The opposite to that is an AOT compiler, ahead-of-time compiler. That is when you first compile all the code, and once you're done compiling, you have a separate step that runs the code. In a just-in-time compiler, that is different, and that's the important part now. In just-in-time compilers, you alternate between compile time and runtime. So you have code, you compile a little bit, and you run that, and then you compile some more, and you run that, and you always flip between compiling and running. And the big advantage here is, it's not that you're lazy, so you save a lot. The bigger advantage is that when you run code, you can gather runtime information. Things like which functions are run, what kind of parameters are they called with, and you only get this information as you're running the code. So only during runtime can you collect this information, and just-in-time compilers actually use this information to then create better compilation targets. So you start off, the compiler doesn't know anything, and it's compiling in sort of a dumb way. Once it has compiled a little bit, you run that, compiler collects information, and now the compiler compiles again, and it can be smarter because it has more information. So JIT compilation means alternate between running and compiling, and the big benefit is that you can collect runtime information and use it for better compilation. So, one more thing. You sort of know that JavaScript is just-in-time compilation because you cannot separate the JavaScript executable from the source code. Like, when you run JavaScript code, you always need the source code. It can be minified source code, but it needs to be JavaScript. If anybody has experience with C++, you have a very clear separation between runtime and compile time because it's two separate steps. First, you say GCC dash and so on, and you wait a little bit while it compiles, and you get an executable, and that is separate from the source code. So there's only one compilation, and it compiles everything, and it does not have the advantage of gathering information from the runtime. It does everything at once. But at JavaScript, we alternate, and we can separate the two processes. So this picture now of any basic compiler, for JavaScript engines, it looks different. So the interpreter is a JIT compiler, and actually you have this feedback loop. It's not one directional all the way down. It's like all the way down and then back and forth between those two. Okay, so the fact that the compiler can gather some runtime information and create better code the next time that it compiles code, that gives us some speed up, but it's not quite the 100x that we actually need to run modern JavaScript. What every compiler has up their sleeves is a so-called optimizing compiler. So every modern engine has at least 2 compilers. JavaScript core even has 3 compilers. And what the optimizing compiler does, it recompiles so-called hot functions. A function is hot if it's run many times. There are certain heuristics that distinguish between how often is the function run and what size in it, and and at some point the compiler considers it hot, and then the optimizing compiler jumps in, and it does a little more work. Like time-wise, it's a little more expensive to compile with the optimizing compiler, but you get better machine code. So you spend a little bit more time recompiling a function that's run a lot, but then when you do run the function, and when you run it a lot, you're saving time because now it's faster. So our picture gets even more complicated. So you start with your source code, parser parses it, generates an abstract syntax tree, and now we don't have one JIT compiler, we have two compilers. We have a baseline compiler, the one that handles all the cases, and it generates, well, sort of average machine code. And then we have the optimizing compiler that only handles special cases, those that are worth optimizing, and it generates machine code that is really fast when you run it. And since I work on V8, some name dropping here. So our baseline compiler is an interpreter, and it's called Ignition. And our optimizing compiler is called Turbofan. So if you read any articles about Ignition and Turbofan, and it's not in relation to cars, then it's probably about the compiler pipeline in V8. All right, so far the theory. So here's a high-level graph of what the compiler looks like in the V8 JavaScript engine, and it's similar to the other engines. So in Safari and JavaScript core, you would have a third compiler, the one that is handling super hot functions, and that actually works really well for them. JavaScript has some amazing performance things going on. But also in Microsoft Edge and Firefox, you have at least these two compilers that help you to speed up JavaScript. But so that's the high-level overview, and now I hope to make it more concrete by giving you an actual example. And compilers are fairly complex. 45 minutes is not that long, so I'm sticking with a really, really simple example. So I have this function here that you would probably not write in real code because it's so simple, but it's my function called add. It takes one parameter object, and all it does is it returns 1 plus object.x. And to make it even simpler, we will just focus on the plus sign, on the addition operator for now. What is the plus sign doing? It adds numbers or it concatenates strings, right? Everybody has pluses somewhere in their code, I'm sure. If we look at the JavaScript specification, though, the ECMAScript specification, don't worry about reading this. You don't need to care about the details. I only want to show you that this is actually a really long list. I mean, when you start out learning JavaScript, the addition operator is fairly early on. It might not even be explicitly said. But if you look at the specification, it's 10 steps that you have to follow to create correct JavaScript. And actually, it's much longer because every single one of these steps calls another method that in turn has like lots of steps itself again, like toPrimitive and getValue and so on. So it's just lots of steps you have to go through to as a compiler when you want to plus two things together in JavaScript. My teammate Ben actually went through the trouble of following along the JavaScript specification for the simple addition operator, and he drew out that diagram. So you can see, from a compiler's perspective, something as simple as a plus, just to be spec compliant, which all the engines have to be, you have to follow all these steps. And obviously, lots of steps means many instructions, means not very fast performance-wise. If you add numbers in a for loop, and every time you have to do all of this, you're going to be waiting a long time. And I want to point out, I think that's pretty cute, at the top of the specification, there's a note. The addition operator either performs string concatenation or numeric addition. So the editors of the spec actually had the need to put in this note because if you just look at the steps, what it's doing, it's sort of hard to figure out what the plus is doing. So they like summarized it at the top. All right, so if you have anywhere in JavaScript some object plus some other object, or some variable plus some other variable, we don't know that they're objects, then from a compiler's point of view, it's lots of instructions. So from a performance standpoint, that is not what we want. That is just a lot of work. But if you think about adding two integers from the point of view of a computer, that is basically what CPUs were built for. I mean, they're not binary numbers, but that is a really simple task for computers. And also in JavaScript, if you're just adding integers, it's not really that complicated specification-wise. You just have to make sure that you're in the case integer plus integer. If you add doubles, yes, there's some funny rounding quirks, but really it's not as complicated as that specification. Or even string concatenation, that's fairly straightforward. So if a compiler could use the information that it's really just adding doubles and not doing anything according to the specification, that would be really good in terms of performance, because it would be a lot less instructions. And that's actually exactly what we use in JavaScript engines. So back to our add function. The first time that we call this add function, the compiler has to really follow the whole specification for the addition operator. There's no way around it. If we do any shortcuts, then it would not be correct JavaScript. But now we're calling this function multiple times, and I said before, the big advantage of a JIT compiler is that it can collect information during runtime. So as we're running this function that is during runtime, and we collect information. And the information that we're collecting here is, well, always adding integers, right? We ran this a bunch of time. We did 1 plus 7, 1 plus 42, 1 plus 13, and integer addition would be really easy. So the compiler now can pass off this function to the optimizing compiler with the information that it usually sees integers, and we can, or the optimizing compiler then generates machine code that is really fast if you only add integers. The machine code would do something completely wrong if all of a sudden you pass it a string or an object. But for integers, it gives you the right sum, and it gives it to you really quickly. So after we optimize, when we now call this function again with an integer, yay, that is fast. And you could not do that if you had ahead-of-time compilation, because if you compiled this ahead of time, the compiler wouldn't know that it's usually integers, so it wouldn't be able to generate this fast code path for us. Do you see a problem with this, though? Nobody is stopping you from changing your mind and just calling this function really differently. So what's happening now? Well, actually, when we run this optimized machine code, we always do a quick check before to make sure our assumptions are right. We just say, hey, is this an integer? Awesome, let's go with the fast path. And if it's not an integer, well, it's not the end of the world. We just go back to the baseline compiler, we follow the specification. It's a little slower, but it's still correct. It's not crashing your program. Like, everything works, and usually you wouldn't notice the slowdown. You only notice the slowdown if you write a framework or something really mathematical and it's run a lot. But it would add up all over your program, so you kind of want to avoid it. But nothing is breaking here. It's still working. The only thing is we went back to the baseline compiler. So in our picture, when we first run the add functions, the first few times, it's the baseline interpreter ignition that's handling that. We get machine code that is fairly slow. At some point, the baseline compiler signals to the optimizing compiler that we're running this add function many times. It's hot, it should be optimized. And now turbofan generates better machine code. And it can only do so because it uses this feedback information that we're adding integers. And if we ever change our mind, or if there's different kind of data coming from the customer that turns into different objects, If we change our mind, then we violate the assumption that the parameter is an integer, so this feedback doesn't quite match anymore, and we'll just go back here to the slower bytecode. So just-in-time compilers, they use this speculative optimization. They run a few times, they collect information at runtime, and then they speculate what will happen. And then they use these speculations to make better and faster code. Okay, so this was about integers, and I think you can all see how this is different for strings and doubles and other kind of objects, or for objects, but integers is only half the story. The way more common thing you have in any real JavaScript code is different kind of objects, right? You have big data structures, big objects, they all differ. And it won't help you if you have a fast pass for integers because you usually use objects that carry more information. So one thing that you always do in JavaScript is that you load properties from an object, right? And the compilers also have a trick for optimizing for that case here. So I want to look at this property lookup now. You have this all over your code, and intuitively you say, well, it's just getting a property of the object. But actually, it's a lot more, and you know that. You could get a type error if you do that. You can get cannot get property X of undefined. Object.X might not be defined and be undefined. Object might not have an own property X, but you might find it on the prototype chain, so you have to recursively go up the prototype chain. The object might be defined as a proxy that has a get trap, so every time you get a property, your function is being executed, which can have any kind of side effects that you put in there. And the X might have been defined ES6 style with an accessor descriptor. So you don't set a value, you set a get and a set function. So even for you as a developer, there's quite a few things that could happen if you just say object.x. It's not as simple as it might look because you use it everywhere. But for a compiler, it's even more complex because even if, as in the most common case, the object has a property x, the compiler needs to know where in the memory layout is the value for that x. Like in JavaScript, there's nothing that specifies what the properties of an object are where the compiler could just look up where that is. That is something we handle internally in the engine, and it's up to the engine implementers how they do that, and they just need to keep track of where they put the values, so when you do query object.x, you get the correct value. And again, the specification is fairly complex. It's lots of steps. There's a recursion hidden in there. There's arbitrary side effects from calling user functions and so on. But obviously, you are doing property lookups all the time. So that is something we have to speed up in the JavaScript engines. So let's look at how we do that. So we're calling our fancy add function again. And the very first time that we call it, we have to follow the steps from the JavaScript specification. Otherwise, it wouldn't be spec compliant, so quite a lot of work. So now that we figured out where to get this 42 value when we call the add function with this particular object, we actually cache this information. So we have a cache, and what we put in the cache is for this shape of object. So in this case, an object that is an object literal with only one property x that is an integer. And we didn't mess with the prototype chain. For this shape of objects, we put in the shortcut of where to find the value. So in our memory layout, that is usually in the simplest case, just an offset to where the object is, where this value of x would then be. So we store the shape and a shortcut of how to get to the value. This is very important. We are not storing the actual object, and we're not storing the value. Like, the result here is 42, but we don't put that in the cache. We only put a shortcut how to get to that x value. And we associate that cache with the call side of the property lookup. All right, so the next time that we call the function, when we're trying to get the object at x, instead of looking up the ECMAScript specification, we first ask the cache, right? That's a common thing that you have a cache, and so later when you want data, first thing is ask the cache and only then make the expensive request. And that's exactly what the JavaScript engine does. It's asking the cache and it's saying, hey cache, do you have an entry for objects that look like this? And you can tell the second time I call it, it's a different object. It has a different value for x, but they look very similar, and they actually look the same internally to the compiler. And then the cache says, oh yeah, I have an entry for that. Just go to this position in the memory, and you'll get your x value. So instead of doing these 10 steps, we have to do one quick lookup in the cache, and then just follow the shortcut. And these caches, they actually have their own name. They're called inline caches because traditionally they were actually inlined into the code. And we abbreviate them with IC. So if you ever look at our source code or if you do some tracing, you'll see lots of variables or classes that have the letters IC in them. So that stands for inline caches, which is exactly that cache in the code that gives you a shortcut for property lookups. And an inline cache is always associated with the call side. So in this piece of code here, even though it's one function and twice exactly the same lookup, there are two separate call sides. So the inline caches are completely independent for these two lines. I kept waving my hand and saying shape of an object. So this is something internal to the engines. It's not specified in the specification. In V8, we call the shape of an object a map. So if two objects have the same map, then we know that they have the same memory layout, and we can treat them the same if you make the same queries on them. And sometimes people also refer to these shapes as hidden classes, because obviously they're not a class that you can query as a developer on the JavaScript side, but conceptually they're similar to classes of objects in Java. If you have a set of objects, and if they do belong to the same class, then they have the same memory layout, and they are sort of treated the same way. So the inline cache is a cache of the map of an object. That means what's the shape of it. That gives you a shortcut of how to get to the result. And if you ever want to play around with this yourself, you can actually use these hidden intrinsic functions in V8 to get some information about these internal details. So we have a bunch of functions in V8, we call them intrinsics. You can call them in JavaScript code if you start V8 with certain flags. So if you start Chrome or Node.js with a special flag, allow native syntax, you have access to some functions that you prefix with a percentage sign, and they give you information about internal state, like they're useful for debugging and things like that. So there's a half-same map where you can actually play around with to check your intuition about whether you understood what we mean by two objects having the same map. All right, so in our graph, when we call the add function, just as before for the property lookup, first ignition is handling that, the baseline compiler. If at some point the function is hot, then we pass it on to turbofan. Turbofan optimizes it, and it uses the feedback about the hidden classes, so that this lookup object.x can be made really fast now. And again, just like before, when instead of an int we used a string, if now instead of having that object that only has one property, if we, for example, use an object that has two properties, then those do not have the same map. They're considered very different, and we cannot use the same shortcut to get x, because this x might be somewhere else in memory now. Like if you would just take offset 1 of this other object at the bottom here, you'd probably not end up with the value for x. So in that code, in that case, we de-optimize and we go back to the somewhat slower baseline compiler. I want to tie this in a little bit to what Prathi was talking about yesterday morning. If you remember, she was talking about reasonable JavaScript, and she said how super helpful types are to make your code more readable. And I just want to clear this up because I talk about types and shapes of objects, which is sort of like the type of objects. In tools like Flow or TypeScript, where you typify your parameters, you do that for humans. It makes the code more readable, it makes your IDE be magic and help you a ton, it makes it easier to catch bugs early, but it's all for the developer. And it helps you with correctness of your code. You notice if you switch the order of parameters or something because you can't even compile it then. And when you write TypeScript or Flow, you cannot just put that in the console of the browser and run it. You first have to transpile it to ECMAScript specification correct JavaScript, and then you run it in your application, right? When you use TypeScript, you always have a transpilation step that gets rid of all the TypeScript annotations, and you're ending up with regular JavaScript. The shapes or maps in V8, they are not for the developer. They are internally for the compiler. So they don't help us or the JavaScript developer to avoid bugs or to make the code better readable. They're just there for the compiler. And they're not helping with correctness. You can switch the shapes just as we saw before, and your JavaScript is still executed correctly. They only help with performance. And also the shapes in V8, they're not determined ahead of time, they're determined at runtime. So just to put types in TypeScript versus types and shapes in V8 next to each other, this is how they're different. And unfortunately, just because something has the same type in TypeScript, it's not necessarily the same shape in V8. But usually, if two things have the same shape from the point of view of the compiler, then they usually also have the same type, except for when you do like type definitions in TypeScript, and a string is either a first name or a last name, and for the compiler, they would both be the same kind of strings. So in general, if you use tools like TypeScript or Flow, which help you to stick with the same type of variables, you're definitely not working against the compiler, which is a good thing. Okay, so I want to go into a little more detail about our baseline compiler, the bytecode interpreter that we call Ignition. So that's the first step that our compiler is doing after the parser has created the abstract syntax tree. And V8 used to not have bytecode. The baseline compiler would straight out compile machine code. It was just not very optimal machine code. But earlier this year, we changed the compiler pipeline, and we have an interpreter now that generates bytecode. And I mentioned earlier that the V8 team is in Munich, but the interpreter is actually mostly built in London. And the reason why it's not originally coming out from the V8 team, but by a different team, is that it was sort of motivated by Android, by mobile. Because a bytecode interpreter helps you to decrease the memory size. You only have to store a few bytecodes rather than all of the machine code. So that was the original motivation at some point, and that's why we have another very small team that's not in Munich. But actually, Ignition did not only help us with the memory size, it actually really helped us internally in structuring our code and making it fairly readable. And I want to show you some bytecode here. So these 6 lines are actually the bytecode for our add function. Before I go into explaining what they mean, our bytecode interpreter is a register machine, so it has these virtual registers, R0, R1, R2, and so on, where you can store things into and load them from, and it has one special register, the accumulator, that is always used in every bytecode or almost every bytecode. And the advantage is that you don't explicitly have to mention it. So your bytecodes are shorter because you don't always have to pass that operand around. So we have a bunch of registers where you can store things in and then do stuff with them. So the bytecode for our function, the first thing it says is stack check. That's some housekeeping work we have to do every time we enter a function. Let's ignore that. But then it says load smi1. So smi is our word for small integer. That's just integers that are not too big, so we don't have overflow issues. So that means load the integer 1 into the accumulator. We never say accumulator, but that is implicitly implied here. So our registers look like this now. The value 1 is in this accumulator register. So the next line, store R0 into from the accumulator. So we take whatever is in the accumulator and store it into the register R0. Then the next line, load named property. So remember we had to do this property lookup object.x. That's a named property, the name is x. So A0, all the parameters in the bytecode are called A, and object was our first parameter, so A0, and we're loading the property x, which is stored in a side table that x is the first entry, that's why it's 0. So we're loading the value of that in the accumulator, and when we call add with the object x42, that named property is just 42, right? Okay, and then the next one, add R0. So that means add the value that is in R0 to whatever is in the accumulator. So add these two together, which obviously is 43. And that's all the function had to do, right? Get a property, add them together. We leave this result value in the accumulator so that the next function, the next bytecode, can work off or can work with this 43 value now. So the bytecode at first, it might look a little bit confusing, but if you read it carefully and if you know that there's always this accumulator register, then I think this is actually fairly readable, like especially compared to assembly machine code. So that's what the ignition bytecode looks like, and then a little bit of an explanation what it does. Okay. So I keep saying that on the left side of our diagram, where we always have this baseline compiler, it is slow because it's not optimal machine code, it's many instructions. And on the right-hand side in the diagram that I showed you earlier, where we had the optimizing compiler, where the hot functions were passed to, I said this is optimized machine code. And I just want to give you an idea for this add function, what the difference between the left and the right-hand side is. I mean left and right-hand side of the diagram with source code, parser, and then compiler, faster compiler, and so on. So on the left-hand side, this is the assembly code generated for our add function in the baseline compiler. And it actually runs on for like 2 or 3 more pages. Because these instructions, they have to reflect what I showed you earlier in the specification, this really long maze of following things and doing recursive calls and so on. So this is a lot of work for the compiler. It's all these steps just to call this tiny little add function. And on the right-hand side, this is actually the assembly instructions, so the raw machine code for the add function when the optimizing compiler is done with it. So if we've called this function always with the same shape of objects, and we're always adding integers together, then you have 4 lines versus pages of instructions. Very quickly, if anybody is familiar with assembly code, Or if you're not, this is what these instructions mean. So the first one, compare, we do a comparison, and here we are comparing the maps or the shape of the object. So by doing this comparison, we are checking whether we have the same object that we had all the time before, the one that we speculated that we will get and optimized for. So we're comparing these two values. If they're the same, we know, oh, they have the same map, the same shape of object. If that comparison evaluates to false, then we do a jump to bailout. So that was the bailout, the de-optimization, where we had to go back with the red arrow to the baseline compiler. So that would actually bring us back to the left-hand side, and we'd have to do a few hundred instructions instead of 4. But if those two are the same, then the next thing we do is a move instruction. This is where we are moving the named property, which in this case we know is just at an offset to the object. That's the array x plus 1b. That's like the offset to the object that was the parameter, because we know that's where the value is, because we know what the shape of the object is. We just checked that. So we move that into register, and then it's one more instruction. It's the actual integer addition of that plus 1. So 4 versus lots of pages, especially if you do call this function multiple times. I think you can all see how this can give you this performance improvement and why we are not stuck with the JavaScript from 2001. So to really drill that into you, the just-in-time compilers and JavaScript optimization and JavaScript engines, they're heavily relying on speculative optimization. So we gather information at runtime, and that's why it's so important that we alternate all the time between run and compile time and not do one first and then the other. We gather information at runtime, and then we speculate that the future will look similar to what we've encountered before, and we optimize for that case. V8 is open source, and so the other big engines, you can try out all of this yourself. You can use Chrome, or Node is probably easier because you use that on the command line anyways. You can also build V8 yourself, the instructions on the web, and then you have D8, that's the debugging shell for V8, and you just call that with different flags to get to some of the information that I talked about. So you can print opcode, that is print the optimized code. Those 4 lines that I just showed you would be the result of that. You can print the bytecode. I showed you the bytecode. You can, for example, trace IC. So you trace the inline caches to see the different states that they're in. And the last one, I like the last one, trace optimization and trace de-optimizations. When you run that, you see when is which function being optimized and when is it de-optimized. So you can totally follow through and see, oh, I ran this for a while and now it says optimized, and oh, here I changed the input so it had to de-optimize it. We bailed out and went back to the left side where it was the baseline compiler. So you can play around with all of that if you want to. In the past, you might have seen specific performance advice for V8. That is not really applicable anymore because we switched out the compiler pipeline completely this year. And so many things that our old pipeline was just not able to handle in the optimizing compiler got fixed now. So I don't have any specific advice for you. I can't give you a single piece of code and tell you on Monday when you're back at work, avoid this and you will see a speed up. We don't have anything like that anymore. And if we do have, it's a bug and we're trying to fix it, but it's not like an inherent structural thing that we will never fix like it was in the old compiler pipeline. But the advice that I do want to give you is that because of how JavaScript engines work, because of the speculative optimizations, if you write code that basically looks like it's statically typed, then you're working with the engine and you allow the engine to use all its power to give you the best performance. So write code that's basically statically typed in nature because that is what's best for modern JavaScript engines. Thank you.
Can we have questions?
Hey, first of all, great talk.
Thanks.
And I have one question. You said the engine caches object skeleton or shape of object, right? So does it mean when we do delete a property, like say delete object.x, does it mean that it decreases the performance?
Yes, so the question is, if we call delete on a property, how does that affect performance? So every time you delete or add or even just define properties in a different order, they're different objects, they're different maps for the compiler. Okay. So they cannot be treated the same, and it might give you a little bit of speed down for performance. Yeah, so if it is feasible for your code, sometimes it's better to just set the value to undefined instead of deleting the property.
That's something we can go to on Monday and apply to our code.
Okay, yeah.
Thank you.
Hello. Yeah, actually, sometimes we have to access the properties on an object multiple times. So is it performant to cache that property into a local variable? And if it is performant, then how much it will increase the performance of a code?
I'm not sure that I fully understood the question. So the caching is always done by the engine anyways, and the details of it, we might change it a little bit, when and how much it caches and when it goes into which state. It's helpful if you can define all the properties when you first generate the object instead of to later add or delete properties.
Okay, thank you.
Hi, I have a question, slightly off topic, but you mentioned that in case of Node.js, we can have not only V8, but the other engines as well. Mm-hmm. Now, I don't, can you hear me?
Yeah, that works.
Yeah, so I don't actively do backend development in Node.js. So I would just like to know, like, in what scenarios would we need to swap out one engine for another, and whether it's a very complex thing or it's something fairly easy.
Oh, it's very easy to get Node with Chakra Core. That's the Microsoft engine. You just go to the Node.js repository or the Node.js website, and there's links for binaries of Node.js, and you can also get all the source code and build it yourself. And Microsoft has great documentation there, how you get it, and they're super helpful if you do run into any problems. So it's not hard to get that. The Spider Node fork is still a project that's currently being developed. I don't think you can fully use it yet. And you might want to use a different engine to compare performance, or maybe if you have specific things that you need from the debugger. Maybe you don't want to use the V8 inspector, but you do want to use Microsoft Chakra debugging protocol. Yeah, those are reasons for why you would want to switch to the other engine.
Okay, thank you.
Hello. Okay, thank you. It was a very great talk. So my question is, since we are using like a JIT and speculative optimization, and so instead of a speculative optimization, aren't we going to machine learning for the compiler, as Google is a lot into the machine learning?
Sorry, can you say the last part again?
Machine learning for compiler. Right now we are, like as you told, that we are going for a speculative optimization. For optimization, we are using speculative optimization, right?
Yes.
So, and as Google is already into machine learning, aren't we going to use that machine learning for optimization? Isn't it clear?
Maybe you should catch me after and we discuss it offline. I think I'm not fully getting what you're asking. You want to find me afterwards?
Sure.
Okay,
Thank
thanks.
you.
Turn it on.
Could human type system like Flow or TypeScript in the future give V8 or other JavaScript engines hints on how to optimize the code and which shapes to expect?
That's a good question. Right now, they don't, but it's definitely an interesting point of research, because especially for frameworks, that would be really great if the engine could benefit from that information that the human developer has specified upfront. But at the moment, we don't have that yet.
Okay, thanks.
Talking about WebAssembly, I know that WebAssembly and these bytecodes are kind of different. Is there any effort to combine them so that the code generated by WebAssembly, the bytecode generated by WebAssembly, could like take advantage so that you don't have to throw out chunks of data over the bridge?
WebAssembly is using the same compiler pipeline.
So is it in the same? Is it in the same like namespace and same context?
It's using turbofan. Yeah.
Yeah, we'll have just last question.
So it's related to like kind of Node.js. Node.js uses singletons, right? Like we have these modules which we can like load once and then that stays in memory. So is there anything that V8 does with respect to that? I load a module and then I try to use that module again and again. So that module will be like do this like compile like for multiple uses, though like I hope.
When are node modules compiled? V8 uses the same optimizations for the modules, and just Node Core puts in the machinery so that the loading works, but they should also be compiled and optimized.
Okay, thanks.
Yeah, thank you, Franziska. It was an amazing talk.
Thanks.
I hope you guys know how the exact JavaScript rendering happens behind the scene and what is the compiler basically doing at the end. So our next talk, Jay Santosh, I would like to invite you on the stage.
Does need okay, no. All right, so good morning, everyone. I hope everyone's fresh and had their coffees. So what we'll be talking now is how will we deal with data offline in web applications. I am Jay Santosh. Okay. So I work as a web architect in ClearTax. You can find me at JSanth on Twitter. Just before we start, I'll throw around a little data. So there are like 3.4 billion internet users around the world who browse like about 5.6 hours per day. And out of this, about 10%, 355 million, are actually Indian users. So in India, we have about 250 million overall mobile phones, out of which 110 million are smartphones. The rest are all still feature phones. So the average cost of people using about a gigabyte of data every month is about 1.5% of per capita GDP in India. So yeah, mainly like it's actually declining year over year, and it's getting much cheaper. But given that we know what happens in our day-to-day life, so this is like what happens in most of the urban population, for most of the urban population. So this huge amount of traffic and whatever data speeds that you get, even if you're on 4G and if you're using an iPhone, because the overall bandwidth is limited, you get very low speeds on your phone. Also in rural India, one thing is like a lot of people have started using a lot of smartphones, but one thing is like they don't use a lot of data, and like there are statistics that are collected so whenever they want to use something on the internet, they switch on their phone, switch on the data on their phone, and once it's done, they switch it off. So predominantly, you should start thinking about developing your web applications offline first, okay? So what means by offline first is from the browser, whenever you hit the internet to get data, if the data connectivity is not there, which means you're offline, you try to give it back from some cache, some sort of cache, which to the browser. And whenever you get online, you just use the internet as is. So what is the magic formula to achieve this is we've actually heard of something called service worker for about a couple of years now. I'm not going to go into too much detail now because yesterday we had a talk by Mukul and where the internals of service worker was actually explained well. But just one thing, so we are aware of the caches API where it allows you to cache, your service worker is like a network proxy which uses the caches API to cache your data in the browser. There are other libraries like SW Precache, SW Toolbox. Google also came up with this new library called Workbox.js, which allows you to mainly, it is a JavaScript library for building progressive web apps. So over and above using it offline, giving network caching strategies, apart from offline, it also tries to give offline analytics. It also allows you to do background sync of your applications. So just a little overview of how you can use Workbox is, so you mainly register a route which you want to cache, and then you can define your caching strategy. It could be network first, cache only, network only, or like whichever is stale while the cache is getting revalidated, which means that it serves from cache first and then fetches from network and updates the cache. Okay. So it also gives you elaborate caching configuration, which like you can say for this cache first strategy, you can use this as your cache name. You can specify cache expiration, what should be the response codes if it is returned from from the service worker, and so on. So the other great thing that is available is like you can actually get a lot more of Google Analytics or offline analytics, mainly for analyzing how people are using your offline app, right? So it mainly uses a queue plugin, which you can basically initialize, create a request wrapper, and when you're routing, you can pass the request wrapper object to it. Okay? So service worker is actually ideal whenever you're dealing with HTML, CSS, JS, mainly static asset caching, and data which is mostly like in a read-only mode. For example, earlier I worked at Flipkart where we built this Flipkart Lite app. So there the app was mostly read-only, and we need to mainly cache the responses from the server directly through service worker, and that was good enough for us to allow the user to operate offline. But what if you have an application which is a lot write-heavy, right? So one thing that you can do is use a service worker. You can probably use IndexedDB for storing whatever data is created. But yeah, one thing you need to ensure is like since service worker mainly only caches like request and response objects, you need to wrap around your data with a response object, and your application should then will just use that response object given by the service worker. So since you need a promises wrapper over IndexedDB, there are libraries like local for age, a slightly slimmed down version, IDB keyval. There are a lot of other libraries, wrappers over IndexedDB that you can use with service worker. But in ClearTax, we had, so we are building something called ClearTax GST. All of you are aware that, so India had this monumental change of goods and services tax, or GST, a new type of tax, uniform tax for all businesses. Basically, what this product does is all the businesses need to declare, okay, these are the sales that I did, these are the purchases that I did, mainly file a tax return around that. So when you have to declare that, you mainly have like lots of invoices that are created in the application, imported in the application, and so on. So you have your website, but when you're filing a return, you also have other requirements where you might need some enablement from the native layer. So for example, if something that is available through browser implementations, I can use that in my web app. But if I need to go further, like if I want to file a return, I need to digitally sign that return file that I mainly submitted to the government. We also want to explore and pre-fill a lot of data for the user from other government sites. If there's no API around, we actually need to spawn a process where we can automate a lot of scraping from the browser. So we can spawn a browser thread, and basically we can get data from other sites. There are a lot more other opportunities for us where we can actually get in live data from other ERP systems and so on. So sometimes if those applications are native applications, then we need to have a process which basically listens to them over a socket and relays that to our web application. So given all this, it actually becomes a little tedious when you have to always ensure that you're wrapping around your data with a response object and passing it along. Sometimes you need a lot more than that. So, but ideally, if you see whatever data you're writing, it's more closer to the data model that you'll use to post your REST API, to your backend API, right? So if you can persist the data store that you have, if you have a centralized data store object, you can map the data model accordingly to it. And we use some Redux, so this mainly maps to the Redux store for us. So there's one good library around this for persisting Redux state object, which is called Redux Offline. So there are other libraries. There is another library called Redux Persist, which allows you to basically persist your Redux state object, store object into IndexedDB and back. So it basically, whenever there's a change to the Redux store, it stores it to disk, and automatically it gives it back whenever you're rehydrating your Redux state, right? So Redux Offline, over and above that, it creates something called an offline subtree of data. So whatever like whenever your application is offline, Redux Offline mainly seamlessly takes care of putting your data in a separate subtree, and then it manages something called an outbox, which is like your queue to be used whenever you have to sync the data back to the server. Basically persist it back on your backend server, not just on the local hard disk, right? So this essentially is a lot easier with Redux, mainly because being the reducers being functional in nature, you can get from state A to state B through some time traveling, or if you can replay the actions accordingly. So in the crux of Redux Offline is mainly that, where it sort of allows you to time travel through the offline subtree and push the data back to the server, right? Little snippets of code from Redux Offline, how you can use it. So you need to basically import something called an offline object from Redux offline. You can use some default config or something that you can always provide as an offline config. So whenever you're creating your store, so use the reducers, then a preloaded state if something that's the dump coming from the server. You need to basically use the compose function, apply your middleware. So one of them is the offline object from Redux offline. So that is how it hooks on to your Redux store. And sort of, this is mainly what you need to do to persist your data. The other thing that you can, in your actions, you can actually, per action, you can also define what needs to be, some meta information you need to provide to this library. Like if offline, what should I do? So you need to basically give what is the effect that you want to add. You can customize something there as well. So it also uses this concept of commit and rollback, where like if it's a success, how you need to commit it, and if there was a failure, how you need to handle it, and so on. So this is effective. I'm not going to explain the whole thing. You can read it in the link, Redux offline. But yeah, one thing is that this is mainly all in memory, and you need to be careful how much data you're actually pushing onto your Redux store, right? So when this comes as a limitation for your web application, you need a lot more persistence and a much faster offline-online sync. You can use something called PouchDB. Okay? Anyone who has used PouchDB here? Yeah, very few. So this is mainly a JavaScript implementation, a library which mainly uses the CouchDB protocol so what this does is it stores the data locally. For browsers, it mainly uses IndexedDB or, for example, probably WebSQL for Safari and so on. And whenever offline, it stores that in an IndexedDB, and it actually computes the change logs that are necessary, and it uses the same CouchDB protocol. So if you have a CouchDB instance on your backend, you can actually, once it comes online, it gets synced. So this is especially useful when you have, say, for example, you have a Google Doc that you're editing. Multiple people are parallelly doing edits on the document. So from the server, it's synced. And once you come online, the server pushes the data to your PouchDB. You get the newer updates. And also, whatever updates you've done is pushed onto the server. So this way, this is much more easier for you to manage a lot more syncing that is required. The other major application that you can think of for very fast syncing is web WhatsApp. So basically, it queues up all your offline messages, and as soon as it gets online, it syncs up and also fetches the newer messages once the user gets online. I mean, it may not be internally using PouchDB as such, but this is a similar mechanism that you can relate to very easily. So for using PouchDB, you need to mainly import PouchDB wherever, like you can do this in Node as well. So this is something that will be very useful whenever, like the case that I mentioned, where you also need to, you have other sources of information apart from your REST API, like some native processes which you need to communicate with. So separating it out of your application and your app always talking to PouchDB for the data that it requires. I mean, apart from things like authorization, which will be your REST API and on the server. So this will be a lot useful if you're going that route with an Electron app and so on. Otherwise, also you can use it effectively on the browser. You need to be just aware of the size limitations. So yeah, you need to initialize your PouchDB object that you import with a DB name. You can store data, and you can listen to an on-change kind of event whenever there is a data change in the DB. Right? Whenever the sync happens from the backend, etc., you basically get you can give a callback and listen to an event, and that's how you can actually, if you need to hook onto it and have some user action for that, you can do that. You can, as I said, you can replicate this on the server with with the URL of your path of your CouchDB instance and so on. I mean, it's not necessary to use CouchDB as such. You can use any database that uses the same CouchDB protocol. So one thing that, given that we are having so many offline data creation, so much offline data creation, at what point does your browser crash, or at what point, till what point can you stretch, right? So roughly this is something that I just copied from the Google developer site. So Chrome mainly allocates about 6% of the rest of the free space. For example, if you have, say, 60 GB of free space on the hard disk, then in 20 GB, there is a percentage of it that is allocated to your domain and so on. Firefox earlier had a hardcore restriction of about 50 MB, and then they were a little liberal, given that more and more applications are going offline first. So it restricts the space to about 10% of the free space available on the hard disk. Safari has a hardcore restriction of 50 MB. IE has IE 10, mainly where IndexedDB is working, is like about 250 MB. On Edge, there is a little complex calculation. It's available on the but overall, like if you have like 8 GB of free space, you get about 10 MB, and accordingly it varies based on the like mainly for phones. If the storage size is 8 GB, it is 10 MB, and it varies as like 32 till 32. There is another limit, and over and above that, there's a percentage limit and so on. But what if you need to? So I mean, if you store all the data through one of these mechanisms, and once you reach this storage limit, basically what the browser does is it clears off your cache. This is not something that is ideal, mainly because it can be okay, you can live with it in some cases where your data is not so critical, but especially in cases where a business is uploading, creating invoices in your website, and if the data is lost, it's a warning for you. You can't have that. It's because users' data is most critical for you, and you can't lose it, right? So there is something called Quota Management API that allows you to check how much storage is available, mainly like how much your domain is using. And if you're reaching the limit, you can basically warn the user and probably stop all further offline data creation in your web app and so on. Right? So this will allow your users to ensure, okay, their data is not lost, and they'll also ensure like they are going online to sync the data and so on. So you can put the messaging across for your user, which can be very powerful in this case. So this API is, the browser compatibility is not yet there. So it's implemented Chrome 55 onwards, Opera 42 onwards, mainly because they use the same Chromium engine. So you can, if you're using Chrome, in Chrome you can have this navigator, WebKit persistent storage, and query usage and quota. You can have your callback, you can give your callback there, and accordingly handle your application logic and messaging for the user, and so on. So yeah, we've mainly looked at, I think it was slightly sooner, but yeah, this is the end of like what I wanted to discuss about what are the various methodologies in which you can deal with data in an offline mode. Most of us use our data, so for most of the use cases, slapping a service worker should be good enough. But yeah, whenever you have write-heavy use cases, and based on your product, you might have to have a lot more other strategy, other storage mechanisms that is required. So yeah, that's it. Any questions? Yes.
Okay, hi Santosh,
Hi.
great talk.
Thank you.
So I just want to ask you this, like, are there any specifications like what should be offline? So I'm asking this because, an user has done some sequence of unauthorized operations, and once you sync it, you can't just show the user like, you're unauthorized 20 times. or multiple times, right? So any specifications on what should be offline?
There's no general spec as such. That is something that is application specific. For example, say you're offline, and when you get online, your session is essentially expiring. So at that point, whatever data you've created offline is still going to be there. You're not going to delete it yet, right? So you need to make that extra, okay, you probably redirect the user to login page. Once they log in again, then you can redo this action. So that is something, that is how you can wire your application logic so that it ensures there is authorization and authentication done before any offline sync that you automatically do. So this is something that you should ideally have on your server side, on your REST API as a request filter where auth is required, and if there's a 401 thrown, then you basically redo the log authentication step and so on. Does that answer your question?
Okay, then, if session is going to expire in half an hour or something, even if I do an offline now, it's a waste, right?
Mm-hmm.
So once he logs in all my...
So the data is not lost, but if he has logged, and of course, like whenever you're storing the data, you need to ensure that you have a user ID associated, user ID encrypted, some ID that is associated that you store on the locally, because if the session is expired and some other user has logged in, you can't use this data, right? So one thing is like you can just clear off all the data that is required, but yeah, you should always. But usually, again, like depends on the use cases. In general, there are not a lot of use cases where on the same device, a lot of people actually create, like multiple users log in on the same system. There can be use cases where probably you need to do something else there. So probably fully native where you have a lot more security restrictions. On the web, it is getting implemented a lot more, but probably not. Yeah, not yet. Yeah.
Thank you.
Thank you. Yeah.
Hello. Yeah. Jay, I'm here. No, here.
Okay.
I'm right here.
Hi.
Yeah. Hi. So how does it differ from Meteor's DDP protocol, what you just talked about?
Yeah, one of the things in Meteor is, like at some point when, say you're using Meteor is good for slightly smaller scale applications where like the automatic sync, I mean, it is a great library to use whenever you want a direct sync with persistence with the server and so on, where the protocol is already in-house, like available in the library. But at some point you need to, like if you can't scale a lot with just Meteor. Like at some point you'll have, like as you grow as a product, you'll have a lot more users coming in. You need to scale things differently. So your REST API, the whole platforms that you have in the backend, they'll be all using separate systems. So at this point, like Meteor will limit you to scale mainly. So you can have a lot more platforms which are built for scale depending on what the usage is and so on. So that way, the binding thing is REST API, REST protocol. So in most cases, so that's where this is really, really helpful.
All right.
Yeah. Yeah.
Hello. Yeah.
Hi.
Yeah. So as I know, this PouchDB works with CouchDB on your server, right? So now just imagine that I'm already having a SQL server or already DB server is already set up, but I again have to write a wrapper or a middleware in front of my server to which PouchDB would sync, and then again that CouchDB has to sync with my server.
Yeah. I mean, it's not very straightforward, but it's not very ideal to have. But in cases where your offline usage is going to be a primary use case, I'll just give you an example of the same GST application that we built. So all the like businesses, there are lots of POS systems where when say you go to a departmental store, invoices are created in a separate system, and probably they are not connected to the internet, and it's offline, and that is critical data for me. Then it actually makes more sense if that is critical data that I cannot lose. I need to implement this, but otherwise you need to. I mean, the other things that you can do are where if your offline store is also heavy, And you need to basically, you can use Electron and you can package your web app into a native application. And since you have control in the native layer, you can have your own local DB replica kind of thing. Okay?
No, so what my question is, like, I imagine that I'm already using PouchDB on my client side. Now, if I want to sync all my data to my DB server, right? But I have to sync it with the CouchDB, then again that CouchDB will
I mean,
directly
like
talk
this,
to the server.
I mainly suggested PouchDB mainly because it's much easier for you to sync very fast, and the changelog computation, etc., is done well in that protocol. But again, that logic is not something that is difficult to replicate. I mean, there are already lots of libraries available for other storage, backend storage, DB storage systems. So, say for example, you have your native Electron app, and you can probably push Redis there, and you can have a Redis cache on your client side. And you can have your application logic, which reads from the local Redis cache and updates your backend accordingly. So some transformation layer you need to write. So that is something that you can do. Yeah.
Check. Hi, thanks for that nice talk.
Thank you.
I'm just curious to know how, what's the strategy you deploy to handle errors in terms of like maybe validation error or data sync error? Like when you have data conflicts, you have two devices.
That's actually a brilliant question. So if I'm creating invoices offline, I can't validate all of the data that goes into an invoice completely client side.
Right.
So whenever you're syncing online, there needs to be an additional step where during the sync, okay, you push it to an API which responds with, okay, these are your validation errors. And depending on your application, you can probably have some extra user action that needs to be done during the sync process. Say you have uploaded some code of, say, an item in the invoice, where there is a huge like the number of codes which an item can have are like probably in lakhs, which you cannot store on the client side. So that needs to be done from whenever you're syncing with the server. So at that point, you need to have a flow where you actually, like wherever, if you're using a REST API to push your offline data for syncing, it needs to return, okay, these are the validation errors. And you have to take the user through a validation correction flow before ultimately that invoice, the offline data gets into your system.
So you delay.
And it depends on your product, but yeah, that is something that ideally one has to follow, where there is a validation step the user has to do when the sync happens. Say if you've created 100 invoices, out of which 10 are not valid, then basically the rest of the 90 can be, whenever you sync, your server can accept the 90 invoices, but for the 10 invoices, it can give, okay, these are the list of validation errors for these 10 invoices. So I need to basically list down those, okay, these are your 10 invoices, you need to, they have validation errors. They can probably recreate or update that invoice, which can be synced when they're online and so on.
So how about data conflicts? Like, as a simple example, say you have a note-taking app, right? Mm-hmm. You created that got synced. Now you're on two devices. You edited that node in one device, and then the same node, before that got synced up, you changed that node in another device.
Right, yeah.
Same account.
Correct, yeah.
How do you handle that? I mean, what's the strategy you follow?
So the collision strategy that, so basically when you're syncing, there is a collision of data.
Right.
So at this point, one thing is like how much can you auto resolve that collision on your server side? That is something that you can think about. Something like how GitHub does, like when you're merging code, what happens. Similar to that, you can have an auto resolution path. But if it requires a user action, then you have to have an extra step when the sync happens and there is a collision of data and so on. So I mean, you need to design your product usage accordingly for that. So it depends from one product to the other.
Okay.
Yeah.
Thanks.
Cool. Thank you so much, Jeff, for a wonderful piece of information for us. And I think we should welcome our next speaker. Sanket, can you please be on the stage?
Does this work? Yeah. There's some problem. Third talk since morning, huh? Already sleepy? That too on a Saturday morning? All right, I think we have the tea break after this. So my topic is a basic one, I would say. It's not too much of science, data manipulation, big data, and all those things. It's pretty much on the lighter side. Yeah, to the user, the interface is the product. I don't know who that guy is, but I found this really useful because it went really good with my talk. So for the users, it doesn't really matter what technology you're using. For them, it doesn't really matter if it is a native app or if it is a hybrid app, if you're using AngularJS or React, nothing else matters. For them, what matters in the end is how the product feels in their hands, how it looks, and what is the use case like. Is it actually solving the problem what they want to, right? So, and that brings me to my topic of the day, building beautiful user interfaces in React Native. Before going forward, I'm Sanket. I co-founded a company called Geeky Ants. It's right here in Bangalore. And we are better known with our product, which is an open source solution called Native Base, which is a UI component library for React Native. And we have been contributing to React Native a lot. With Native Base, we have got good recognition. I think something is getting cropped off. Let me just try. I think this should be good. Yeah. So we contributed to React Native in its early stage, actually, when it was launched for Android. And then we came up with this library, which I'll be talking later in the future slides. And yeah, moving forward. So what is React Native? So we know what is Angular. We know what is React. So React Native is a JavaScript framework which can be used to develop cross-platform mobile application. You can use the same code base to actually develop apps for Android and iOS. And also, we have unofficial support for Windows, and we have the support for a few other platforms as well. And the good thing about React Native compared to other technologies, the first thing is that it's JavaScript. If it is JavaScript, and since we are web developers, we come from that background, we can use the same learning of the language and apply it to now develop mobile apps. And these mobile apps, you can actually, they're purely native in terms of the user interface. So the second point is React. If you have any idea about, or if you have ever worked with React, you can just use the same learning as the paradigm says, learn once and write anywhere. So if you know React, you already know 80% of React Native, and you can easily hop on to mobile application development, which actually we did. And then we have cross-platform support, like it works for Android, for iOS, and again, Windows and all those things. The performance compared to the other technologies like, if you see Cordova and Ionic, the performance of React Native is really good because it actually gets you the native user interface. So if you use a tag inside React Native, it actually compiles to the native code. It runs in the native code, actually. So the performance is really great with React Native. And last, it's backed by Facebook, so you can trust it, that it's going to be around for a while. And we have been betting on React Native a lot, and it's, the journey has been amazing. And the community, like we have companies like Expo, Microsoft, CallStack, they have been contributing a lot into this technology because we need a solution, right, which just works cross-platform, which is easy to develop, and which something anybody can understand. So the community is really great, the React and React Native community altogether. All right, so a usual workflow when it comes to product development or you say mobile app development, it usually has few stages. The first one, you come up with an idea. An idea could be like, okay, I want to build this which solves this problem. And then you would go ahead and try to design that. Maybe on a piece of paper, you just go ahead and draw the wireframes. Or maybe if you're good at tools like Photoshop or Sketch, you would go ahead and design it on the tool. And then you'll share it across with your friends and get some feedback. The third piece is you'll convert these designs to something which makes sense to mobile devices. So you'll convert these designs to something like tags, like view, text, and all those things. And as a next step, you'll implement the business logic implementation into this. You'll wire it up with API calls and do those things. And after these phases, actually, you'll need to put it on production as an app in the Play Store or App Store. But this is the usual flow, how you come up with an idea, and then you end up developing your app. I'll be talking mainly about the UI development part of it and touching a bit of the design part, because UI development and the design principles somewhat go hand in hand. So that's right, yeah, my topic is building interfaces in React Native. So what are the hard parts of building UI for mobile in general, not for React Native? We have problems like if you come from a desktop or web developer background, you see the screen size drastically decreases, and you have to fit in a lot of things there. You have to maybe you have to split the screens, which was on the desktop, into like 5, 6 different screens into steps on mobile phones. So the screen size is a problem, and then you have to keep the user on a sub-part of your app, which is a little tough. And then we have multiple devices to support. We have devices like low-end devices and smaller screen size devices to large tablets, which also fall under this category of mobile phones or mobile devices in general. So you need to have some sort of responsive design and all those things. And then we have design guidelines by Google and Apple, because these two platforms are the most famous ones, and they have different principles. Like Google came up with material design, and Apple came up with Cupertino design for iOS 9 or 10, which are similar but not the same. You need to consider both the guidelines in terms of dimensions, in terms of interaction, in terms of color, and all those things. So these things make actually mobile development a little difficult, but we'll see how to solve them in the next slides. So to start with, let's just build a simple button component using React Native. If you have ever worked with React, this is very similar. We just change few tags. So this is the design. We need to design this button, which has this text awesome button and a blue color background. And later in our code, we can use this with a markup like my button, and then we can pass in title whatever we want inside that. Pretty straightforward, nothing fancy. So the first thing what we do is we split or we break the component down into something which can be mapped to React Native. So basic, we have a text, we have a box which is blue in color. So 2 parts, caption and the box. This can be directly used with 2 tags which is available in React Native called text and touchable opacity. So you can just import text and touchable opacity from React Native and then build your component. So let's just do the markup. I hope it is readable at the back. We have a class button or my button, which extends from React.component, and then we have a render function. Render functions actually returns a couple of components, which is nested. We have touchable opacity as the root level component. Inside that, we have text. And then inside that, we have this.props.title. So whatever is passed from the outside is just used here inside as props. So we've got something on the screen. We've got just plain white background with black text. We need to style it. So you can style using style prop for touchable opacity and text, which is, again, a prop available on the native components. It is much similar to inline styling for the web, but React Native does not have anything like global styling or context-based styling, so you have to follow this paradigm, which is a little pain, but let's see. We have a style object, actually a couple of them, one for the outer touchable opacity, and then we have one for the text. So we have things like background color, padding because we need that gap, and then border radius because we need rounded corners. For the text, we have something similar. We have color white, and then font size. So it just works fine. We've got our button component, and this is the output. And if you don't like inline styling, you can actually move them out. Since it is just plain JavaScript object, you can just define it at the top and then reference it in your render function. Pretty straightforward. And we have stylesheet.create function, which is provided by React Native code, which makes the styles cacheable and the renders faster, actually, because these things are cached at the native layer. So if you reference it again, it just uses a number to reference that. So it's pretty fast using this way. And this is the final output. This is a simulator. We have the button at the center. Pretty basic. I know it might be boring for a few guys, but I needed to start from this. OK, next. So it's not just buttons, right? You have many different components in your application. You can have a header. You can have a footer. You can have tabs, and a lot of different things. So let's take another example. So we have this screen wherein we want to build 3 sections. We have header. We have content. We have the footer. And so let's just do the same thing like as we did in the last one. Let's try to split or break it down to the components. So we have 3 components. We can see header, content, and footer. And they have these properties. The header, it's fixed in size. The height is fixed. It does not change depending on the device. It does not scroll. So if you scroll, the center part scrolls, but the header remains there. And it has a background color and white text. For the content, the height is fluid. We don't have a fixed height for that. So it depends. If you're in landscape mode, it just squeezes. If you're on a bigger device, it just increases. So it's fluid in height. And then we have the content scroll. So whatever we put inside the content, it should scroll. So let's try to find the matching native components, which is provided by React Native. So the header can be implemented by view. View is a tag which is much similar to touchable opacity in our last example. And then we have text inside that because we need that header text. Unlike HTML, we cannot directly use text here. Whenever you want to introduce some text, you have to use this text tag. This is much similar to span on the web. Next, then we have scroll view, which maps to the center part of the app, which is a view, but it has this scroll. So it is much similar to overflow Y scroll of web. So you can just directly use this as scroll view. And then the footer is very similar to header. And then we have a couple of other things. If you see it from the last example, the color of the status bar has also changed from black to white, which is specific to mobile devices. And then we have the button component, which we are just reusing from our last example. All right, so let's try to build it. So we again go ahead and create a class which extends from react.component and then render function. Then we return a view, that is the container view, which has 3 children views. And each of the view actually maps to header, content, and footer. Pretty straightforward. And then we have text inside that. But we don't have any styling as of now, so we can use the same inline style and just style it. So I have just created stylesheet.create, and then we have like container, header text, content, footer, and footer text. And these objects will be mapped to the styles of each of the component. All right, so for the container, we have background color white. For header, we have, again, red color and white text. Pretty simple, nothing fancy. One important thing here is that the objects, what you see with, the keys, what you see with the objects, the style objects, they are actually mapping, which Facebook has done for us. So when you say background color, it actually maps to the background color of different platforms, which might be something else there. So this is a one-to-one implementation of CSS-like thing. This is not real CSS, but it is an implementation of CSS. All right. But in the last example, you see it's at the top. Like, we didn't position the elements correctly. We need to center align things. We need to move the footer to the bottom, and the content needs to be fluid. So how do we position elements? So we have a very nice flex box, which you might have heard about. So the same thing is copied here in React Native. It is similar, but not exactly the same. So the basic terminology as it goes in Flexbox, that we have a wrapper container, and then the items inside that can be called as item. So we always use these two terminologies and a set of CSS properties to assign or position our elements. So for the container, we have the first three things, which are flex direction, we have align items, we have justify content, and for the items, we have a few other like flex, align self, and aspect ratio, which we'll just see it here in the GIF. So for the container element, you can just go ahead and pass this CSS property called flex direction, and then you can pass the value as row to align the items from left to right in the row, and you can say it as column from top to bottom. That's the way how we do it in normal web CSS. And then we can also reverse it. Like, if you want to reverse the order of your items in a flex box, you can just use column reverse. So the first element starts from the bottom and it goes to the top. And same thing happens with row. Row reverse, you can use it. So it's just like column, but it starts from the right side. And then we have align items. So we saw how we can order our elements, and now we can see like how we can align the items. So this is like perpendicular. Like, if it is row, this align items actually decides how it goes on the y-axis. And if it is column, then it goes on the x-axis. So it's perpendicular to that. So we can say, okay, align items. We have examples like flex start at the top, and then we have flex end, which goes at the bottom, and then the center, and stretch. Then we have justify content. This decides where exactly all the elements are placed, not the order, but how they are placed as a group. So we have examples like space around, equal spaces around all the elements, flex start at the left, flex end, and then we have flex center. All right, and then we have few properties for the items. We have align self, which is passed for the items. So if some of the elements in the flex box need to specify some specific alignment, they can just use align self and align self flex start and flex end, the same values as we had it for align items, but this does not obey the properties passed down by the container. That's the whole idea. And then this is very important. We have flex property, which always goes with the items or the children. This decides the height or the size of the children items. So if we have like a couple of children, and if you want them to be equally placed, equally sized, so you can just pass flex 1 and flex 1 to both of them. It goes like 50%, 50%. And if you pass, say, flex 1 and flex 2, so it uses that ratio to decide the height of the children component. So the second child, that is flex 2, will be twice as big as the flex 1. And then you can just decide. So it's much like percentage and something similar. So let's apply this to our example. So we saw that our previous example was cluttered like this, and we need to increase or bring the footer down and increase the height of container. So we can pass flex 1 to the container element. But there's a catch. This flex 1 was not for container. It was for the items, right? So here flex 1 is applied to the container, and the screen itself is acting as a container to that element. So flex 1 actually brings everything down. All right? And then in the header, we can see to bring that header in the center, we can use align item center and then justify content center. For the status bar, if we need to change the color of status bar, we have a component for that in React Native. Just use the status bar, and then bar style is light content, so it makes that white. Yeah, and then we have these platform guidelines. So let's get back to the height of the header, and let's see what we used there. Whoops. Okay. So for the header, we used a height 56 pixels. So you guys must be thinking, what is this magic number 56? So the thing is, we have different guidelines by Android and iOS, like Google and Apple. So Google suggests the height of the header or the toolbar should be 56 pixels. So we have used that. And we have a different height for iOS devices. We have it 64 for that. But we are running this in an iOS simulator. So this is not the correct practice to do it. Ideally, on iOS, it should be 64. So how do we solve this problem? We have to use the same source code, and it should work for both the platforms. So this is the guidelines by Apple and Google, where we have like different dimensions and color and the font style and all those things. So how do we accommodate this in our source code? Because the code which we wrote works well for Android and iOS both. So we can put a conditional like this. We can say platform.os, if it is equal to iOS, then use 64, otherwise use 56. As simple as that. And you don't have to rewrite the entire code base for two different platforms. But the UI is more than just rectangular blocks, right? It's not just bars and all those things. Sometimes we may need icons. So we have this package by the community called React Native Vector Icons, which provides a bunch of around 3,000 plus icons, which you can use. So say, for example, if we need this guy on our screen, in our app, so we can just import icon from React Native Vector Icons, and then say icon name is equal to something. Icons are not the default ones which come with React Native, so you'll need an extra bit of React Native linking, which actually links the native libraries to JavaScript engine. So icon name is equal to iOS person, and we have a bunch of other icons which you can use, like back button, arrow button, and all those things, you can use it. And sometimes we need custom shapes, like circles, like graphs, like we can have curves, and all those things. So how do we do it? So we have React Native SVG available for that. This is again by community and not officially by Facebook. You can just install it in your project and then use very similar to SVG. And this is not 100% or not even 50% implementation of SVG, I would say. This more or less tries to imitate the APIs of SVG. So if we want a circle and a rectangle, we can just use SVG width, height, and then pass circle with different values, and then rectangle with different values. But sometimes we need, say, a bunch of different buttons. We'll need, say, a green button for success response, or maybe red for something negative. We might need tabs. We might need card. We might need card swiper, because people don't really match with me on Tinder. I may need my own app. And then a lot of different things. We may have fab icons and other things. And that brings me to this conclusion, that there is a need of generic set of UI components. You won't go and develop button for every project you work on, right? You will need some set of predefined components which you can use across your multiple applications. And that's the reason we developed Native Base. So Native Base provides you all these components which you don't need to develop by hand for each and every project. Just install it and start using it. For example, the same example where we have header, the icon, and the content, and all those things. You can just go ahead and import container, header, text, left, and all those things, and just use it in your application. And the screen looks beautiful. Also, the code looks beautiful. We don't have view style, view style, view style. We have something which makes sense and which is readable. We have container, we have header, left, title, button, text, and all those things. And you get the design and the guidelines followed for Android free. So the exact same code renders like that on Android on the right side, and the same exact code renders on iOS or Apple devices like that. So we have done the hard work for you, the heavy lifting for you. We have followed the platform guidelines, the colors, specification, and all those things. It just works well on both the platforms. This is a kitchen sink app. Maybe if you want to give it a shot, see what are the components which we are providing. You can just go on nativebase.io and check the app. All right, so what are the takeaways? First, building UI in React Native is very similar and easy, like web. And the second, Flexbox is a must if you want to build user interfaces for React Native. So the learning of Flexbox is a must. And then platform guidelines is something which you must follow, because I have seen Apple rejecting apps because somebody didn't follow their guidelines. And fourth, which is sort of self-promotion, but you can go ahead and use native ways to solve your problems. That's all for me. Thank you.
Do we have any questions?
I think we have 5 minutes, so we can have questions.
Thank you for that.
Yeah.
So yeah, at native base, I just have a question. So with regard to native base, so as Android updates their versions, right, they would have different sort of styling guidelines for different versions of Android. So how are you planning on managing that, or how are you currently managing that with native base?
We haven't faced anything like that at the moment, like different versions have different guidelines. We just followed the material design guidelines, and it's pretty much same for tablets and phones. So, and if we have that in future, then we'll put conditionals for that as well. That's not a big one.
Okay,
yeah.
Thanks.
Hello?
Yes.
Yeah, nice talk.
Thank you.
I just want to learn about native base. That by default with React Native, you have these components, view and style, the native components, right? So you have built on top of that, or you have incorporated them, and with your libraries providing container, header, and all those, when we render it, it will render exactly the same like views, those native UI library.
So we have styled the native rectangular blocks to look 100% like their guidelines. So if you use header, you're not actually using the Android toolbar component, but it 100% matches with the design. But at the end of the day, it's built on the native layer using the native components itself, but low-level native components.
So you are not, behind the scenes, you are not using those native UI components, but you are built on top of them.
Yeah, but the building blocks is again the native UI.
Native UI.
Yeah.
Okay. Thank you.
Thank you.
Hi, Praveen here. So we know that Android market has a huge fragmentation. There are different devices with different aspect ratios and scaling, right? And then there is iPhone market. So how is that being addressed here?
So I think that's a similar question what he just asked. So yes, the guidelines what Android has, I think post Android 5 or 4, they made it a must to follow material design guidelines, and that does not really change much from all the versions and all the different sizes. So even for the tablets, the height of the header you see is the same what you see on mobile phones. It's not much different.
I'm asking more in terms of when you are developing an Android application, right? You have all these assets which are being made for MDPI, HDPI,
yes.
XDPI,
Okay,
right?
yeah.
So how are those things handled?
So those things are internally built with React Native itself. So if you require an image, so it just looks what resolution and what DPI or DDI the device has, and it picks up the corresponding image. We have plugins for that, and I think it's internally supported with React Native.
Thanks.
Okay.
Hi, it was a very useful info for beginners like us.
Thank you.
So my question is, I'm new to mobile app itself. So how is the resolution based? It will be how it's a media query or how it thinks.
I didn't get your question. Sorry.
So we are using only CSS, right?
Yes.
For
Mm-hmm.
every buttons or something like that. So how it is different devices resolution like that?
So different devices, we have Flexbox, and Flexbox is again fluid, so it just works all by itself for different sizes. But still, if you need different styling for different sizes, you can always put conditionals, because at the end of the day, it's just JavaScript. You can query the screen size and add your own conditionals.
Okay, we can use media query, same media
It's something
query.
like that, but it's purely in JavaScript. Okay. You can just query screen height, screen width, and add your conditionals in the stylesheet.create statement.
Okay, using this, is it possible to 100% native app? It's like that?
There are many apps built on React Native. If you see Myntra app, you might have used it. It's 100% React Native. Facebook's ad manager, the new Skype is built using React Native. So big companies are betting. Airbnb has like 192 screens which uses React Native. So you can use it.
So is there any limitations in this?
Yes, limitations are there, but that really depends on your requirements. If you just need a team where you need the same code base and the same learning of JavaScript, then it's a good thing. But limitation, yes. On the performance side, we do have some limitations. But again, that use case is very small to consider. And if you want to say build a game, you won't use React Native. You'll go with Unity 3D or something else.
Okay, thank you.
Yeah. All right.
Hi, nice talk. Actually, I'm new to React, so I want to ask, like, can we share the code between React Native and React app? Like, if we have a web app and we want to develop a mobile app as well.
Okay, good question. Yes, you can actually share the code, not the UI part of it, because the UI is separate for React Native and React, but everything other than that, like business logic, Redux, reducers, and all those things, yes, you can 100% use that.
And is there any problem that will be faced, like any complications or?
No complications as such. It makes our life easier at the end of the day, I guess.
Okay, thank you.
I think the time is up. Maybe you guys can, yeah, just last question. Yeah, go ahead.
Yeah, sure, last question.
Yeah.
Yeah, this is regarding like, so how are we going to handle like different set of permissions that Android is having set of permissions and iOS is also having set of permissions with respect to hardware. And also like maybe Android doesn't have sort of feature like 3D touch, whereas iOS has that. So how are we going to handle that sort of things with React?
So I think you have two different questions. The first one is how do we handle permissions? So when you create a React Native project, it creates an Android project and an iOS project. So the permissions and all those things, the way you do it in manifest.xml and all those things is actually handled in the same way. And the second question about like handling gestures and all those things. So for gestures, for anything which is a native, it can be easily bridged in React Native because in the end, React Native uses the native libraries. And the community is really growing. We have almost all the APIs which is available in React Native. If it is not, it's just like 10 lines of code. You can just bridge that thing.
Yeah, I mean like iOS totally doesn't have any back button, whereas Android has.
So you need to write conditionals for that.
Okay. Thanks.
Thank you. Thanks a lot. Yeah.
Sure. Super cool, Sanket. Thank you so much for your wonderful talk and sharing it with us. So, yep. Cool. Now's the time to tea break. We are running late by almost 15 minutes, and we know who the culprits are. We started 15 minutes late. So probably now we can break for tea, and let's get back here at 12 o'clock, and then we have awesome talk again lined up. Whoa.
Check, check.
I think we can give 2 minutes to settle down, everyone, and then probably we can start with the talk.
Says 30. Do you want me to reset it? 45.
45? Oh, sure. So I think we are good to start, and welcome, Ram, and we can proceed with the awesome talk. Thank you so much.
Greeting wizards who practice the dark arts of JavaScript. I'm known as Parshuram, and I come to you from the far, far away land of the Pacific Northwest, where the deep blue ocean kisses the great Cascadia Mountains. And I come here to deliver a message. Oh, wait, what? Winter is coming? I mean, no. I mean, it is coming, but it's not coming for a very long time. That was not the message I came to deliver. I came to talk to you guys about JavaScript, and JavaScript typically with like a bunch of other things. Back there in Seattle, I work at this company that's probably a little more into windows than walls. I mean, windows of all shapes and sizes, windows that you love, windows that you hate, windows that sometimes don't shut and just crash. But that's where I work. And if you guessed, I do work for Microsoft. And at Microsoft, I am a principal program manager working on developer tools with JavaScript. More recently, I've been working with JavaScript tools for React and React Native. And I'm kind of passionate about JavaScript tools, and that's why I thought I'll come over and talk about. The whole DevTools space is pretty interesting. Right from when, in May 1995, when JavaScript was invented, the DevTools space has been interesting. When it all started, there was not a lot of DevTools. I mean, the errors were cryptic. It was hard to debug. As you guys say in Bangalore, Solpa adjust madi. That's exactly what the story was. And we are clever programmers, aren't we? So the first thing we did, started using started using alert boxes and displaying all of the log messages and doing watches. To be honest, that was not the best situation. I mean, if you had to characterize it, I'd say we were bringing in not just a knife to a gunfight, but like a banana to a gunfight. It was horrible. It was messy. Anyway, so that's what was happening, and we are all clever programmers, aren't we? We survived that era, and we started becoming good at writing dev tools. The first one that I remember using with JavaScript is this dev tool called Venkman. Venkman is the same Ghostbusters Dr. Venkman. I'm not even sure how many of you are old enough to remember that, or how many of you were even born when Venkman was around. The thing that a lot of people do know and do understand is this other very popular tool called Firebug. Firebug, in a way, revolutionized the way you think and you debug JavaScript. Fast forward it all the way till today, and not only can you debug JavaScript, you have a bunch of other tools, things like live reload, and you write in TypeScript and ES6, and that does transpilation. You have hot module replacement, you have browser sync, you have Redux replay, a whole bunch of those things. And as a result, JavaScript has proliferated into a bunch of other contexts. They don't just run on the browser. And as Francesca was saying, it runs on systems like Node, systems like Internet of Things. You write command line applications with it. You put stuff on the mobile phone, and all of this runs with JavaScript, not because JavaScript is a fast language. It's probably because JavaScript has excellent developer tools. I was going to pick JavaScript as an ecosystem, and I was going to go in and try to figure out what the ecosystem did and how did it evolve. But given that JavaScript has almost 10, 15 years of history, it was hard. So rather than picking JavaScript, I thought, let me pick React Native, and that might be a representative of what happened with the JavaScript tooling. Effectively, this is basically what my title of the talk is. It's called Supercharged Developer Tools with React Native. Now, if the words do not do justice to the title, maybe this image will. And to all the Madrasis in the audience, hey guys, this is hero introduction, no whistle or clap. Adi, good. So, nice. So that's what it is. And if you're thinking of what React Native really is, React Native is a way to develop iOS and Android applications on your mobile phone. The good thing about React, unlike Cordova or Ionic or any of them, is that the app you write actually has native UI controls. So the list views, the buttons, they're actually native and look and feel as if they were a part of the real mobile phone. On the other hand, you still use React, and all the code that you write is written in React. And this React or this JavaScript code runs in a virtual machine called JSC. JavaScript core, which is what comes pre-bundled with your iOS devices. It's similar to what Francesca was talking about in terms of V8. JSC is yet another JavaScript virtual machine. And the way this entire structure works is JSC starts sending instructions to the native part of the world, and then you get like events from the native to JavaScript. And this interaction ensures that it's not like a full screen web view. This ensures that it's like super performant. Now, I also believe that Sanket showed you a pretty good introduction of what React Native is. So I'm probably not going to go into every single aspect of React Native, but when I was talking to you guys yesterday, I did hear that a lot of you had not really done a lot of React Native. There was some React experience, but not React Native. So let's just take a quick summary of what React is and React Native is. So here's a very simple React class. In this, you have like a state, which is a timer. You have a render method, and then you just mount it on the DOM. This is like a pure, super simple React application. It basically displays something on the website. Now, the philosophy of React Native is, hey, why should I worry about divs, and why should I worry about the DOM, right? I mean, if you look at this code, this is where my DOM coupling comes in. What if, instead of calling it DOM, I called it a view? Now, view could be a div on your browser. It could be a native UI element on the Android or the iOS device. And that's basically what React Native does. It kind of replaces all of your DOM instances with something that's native or mobile specific. And then rather than mounting on top of a DOM node, you mount it inside an application. And that's the beauty of React Native. And that effectively says that if you know React, you're almost there. You're more than 90% React Native developer. And writing a mobile app is not that hard. Now, in fact, the whole development process is also very similar to what you do with React. Just like in React, you have Webpack and Rollup and Gulp and Grunt, you have a packager. And this packager, you just start it up on your command line, on your dev machine. And this packager basically takes up all the source code that you have, bundles them together, and sends it to the JavaScript core. And the JavaScript core basically interprets it and sends instructions to the native UI land telling, hey, go draw a button from this location to this location, or go draw a view from this location to the other location. Now, because this is JavaScript, it also leads to a whole bunch of interesting scenarios. I mean, you know how if you write Android code like in Java, or if you write Objective-C, even for a small change, you have to recompile the whole thing? With React Native, and because this is all React, React already does live reload. You get the exact same benefits of React in React Native. You don't have to recompile your entire application. You just do get live reload out of the box. Debugging is also very, very similar. Now, all you have to do is, hey, it's a JavaScript engine. Why not attach directly to it, right? There is a slight problem there. The way JSC is compiled for Android, you really can't attach a remote debugger. And that's a problem. Now, I see that a lot of people here haven't gotten the intensity of the problem. So let me try to invoke the Amitabh Bachchan voice and try to make it a little more serious. It's like saying, अब मेरे पास native UI है, मेरे पास React है, मेरे पास bugs है, तुम्हारे पास क्या है? And if you ask a web developer, you know what they typically would say? They'd say, मेरे पास Chrome है. And that's the power of like the whole React story. So, you know what? JavaScript runs in JSC. Where else does JavaScript run? On Chrome, right? What if, instead of running during the debug mode, you switch from running JavaScript on the JavaScript core on the phone to Chrome through the packager? And this is how React Native debugging works. I mean, effectively, I've told you what is in terms of React Native at this point of time. And what does Chrome have? Chrome has developer tools. You will be able to use the exact same developer tools with Chrome, like as if you're building a website, and you will be able to debug your mobile phone applications. Okay, JSC runs JavaScript. Chrome runs JavaScript. What else runs JavaScript? Node.js, right? What if we replace Chrome with Node.js? Now that's interesting, and I'm not replacing it because I'm at Microsoft and I have to replace Chrome because I don't like Chrome, but effectively, you can replace it with Node. And Node has developer tools, and you can attach developer tools with Node, right? Again, what if? Now, Node has V8. That's still kind of Chrome-ish. What if you replace Node? Again, I'm not saying this because I'm at Microsoft, but what if you replace node with node chakra. You would get the exact same story. And I mean, jokes apart, I'm actually doing this for a reason, and I'll show it to you in a demo. But jokes apart, what if you replace node with node chakra, which you actually can? And once you do this, the capability that you get is something that's called time travel debugging. Time travel debugging is effectively the ability to not just step forward with your statements, but step back or do reverse continue. And I'll probably show you a demo. It's demo time, which means let's play to the demo guards and see if we can send our code backwards. Before we do that, let's actually start with a simpler demo so that I don't fail right away. So what I've done is I didn't want to rely on NPM in a conference network, so I already went to my command line, and I did npm install React Native CLI, and then I said React Native init application name. And what it gives me is this folder structure. Effectively, it has a bunch of JavaScript files. It has an iOS folder and an Android folder. And if you open, like, say, the Android folder, this is actually your native Android application. It has Gradle, it has things written in Java, it has all the scary type checking and all of that. We are not going to worry about that right now. What we are going to be interested in are the two entry points for my iOS application and for my Android application, which is this. And in this case, I do not want to write two separate code syntaxes or two separate files. So what I'm going to do is, in both of these, I'm going to create just an app folder and refer to this simple file called counter.js. And what does counter.js do? It displays a counter and has a plus and minus, and you click it, it keeps incrementing or decrementing. Now what you can do here is, by default, let me minimize this guy. So I've already also taken the liberty to run it because I didn't want my demo to fail yet. So here's how the application looks. And all of these buttons and screens that you see are actually native screens. In fact, if you were to open up Android Studio and open up the UI manager, you would be able to see the hierarchy of all of these as native elements. Like this basically is your com.android.text area. This basically is your Android button, so on and so forth. On iOS, it's the UI button and UI text and all of that. The app itself is super simple. I'm trying to learn to count, so that's what it does. Now, remember I told you about debugging, right? So let me show you what that looks like. Typically, what you would do is you would shake your phone, or shortcut is Command D, and you would say debug JS remotely. What this is going to do is open up a browser, and if you go to developer tools, you can open up index.android or index.ios.js. It has source maps and all of that supported, and you can start putting breakpoints here. And you as a web developer are not going to know if it's web debugging or JavaScript debugging. In fact, React Native also has, so if you have the React extension, looks like I uninstalled it, but if you have the React DevTools, you will be able to do DOM inspection of your native application. I mean, it's that close to developing a JavaScript application. Now, let me close this guy. Let me stop debugging, close this guy, and let me enable this thing called hot reloading. So what I can do is, it's going to load up the whole thing again. Eventually, it's 60, 70%. But here's what I'm going to be able to do. I can, without even changing my application, I will be able to like change colors and styles and all of that without having to reset my state. And that's something that's super unique to React Native, primarily because it's written on the JavaScript stack trace. So I can do this. And if I go a little bit downstairs and say my background color needs to be, save it. Did you see the background color actually change? So let me replace this. So the counter value is like 10 right now. And I'm going to say my background color needs to be, let's say, A, B, C, D, E, F. I save it. My counter doesn't reset. The color just changed. And that's not something that you typically do in like a native application. Thanks to React Native, it is possible. And the final thing I was talking about was remote debugging, or time travel debugging, right? So what you can do is, I've already set up time travel debugging. Effectively, what I've said in my launch.json is, let me just minimize this guy. And what I've said is, instead of using the regular V8 node, just use node chakra. That's all the change I had to do. And node chakra automatically comes with time travel debugging. So if I hit F5, It's going to start up my debugger, and it's going to hit the first breakpoint, and I'm going to just run through this. But now when I'm hitting this other breakpoint, apart from the ability to step forward or step into or step out, I can now step back in time, which basically means I hit this, and I was in this frame, and I was able to go back to this function. And that's actually super cool. You can actually jump back and forth between statements, which makes debugging so much easier. And because it's React Native, I didn't have to change a thing. I just changed my debugging engine or node engine, and it worked. And that was remote debugging. So going back to the slides, I'm sure you guys want to see this GIF again, but going back to the slides, it all looked like magic, but it's not really magic. Let's take a closer look at the JavaScript VM that Chakra does. So in a React Native application, you have a state, right? And in the state, you say this counter is 7 or something like that. If you zoom out a little bit more, what you see is the entire JavaScript context. And Node Chakra has this ability to take a snapshot of this context. And the reason we do a snapshot is because in JavaScript, if you run an instruction, there is no undo, really. I mean, you can't like run instruction and then unrun it, right? So instead of doing it that way, it actually takes a snapshot, runs all the way back to the snapshot, and continues. So let me show you an example. Right? In this case, it's going to run like a bunch of instructions. There might be external events like reading from a file system or network, which is non-deterministic. So it's going to save that. It's going to continue running my code, and this is where my state changes from 7 to 8. And then it finishes running. So at this point of time, my instruction pointer is at this level. Now, what if I want to go back? I cannot go back. I can't unset state in React, right? What I can do, however, is go all the way back to a snapshot, run my instruction, like restore that snapshot, run my instructions. If there's an external event, I do not want to respond to the external event, primarily because it could be, from a click, it could be like a double tap or something like that. So I'm not going to run that. I'm just going to rerun what I already saved. And then I'm going to come back to this state and pause. And that gives you the illusion of going back in time. And this whole mechanism is actually so fast that people are running this on production Node.js application. Now, if it's OK to run it on production Node.js, why not use it for debugging, right? This, in short, is basically the whole time travel debugging part of the world. Now, that's good. We have just started debugging, and we've started developing our React Native application. But with websites, what we do is we don't have the concept of an app store. We do not have to wait for 24 hours or 3 weeks and get rejected and stuff. With React Native, you have the exact same capabilities. What you can do is, once you have submitted the app to the App Store, because it is JavaScript, the next time you have an update, you could send it to your packager, and rather than distributing it directly to React Native, put it up on the cloud. I mean, everything goes on the cloud these days, right? So why not? The next time the app is opened, it can check if there's an update. It can download that JavaScript file and do an eval of that JavaScript to get the new bundle running. I mean, this is pretty much what websites do. This is not possible in native applications, and this is one of the biggest advantages of using React Native today. This effective thing is live reloading or instantly updating your apps. And this is super important if you have critical bug fixes. So if you have a bug fix, for example, all you do is upload that bug fix. It gets downloaded the next time, and you do not have to wait 24 hours for an update that you want to fix. You have another update, you can continue doing that. But here's the other interesting scenario. What if your third part of the code was done on a Friday evening, you were totally drunk, and you messed up something? What you can do is you can undo the change, because guess what? We already had the previous code update, right? So you can do that. You can basically undo and redo the whole React Native application and even start versioning your application. And at this point of time, I'm sure it's almost like writing a website, right? I mean, it doesn't really feel like you're writing a real native application. So it's basically combining the whole web world and combining the whole native world. Now, that's the second tool that I showed you. And now you have done your due diligence, and you effectively have come here. And you have tried to develop an app that you like, and you have decided to distribute it to the App Store. But then you realize that there are multiple devices. Even when Sanket was showing his demos, there were like a bunch of questions about how do you do media queries? How do you test on multiple devices? It's hard. I mean, imagine a world where you have shipped your code, and then your boss, who's probably personified as Gabbar Singh, And to my Tamil friends who do not know who Gabbar Singh is, it's that same movie, where you say, "Na paata kadesi English part of Sholay," that Sholay thing, that's this movie. So Gabbar Singh, if he's your boss, he'll be like, "Areo Samba, kitne phones the?" You'll be like, "There were 1,000,000 phones. You didn't test on any of them, right?" So what do? Well, you can say, "Dude, why this Colaveri? Hold on." What you can tell him is, there is a way in React Native to test it on multiple devices. And let me show you that. So what I'm going to do is, I'm going to stop the PowerPoint slides. And I have an Android phone and an iOS phone. So, or not, I have an iPad and an iOS 7 phone. Wow, that's super long. That's probably iOS 8.5 or something. Like, it's tiny on the screen. It's super long there. Let me just reload this application. I'm going to disable hot reloading. I'm going to reload this application. And let's see, I'm going to also change it to something a little more complicated. So I'm going to change what my app is. Reload, and there you go. OK, so I have like a menu app kind of a thing. And I have it running on 2 devices. What I'm going to do is I'm going to start up a simple socket server. So this is a simple WebSocket server. And I'll show you what it can do, really. So rather than speaking through it, let me just reload these applications. Oops. What was that? Hold on. Sorry, give me a minute. Looks like the internet is not very good, so. Sorry, give me 1 minute. What is the file called? Live coding on stage. Something had to break, right? Reload. OK. Really? OK, so I have two devices right now. Let me just ensure that I'm restarting my server properly. I love it when I have to debug code on stage. It's worse than a whiteboard interview, where there's like one person asking you to like write code on a whiteboard. This is like, what, 400 people looking at how I code. So just a reference for my future interviewers, this is not how I write code. Anyway, so reload. And what I can do is, I will effectively pick up multiple devices, and rather than having to go manually test it, what I can do is, I can click on one device, and the other device is going to follow. We have the same concept on the web called browser sync. React and React Native is written in such a way that you can actually enable browser sync kind of a scenario on your devices. And these devices don't even have to be connected on your like local network or anything. They can just be devices that you have in your hand. I mean, look at this, for example, like, right? So if you see my mouse, I'm only moving it on the iPhone 7, and the iPad is responding to it. And that's purely because of the way React Native's event system is written. The way it works, again, I mean, it's easy to show demos, but the way it's really written is, it's because of React's event system. So if you remove the black box, which is JavaScript core, expand it and see what's inside, the way events are handled effectively is, you have a plugin registry. You have like something that does a response to the plugins, and then it eventually goes through an event emitter to your on-event handler or your on-press handler. What I did was, I wanted to replicate the events, right? So I basically wrote my own event responder, and rather than doing anything, it broadcasts this event using the WebSocket server to the other devices. And this basically is the way I'm able to replicate the whole event on one device across multiple devices. And that makes it super interesting. Now, why am I showing you all these demos? But before I get there, just another thing. I also noticed that there are a ton of people here who are not Indians. I know I did put like a bunch of movie clips. So, like, folks, that's not a representation of Indian Bollywood or Indian movies. If you want to really get the sense of what Indian movies are like, I'd recommend watching movies like Ram Gopal Varma's Aag, or like there's this these awesome heroes like Mithun Chakravarti and Govinda. You should watch their 1990s movie. Or there's Balayya, or there's this great Tamil actor called T. Ranjadhar. He probably is even better than both Bruce Lee and Jackie Chan in Kung Fu. So you should watch those movies. That's a representation. I just wanted to put that away, but anyway. So the reason why I'm talking to you guys about all of this is, if you noticed, through this journey, we have had problems. We have, like a typical Indian movie, we have had ups and downs, we have had twists and all of that. Eventually, the hero survives, right? Effectively, what I'm trying to see is the system itself has a ton of disadvantages. The script is completely flawed. Like an Indian movie, the script is bakwas, to be honest. However, it's the actors or us who make the entire ecosystem good. And I think, all said and done, despite JavaScript's flaws, it is us who come up with these really creative and random hacks that help us ensure that React Native is a great movie. It's a box office blockbuster. Now, the future. Well, to be honest, the future is dark. It's up to you guys to have that awesome idea, to have that next generation idea on how a dev tool can be. Should it be time travel debugging? Should it be space travel debugging? I don't know. And that's the power that you guys have. And that's why it's up to you to shape what the future looks like. That's pretty much all I had. Thank you for bearing with listening to all the rambling that I had to do. I think I still have I did not want to get between you and your food, so I wanted to finish early. It's almost 12 or something. So let's take a couple of questions, and I think we should be good. Hey, before you do the question, sorry, is it okay if you say your name out aloud? I'm here to meet people so that I want to know who you are. So you can say out your name, but if you're shy, you can call yourself, say, James Bond, or even like Sanskari James Bond, like Bahubali or something, that's fine. Just say what your name is.
All right, my name is Ungmating Chaiza. So there was one problem we had recently with React Native, in that when we enabled remote debug, and we were running it through Chrome, it was working fine. But when we disabled that, it just wouldn't run in the emulator. It's just not getting compiled. And it had something to do with typed arrays in JavaScript. So do you know, stuffs like that don't work? Maybe it works on Chrome and does not work on React Native, like just using the whatever comes with React Native. Like, any checklist that we should be aware of? Because that was a pain, and we figured it out the hard way. So any idea about that?
So I think the crux of the question there is, when you're debugging, you're running it in Chrome. But when you're not, you're running it in JSC. And to be honest, JSC and V8 are totally two different virtual machines. Their capabilities are completely different. And at this point, and that's also the reason why the Facebook guys effectively compiled JSC for Android also. Technically speaking, like native script, they could have just picked up V8 for Android and done JSC for iOS. The reason they didn't do it is because they wanted consistency. And I think the short answer is, unfortunately, no, there's no simple way to do it, because Chrome does expose a whole bunch of things. That's also the reason why when you're debugging, the debug context is not the DOM, but a web worker. That way, the number of things you can use is small, but yes, typed array is a problem, and there is no direct answer for that. And I think the best way to do it is stop debugging, run it, you will crash. Good thing about React Native crashes is it gives you JavaScript stack trace.
Right.
And as a result of that, you'll figure out where exactly the problem is.
Cool, thanks.
Hello, yeah, this is Dheeraj from this side. Nice talk. Just wanted to know about one thing. You said that we can go back in the time with using Node Chakra. So you said that with asynchronous things and file IOs, you take a snapshot of it, some things. What if, and this is not just nudging you, but we have a specific use case for this particular scenario. We work on random numbers quite a bit. So what if we rerun the application for that snapshot, and inside during that time, the random number changes? Do we take snapshot of that too?
So the question basically is about determinism, functional programming, reasonable JavaScript. That's pretty much what it is. And the way snapshotting works is the thing that you snapshot is all static or deterministic states. Any external stimuli file reading, random numbers, all of them are logged. So if you do maths.random, the next time the snapshot is run, it will not call the real maths.random. It's going to call, because it's an external story, it's going to pick up what was stored in the log event. So it's not really going to be maths.random, and that's the only way you can make snapshot work.
Hi, this is Hussein from Agrostar. So this is probably a very basic question. There is something called activity lifecycle in Android. So I'm not a React developer or a native React developer, but I would really like to work on that after your talk. It was very good. So how is activity lifecycle handled in the native React applications? Because it is very annoying in Android, like you have to handle a lot of things.
Hey Hussein, nice to meet you. So I think the story or the question boils down to there is an activity lifecycle in Android.
Yeah.
React also has an activity lifecycle. It's basically component did mount, component will mount, etc. Right? So in case of React Android specifically, what shows up is a single activity. If you go modify your Java code, you can mess around with it, but technically if you're using React native, you don't have to worry about it. If you're a React developer, you just think about component did mount, component will mount, etc., and that will take care of all of it. Now, if you have specific use cases where you want to use something like on resume or something like that, where you have like an intent coming in, you can write native code, and that's one of the biggest advantages of React Native. Like, if React Native ever stops short, you have this native escape hatch. You can always go write native code, and that's kind of what the Facebook app does, right? Like the Facebook app is a real native app, but parts of the screen are React Native. And that way you have this escape hatch and you can go do that. So depending on what works for you, if you think that Android activity lifecycle is hard, just use React. That'll just work as fine. If React is not powerful enough, and if you think that you really, really need to go access the punch through to the native layer, React Native lets you do that too. And that's basically the possibilities, and that's one of the reasons why I'm so excited about React Native.
Good to know. Thank you.
Hi, my name is Bilal, and I would like to say a big thank you to you guys. You guys are doing some amazing work with development tools, and I've been using Code Push for more than a year, and it has been an amazing experience, and we were able to fix bugs on production, and we could get client offer back. So a big thank you for that.
Hey, thanks. I'm glad you guys liked it. As Steve Ballmer always said, developers, developers, developers.
Hi, this is Basav Raj from Agrostar. So my question is, like, you said ki, we can deploy the code, like if anything breaks, and we can revert that back. And the question is, like, do user has to update his app, or it's like without update we can do this?
The interesting thing is the user does not have to update his app. So the question again, just to repeat, how does the whole instant update work? So it works just like it would work on a website. So you can either have a hook where you say codepush.sync, or you can have a check when the app loads up and say, hey, is there a new version? And that's all you have to do. There is no need to reinstall the app, nothing like that. The app is, the thing is you just check it. If there's a new update, it's going to go to the server, fetch that update, apply it on your React Native application, and boom, you have a completely new version of the application.
So does this like replace everything that we currently have in the Android thing, that we have to update the app, things like this?
Yes, it's going to bring in world peace. I'm just kidding.
Awesome. Thank you so much.
No. It's so to be honest, no, it's not going to bring world peace. But to answer your question, does it replace everything that Android does? So here's the thing. Apple Store specifically says that you should not be changing what your app does. So this is good just for fixing bugs. Do not start with a real estate app and suddenly change it to Tinder. One, that's morally wrong. I'm sure a lot of people are going to be like, my parents are searching for houses. They will not be happy if it becomes a Tinder app. On the second hand, that violates the App Store policies. So it's good for, like, these kind of updates are good for critical and bug fixes. And it's okay to keep updating it. So it's like you do not have to wait for 24 hours, and that's the whole point.
Hello, hi Parshuram. This is Zaheen. So my question is regarding the debugging point of Node Chakra. So just like you mentioned with live reloading, you can instantly live reload whatever the code you want to change, and the state will remain the same. So with the Node Chakra, you can also do the undo and redo. You can go forward in time and backward as well. So what happens in Node.js when you're debugging and you suddenly you have a breakpoint, when you come onto that breakpoint and you want to change something, but that change will only affect once you have restarted the server. So will it happen exactly with the same Node Chakra?
So the first thing is, while debugging on Node Chakra, there is no concept of a server. The only concept is of the JavaScript context that you're running in. And this is also the reason why you cannot do time travel debugging inside the browser. Because inside the browser, you have your DOM, which is a completely separate engine, and you have your JavaScript virtual machine, which has JavaScript context. So they are two completely separate things. And the best way to think about it is, yes, you can replace variables. So you know how in Chrome you put a debug breakpoint, and then you go replace the variables? That you can do. But if you do that, what's going to happen is all the previous snapshots are going to go stale. So you will not. So once you make the change, you'll not be able to go back past that time. It's almost philosophical, right? Like if you go back in time and change something, there might be a time travel paradox.
Exactly.
React Native will let you create time travel paradoxes. God, I even said that. Good.
Yeah, thanks.
Hello, Parshuram. This is Rinku from Learnist. So what exactly I wanted to ask is, you have given example of bug fixes, right? So we can push code to cloud and it will get updated. So what if there is new APK versions? I mean, for example, I have APK version 1 in production, and I have some native dependency that is updated, and I have given version 2. So say I'll be pushing the code of version 2 also to the cloud. So what will happen exactly? I mean, even the version 2, whatever code is there in cloud, will it get updated to version 1?
That's a very good question. The question is about what really gets, so if you look at it, it's about what gets updated. So remember, also to the point that the other gentleman asked, your native code does not get updated using code push. It's only the JavaScript part of the world. So if you have an API, so imagine that you have some native API that has V1 and V2. With code push, you can specify that all of these updates have to apply only for V1 of my native code or only for V2 of my native code. In fact, the good folks at Airbnb have written this module that says, it's kind of like feature detection in a browser, where it says, hey, if I have this native API level, if I have this method in the native API, go fetch that code. Otherwise, don't fetch it. Okay. And native APIs, you will have to still go through the store, unfortunately. It's compiled code, right?
And what if it is JavaScript? I mean, if we want the JavaScript code of, say, version 2 to be there in version 1, so can we do that?
Yes. If there's no change in your native version, you can have like any number of JavaScript versions. In fact, we have actually had customers who have submitted once to the App Store and for over a year have released like 250 versions. And that works perfectly. So, in fact, the fun thing is you can not only do that, you can also do A/B testing. You can release version 2A and 2B to like set of users and do a whole bunch of A/B testing. Something again that's possible only with React Native, not with real native code.
So you are saying instead of giving full rollout, we can just...
you can do A/B testing, you can do partial rollout, you can roll it. Today, code push lets you roll it out to 10% of the users. Test if the JavaScript code is good, and then roll it out to 100%. Effectively, the goal there is, from the tooling perspective, in the web, we have always been doing that. Facebook rolls it out to 10% of the people and then to 100%. Why not do that on the mobile side of the world, right? That's effectively what we are bringing, and that's where the innovation of tooling comes in.
And we have a framework where what we do is we upload an app to App Store, say version 2, and we just want only developer to test it, tester to test it. It shouldn't go to the production to all the users. So is it possible to do that?
It is. Microsoft, being the big Microsoft company, has acquired this company called Hockey App. I'm not sure if you've heard of Hockey App. It's similar to what TestFlight is. And Hockey App is the way to do beta distribution to your testers only. Code push is now a part of the whole big thing that also Hockey App is a part of. So code push and Hockey App can work very well together. So you technically can do what you're talking about.
Thank you.
Hi, this is Sneha. So actually, when you do a code push, how would iOS take it? Because we have this review cycle that it goes through, right? So if I change something in the UI and it doesn't follow the style guides or something, how does it work?
So again, as I said, the caveat there is do not convert your real estate app into a Tinder app. But having said that, so here's the code push story, right? So the native UI is not going to change. When the JavaScript code loads, what it's going to do is it's going to go, rather than loading the file that it has on your local device, it's going to check if there's a new file on the cloud. If there is, it's going to download that. And because the new code has all that logic to create a different colored button or to create like a different UI, that works from here. And this guy drives all of it at the top. And that's how it works on iOS also.
So Apple doesn't stop like from doing it or something?
Maybe we should. So I can see that your friends sitting around you are probably looking to head outside for lunch, and they're probably going to come back and they'll be like uta aita, and then they're going to rub it into you. So let's take this offline, given that we are running out of time. But yes, it is possible to do.
Okay, thank you.
I think.
I mean, that's fine. If we want.
Hi, my name is Arun. So I wanted to ask you that as a developer, I have always wanted. So when I'm debugging my code in Chrome Developer Tools, I kind of always wish that I could go back and from a specific debug point. And the only way you could go back was to reload your page, put the debugger point at some earlier place, and debug from there. So I wanted to ask you, is this something very specific to React Native, or can I do this type of debugging in Chakra directly in a normal JavaScript code?
So yes, the short answer is yes, it's specific to React Native. The reason being, in case of React Native, your entire virtual DOM is stored inside the JavaScript memory. So effectively, there's just one virtual machine that you're dealing with. The moment you take it to a website, you have the whole DOM infrastructure, which is either like the Blink engine or the web, or like the Trident engine or stuff, and then you have your JavaScript. So keeping those two state machines in sync is hard, and that's why you will not be able to do it inside inside the browser. But because this is React Native and because it has like virtual DOM and stuff, it's possible on React Native. So unfortunately, we do not have an answer. In fact, the whole time travel debugging thing is actually a PhD thesis. It's done by Microsoft Research. And those guys have been wanting to implement it in the DOM. It's not trivial. Because the way React Native is the way React Native is, we could hack it together with minimal changes.
Okay, thank you.
All right, guys, thank you very much.
And I think I'll also be hanging out, having food. So if you have any other questions, or like me, you're socially awkward, just come over, we can chat, or tweet to me, that's also fine.
All right, guys, let's break for lunch. In the meantime, we would really appreciate if you would go back to the feedback link and give your feedback. It will really help us next year to do a good job. I'm going to project a link, so please spend 5 minutes on the feedback. Thank you.
Hello, hello, hello. Yeah?
So I think we can resume with our next workshop. And probably I think pretty much everyone has done with the lunch, right? Was the food good or is everyone full? Yes, no, huh? Yeah, okay, cool. So welcoming Farhad, thank you so much for coming. And let's resume our workshop. So, all set? Cool.
Ready to start? All
Over
right.
to you, Farhad.
All right, thank you. Yeah, I am definitely full. I ate a lot, so thank you. All right, how's everybody doing? I'm much louder than you guys. Hold on. Is that better or is it good? Good? All right. And if I can get some technical help here. Oh, it's just a little bit finicky. As soon as it started. Yeah. There it is. All right. All right, everybody, my name is Farhad, but I'm sorry, is this too loud? It sounds crazy loud from my end. Is it good for you guys, or? All right, I just want to make sure I'm not yelling at people. It sounds awful. Anyways, my name is Farhad. You already knew that. So here's a little bit more about me. I'm a big car enthusiast. My background is in philosophy and logic. And somehow I found myself in software, still trying to figure that out. But all kidding aside, I'm based out of San Francisco. I work for McKinsey, where I get to travel around the world and help Fortune 500 companies. It's a really great, I've been really enjoying working with the team here. We have a lot of our colleagues here as well. So that's enough about me. Last year I was fortunate, I gave a talk on WebGL and production. And let's see here. And I had an amazing time hanging out with you, getting to talk about something I absolutely love. But this year, the plan of the talk is something a little bit more practical, something a little bit more intimate, and we'll get back to that in just a second. But I'd like to kind of just start off and say thank you so much for all of you being here. This is phenomenal. I really mean that. Thank you so much for being collaborative, being so supportive. And a big shout out to the JS channel crew. I'm not sure if they're there. The lights are super strong. But a big shout out to everybody here for kind of bringing us together under one roof and experiencing something so phenomenal. So thank you so much for that, guys. Yeah. So, the title of this talk, it's kind of cut off there, but it's called You and I. Can anybody guess what this term means? I just made it up in the shower. I thought it was clever enough. But I'm curious, anybody can take a guess at what this term means. You don't need a mic to shout it out. What is that? UI. Well, what's the ampersand about? I'm sorry, I can't hear. You and I? Or who am I? All right, all right. It's a lot of confusion. I guess that gives me something to talk about. Cool. Yeah, you and I. This is actually, as I mentioned last year, the talk was on WebGL, but I felt it was not really grounded, first of all, because in our traditional modern-day development, we don't get to work with this cutting-edge technologies. And I found myself over the past year working with a lot of different teams and different organizations, different constraints, different skill sets. And I've really been feeling this pain point that I think we've all encountered is dealing with traditional UI development. And as much as we love the visuals, we love the interface, the people who are actually creating them, our experience of building these UIs to be reusable, composable, it's a pain point, right? When I think a lot of us were so excited about shipping a product or a service to our clients or our customers, but I wish we had the same type of passion and same type of interest for having these building blocks behind our applications also served to other individuals who can consume them. So I thought, how do we approach building user interfaces, UIs, that's meant for you and I? It's a little bit more empathy here, right? And I'm not talking about some AI-driven button, which would be crazy, but an interface, some components that we talk about modularity, we talk about encapsulation, but a lot of times my experience from what I see, including myself and my own code base, is we build these components that are not really reusable. Their styles kind of bleed outside. We start out with good intentions, but it's really hard to kind of scale these applications. So the biggest thing that I want to kind of take away here, just I hope that I do a good job of articulating as best as I can, but hopefully you walk away with something, is coming up with these basic principles, these standard guidelines for ourselves and the teams that we work with to help us become better developers. So again, it's building these components that is meant for you and I, a little bit more empathy, and having these things actually reusable, and different strategies for consuming them. Does that make sense? Yeah? Cool. All right. This talk is inspired actually by a talk given by Christopher Shadow like 2 years back. He did a phenomenal job. He worked at Facebook, and some of you may have listened to this talk. It talks about the different issues that Facebook was running into with just traditional CSS. And I call them the Shadow's commandments, right? As if he came out with the tablet in his hand, he's like, these are the things that we follow. And it was really powerful. And whether he actually prescribed that inline styles are the optimal or the perfect solution for our use case, I think what it did for the React community is inspired a lot of developers to go out and create a lot of technologies around inline styles, around CSS and JS. For example, I think we had Max here, but he gave a phenomenal talk yesterday on styled components. And these are the type of inspirations that have inspired a talk like this one as well. So actually, Max did a great job yesterday. He covered inline styles. He talked about CSS modules. He spent obviously a good amount of time on styled components, rightfully so. I'm a big advocate of writing CSS and JS. I think it has a bright future. But how I like to distinguish our time here is I like to kind of talk about the principles, the best practices, things that are not tied to an actual technology, but more so working with different teams and different constraints and how we can adhere to certain standards to help us become more effective, right? So we'll have a very high-level overview of some of the different strategies and different concepts. We'll have time for some live coding sessions at the end, but I would like for us to kind of stay a little more high-level, just to kind of get the principles, some of the guidelines, and some of the things that I've learned, some of the things that I've uncovered, some of the things that I'm actually just experimenting with. I just think they're good ideas, and I'm just tinkering with them. They might be useful for you. If they're not, please let me know, because then I can save some time, right? I don't have to keep experimenting with them either. So it's inspired by that, and I just want to make sure we focus more on the principles, more of the guidelines as we move forward. And something that, man, this is kind of unfortunate because, oh, nice. Sweet. All right. So how do we actually come up with these strategies for building reusable components, right? Max, I'll reference Max again one more time here. He said something, if any of you remember, something really, really interesting. He said it in a joking manner, but there's so much truth to what he said. He had a list, right? And he said the list is all green. That list was a guideline. It's the guideline that I think he uses to analyze, to decipher other frameworks, other technologies. In fact, he wanted to create his own based on that standard. He said he was biased to it, which is rightfully so, right? We have these guidelines, we have our own standards, but I think what I've experienced over the past couple of years is that many of us developers, we don't have these clear guidelines. So we're easily persuaded, we find ourselves confused, or we just go chasing after the next cool technology. So I found it to be useful as, yeah, technology is cool, these different toolkits that are coming out are awesome, but it's really valuable to have a clear set of guidelines for yourself and for the teammates that you're working with, for your colleagues, and for other organizations. These contracts are, I think, essential before you start any UI framework, right? And I've took some from Shadow's concepts. He described them as problems in his skills and in the problems that they were facing at Facebook. I took some of these, I added some other ones, you'll see why. That I just, you know what, here's a sample UNI contract that I want to adhere to for a given project. And I want to make sure that when I work with teams, this is something, let's say, for example, we try to adhere to. And contracts, just like Max mentioned yesterday, they're biased, right? But these guidelines are necessary. So the topic of this book, this entire talk, is actually having a set of guidelines here, adhering to them, and going through different strategies for fulfilling these. It's not tied to React. It's not tied to CSS modules or inline styles. It's more so, we have these principles, how do we actually go about building them or adhering to them? So we start out from the really basic primitive blocks of just traditional CSS. We see how far we can get that, and if our requirements just need more, we go to a different strategy. And we just cover a vast range of strategies to adhere to these. So we'll start with the first one, no global namespace. By the way, I like to kind of be split conversation, so don't be shy. I make a lot of mistakes. If you make a mistake or whatever, just feel free to shout out anything that you want to shout out. Hopefully it's relevant to the talk, obviously. Just don't shout out random stuff, but I like to just for this be a conversation. Can anybody guess what it means by no global namespace? I'm sorry? Nothing is shared. Good. That's awesome. Yeah, I mean, this whole idea, right, is we don't want things to be just global by nature, to extend, right, to things that they shouldn't extend to. The second one is, this is something I've been experimenting with, and it's quite extreme, right? I just came up with it, been experimenting with it, and I'll kind of explain to you what it does, what it means, and give it a try. And I'm saying it's pretty extreme to be following this pattern, but I just have it in the back of my mind when I'm developing a UI component that's meant to be used by other people. And I think about this. I'm like, I try to adhere to it as often as I can, but there are certain situations it doesn't make any sense. Unidirectional styles, I'll draw a diagram a little bit later on what that means. But this whole idea is that if we thought about our styles in the same way as we think about our data, how it gets applied to our application, and how it styles only get applied internally. So you have a component, you have a button, right? Background color, that's set to that button. Text size, right? Maybe padding, maybe width. Width is kind of questionable. Can you think of some CSS attributes that are not intra-focused? I'm sure you guys have used them. Just take a moment really quickly and think about some CSS attributes that are not intra-focused. Which one? Great. Any more? Think about, right? Styles that don't go inwards. They're not intra-focused. Float could be. We'll talk about that. Yes, margin. That's a good one. Absolutely. Right? So this is an idea, right? I think about it, I'm like, hey, whenever I build a component, I want all of these styles to be unidirectional. Why? It's because I want the style to flow downward, right, from parent to child. If I have an element, the margin telling other things around it to behave in a particular way, I don't want that component to tell other components around it how to behave, right? Wouldn't it make more sense for the parent to lay those things out? Wouldn't it make more sense for the components to be only intra-focused? They're just responsive, in whatever context that they reside in, the parent tells them how to actually behave. Does that make sense? And it's really difficult to actually do this properly. At first, I was like, oh, this is amazing. This is simple, right? How come we just don't do this with all of our styles? But it's quite difficult. But it's a really, really good standard that I have back in my mind at all times. How do I maintain unidirectional styles? Dead code elimination, obviously, CSS tends to grow it gets quite bloated, right? We have a lot of styles that just don't get refactored, they don't get removed, and I understand that, right? When CSS files just grow massive and our applications are huge, it's really hard to remove styles without thinking that you're going to break something. Shareable constants. Again, I love 3D and I love graphics and I love when I work with WebGL, I have access to the power of being able to share variables amongst different contexts. With CSS, we don't get that. CSS Next, it allows for that, but it's not widely supported, which I think is awesome when CSS in the future where you can actually change CSS variables through JavaScript. If you're not familiar with that, I highly recommend looking into it. It's amazing. So that's another thing I look for, right? For building interactive applications, I want to be able to share data between CSS and JavaScript. Next one, deterministic resolution. It doesn't happen as often as you might think, but when you're asynchronously loading styles into an application, bless you, things, depending on how they're being loaded and how they're being applied, you can have a non-deterministic outlook, or just a view, right? So I want things to be a little more deterministic. Isolation is huge for me, right? Again, this kind of goes to the idea of building these components with a little bit of empathy, meaning that if you build them in isolation, if they're well encapsulated, all their dependencies are self-included, this thing is isolatable. If that's a word, it's isolatable, right? Extendable is that the component is protected. You don't want things just randomly manipulating it. It provides an interface for other component consumers to actually modify the behavior. The last two are extremely important for me, and I hope you don't have to be an open source developer. You don't have to be creating the next biggest front-end framework or UI library. This is so simple that we could do this. It's just hard to do with UI, right? Because a lot of times our components, our UI elements, are so entrenched in the application, it's hard to document a particular piece. And things like Bootstrap, Foundation, they do a great job with their documentation, but it's just the visual looks. You're not sure what the underlying mechanisms of these things are unless you look into the source code. And again, it's a big open source project, so many people are contributing to it. So how do we as developers in our normal daily jobs, right, be able to adhere to the same type of standards? So those two things I just threw up there, we'll talk about it. You guys are good? Yeah? Making sense? I hope I'm touching on something quite intimate as developers, or if you're an aspiring developer. These are things that I've encountered over the years. I just want to make sure I try to do my best to hit home with this. All right, and I have a gift for you guys. I really mean this. Over the past several months, I spent countless mental cycles, many days, honestly, not sleeping, to be able to deliver this gift for you guys today. I had such a great time last year. I want to be able to make sure I give you guys something to walk away with, something tangible that you can go back and kind of reflect upon the things that you learned and have some feedback. And what that is actually, I just published this book literally this morning. It's provided as an open source project for you guys, and I made a JS channel as a package. You can just download the entire book for free. And all of the source code is there. The documentation is all there. And there's a link in the GitHub. Thank you, guys. No, honestly, this clap this is all for you guys. I was so inspired last time, and some of the pain points that I felt. I was like, you know what? I'm just going to document everything that I have, give it back, and provide it to you guys. But I can just tell you, I put my heart and soul into this thing, so I hope you find it useful. And I just published it like literally 3 hours ago. So if you want, just go ahead and go to that link. It's on GitHub, and there's a link on there that goes to LeanPub. You'll see a little section there. It's called JS Channel. Just click on that. You can just download the book for free. So go ahead and do that if you find it useful, and I hope that later on you can go through the chapters, and it's a lot more in detail, and hopefully make your future lives as UI developers better. All right. So I'll give maybe a few minutes for everybody to go and just download, at least, you don't have to download the book, but everything is encapsulated as far as the source code, because we're going to go through the code examples, and hopefully have some time at the end for some live coding sessions. So I'll give you guys maybe 5 or 10 minutes to kind of at least download the GitHub repository. How is the internet for you guys? Pretty bad? And if one person is lucky enough to download it, if you'd be kind enough to kind of maybe give it on a USB or through, just send it over via Bluetooth or whatever with your neighbors, that'd be awesome. Yeah, if you could, that'd be awesome. Yeah, it should be there.
Connect to my hotspot.
Yeah, but I think I need to go to the smaller interface because I can't see it.
You cannot?
Yeah, let me just see Wi-Fi. I'm not sure if I can. System preferences. Let's see here. Where's the Wi-Fi? Yeah, perfect. What is it? Moto G3? Great. Everybody's got the link? You guys are there? Just raise your hand if you're there and at least download the, wow, man. So that's why I can't connect, because you guys connected. Thank you. All right, good. All right, cool. Should I disconnect this back in? Let's see. Anybody's got an interesting story or a joke to tell? Yeah? You are a brave, brave man. Speak up, please. Come up here. Okay, good. I'm sorry, what was that?
So you already said that curiosity across the audience, at least myself, about what we are going to discuss. But I was just trying to correlate what exactly we are going to discuss further.
Absolutely. Good question. Actually, we're going to go through each, at least at a higher level overview, we're going to go through just the introduction of this book. We're going to go through the chapters of building a very simple application through different strategies. So we'll cover, obviously, we'll start with a very simple CSS application. We'll convert it over to using CSS modules, CSS preprocessor, but it's more so about that UI contract that I laid out, what kind of practices we can employ to actually adhere to that. So not just because we're using CSS modules or inline styles, but how does it actually help us to adhere to that contract that I put up?
But if I correlate it correctly, the frameworks like Bootstrap and others
yes,
already doing it for us. It's like the points, whatever you have, bullet points, whatever you have mentioned.
Yes.
So if I come from the order, reset.css, base.css, the container level CSS, and the custom CSS, whatever we have to write for this specific application.
Absolutely.
So are we doing anything apart from that, or how it is?
That's a very, very good question. So one thing is, like, for example, I use Bootstrap all the time, right? Bootstrap is a great, great UI library, and it's one that's been provided to you, right? But a lot of times, we have to build our own UI components, right? And we use Bootstrap, and I would argue that Bootstrap doesn't meet a lot of that criteria. It is non-deterministic, right? Because if you bring another external library and try to align it with Bootstrap and things are loaded asynchronously, you can have a non-deterministic resolution. The styles are not encapsulated to the components, right? So it just takes a lot of effort, actually, to do that. But more importantly, Bootstrap by itself is not enough for you to actually build an application, right? If you're working in an organization and let's say you need to build a header, right? This is something I run into all the time. I work with an organization and they have this common header and footer that they're like, hey, I want this to be reusable. But then I go from one team to another, they're using completely different standards and these guidelines these things that people have inside of themselves, the guidelines by which they actually analyze the world around them, they decipher what's right and wrong, it's not outlined clearly. For example, in Bootstrap, I just kind of know it works, and I have some ideas behind it, but I don't know the guideline by which the developers behind this, what are they actually using to decipher what's good and what's bad? And these are great, great developers, right? And they're prescribing a lot of kind of methodologies. But within our own teams, within our own personal projects, we don't have these clear standards. We don't actually even talk about them. So for example, myself included, I come into a team, I'm like, that's not a good idea, or that's a great idea, right? But I have this guideline by which I'm actually judging things, right? And I just want to make sure we become clear of that. So I guess the idea is, yes, how do we actually build a Bootstrap within our own organization? Or if we're using Bootstrap and we're adding on top of it, right? That's what we do, right? We bring in a library and we use it. But those things are not reusable. We're just excited about shipping out an application. Not all of us are open source contributors wanting to build the perfect modal. But what I'm trying to get at is, I think it is actually quite doable. If you start out with clear guidelines and have everybody on your team level set and understand where you need to be with each particular component, you can actually get there quite easily. I hope that answers your question. It's a little more of a practical approach. So anyways, guys, if you've downloaded this, raise your hand. If you need to download it. Anybody's waiting to download it? Okay. Should I wait? That's good? All right, so the code, all the code examples are on the side of the code directory. The manuscript just has the, if you spot any grammatical mistakes or any errors, just please open a pull request to it. So let's just start with the application. You guys can see that, right? Great. How do you, obviously this thing's going to be gone through React, but React is not, the idea is here that we don't have to use React. A lot of these principles, right, you can just be using just traditional CSS, HTML with Bootstrap, and you'd be good to go. Just following these basic principles would be useful. But we're teaching this through React because obviously React seems to be a lot of our domain, or we're interested in learning it, so we'll cover it. But the focus here is not React. And for those of you who have used React, how many of you used Create React App, the nice utility? Yeah, sweet. This thing is phenomenal. For those of you not used it, it's just a basic command line. You just do Create React App in your application, and it gives you a lot of the latest features already configured for you. You get ESLint, you get Webpack, all the nice and dandy features you would expect in a modern React framework or project. So what is the app that we're building? Let's go to code, chapter 1. Go chapter 3. The first ones are not. Got to install this really quickly. In the meantime, we'll go through this really quickly. So we talked about, obviously, the this idea. Here's the unidirectional styles that I was mentioning about. We'll try to implement this. It's quite difficult, but CSS is easy as we first start, but as the application grows a little bit more in complexity, it's harder to maintain this. And we'll continue down this. All right, so building our application. Okay. Sorry, guys, I was hoping to have split screens for this, so my apologies if I'm scrolling really fast here. Okay. Once things installs. All right, anyways. We build a very, very simple to-do application. I try to keep things as minimal as possible, purely just for that Occam's razor principle, like the principle of parsimony is having the minimal amount of work to try to get this idea across, right? We have a basic application, there's a list, and a list of to-do items, right? This kind of helps at least try to drive a lot of these points home without introducing too much complexity into the code base. So once we build this application, you can see it here. Really simple, very basic CSS animations. And if you look into the source code here, chapter 3, we can start. We start out with everything being global. And not that I'm saying oh man. Excuse me, guys. All right, let me see if that resolution is better. Yeah, it's just, maybe it's a little bit better to see that. Okay, cool. So not that I'm saying when we run to React applications, things are really written this way, but I just wanted to have it as a starting point. If you're new to React, you start out building everything kind of global in one file, and then we extract this out. So we have just an unordered list. It renders a list of elements. On the click, You toggle the to-do, nothing too fancy, and a component amount, we're not fetching any APIs, we just set the to-dos. So if you're familiar with React, this is pretty straightforward code. It's probably one of the simplest applications you can build. But everything is global by nature, right? We have our styles here, which are really poorly written because everything is applied at a global level, right? So in the next phase, we see how we could apply. Perfect. Let's go through this. In the next section, we just employ some basic UI principles that we mentioned to see how we can refactor this code base, all right? So instead of having everything global, we just create a basic React app component called app, right? And all that does, in the first chapter, or I'm sorry, in this particular section, instead of having the UL element, can you see that? We call this thing called just a to-dos list. So a lot of times we have lists and we have list items, right? And I was thinking, you know what? Wouldn't it be better that we have common lists and we have list items? Instead of having the entire list tied to the actual items itself, what if we build a component that's just purely a list, super generalized, that renders its children, right? So our list of to-dos, right? The to-dos themselves are an actual item. They can be rendered to any particular list. So instead of having our UL and our LIs tied together into one component, what if we extract out the ULs and all it does are lists? It applies some basic functionality, again, in a top-down fashion to any children that are passed down to it. Does that make sense? This is something that I generally don't see in projects, right? Lists and unordered lists are things that are just a collections. They're heavily tied to the items that they're rendering. Does that make sense? So that's the first thing we do here, right? We say, you know what? We're going to convert our to-do list into a component that renders the children, which is a to-do list item here, right? And let's see what these components look like. They're quite simple. You can see here an unordered list that renders the children. And this seems quite minimal right now, right? Nothing too crazy. But you can see that, like for example, we talked about how you have a list that may lay out particular things in a fashion. Maybe things need to be centered when there are only 4 elements. Whatever complex list that you may have, it's kind of good to kind of separate the items in the list from the list itself. So that's that. Next up, we have our to-do list item, right? And our to-do list item, it's literally tied to that particular instance. It's just an item that receives a few props on handling its click and rendering a display, right? That's it, super focused. And again, why do we separate this out? Because now I can feed this unordered list, this to-dos list, different types of items, which we'll see here shortly, without changing much code at all. I didn't have to create another list or some other components to be able to handle that. I just fed a different item into it. And we'll see how that works pretty easily. Another thing we employed here is, how many of you have worked with, when you guys work with CSS, like Suit or BEM? How many of you use that? Raise your hands. Okay, cool. It's just a basic, clever naming convention to be able to kind of scope your CSS in the hopes of not having your CSS clash against one another. So BEM is just basically block element modifier. You have a block, you have a class, and you have, for example, if you have a footer, the elements below, you have footer underscore underscore the element, and if you have modifiers like active, non-active, whatever, those are the modifiers. It's just a kind of a clever naming strategy to help organize your CSS and to kind of avoid naming collisions, right? And in a very similar fashion, something that we can do with our components is the CEM, right? Component element modifier. At the top of every single component, right, we introduce the name of the component, right? At the top, class name, we put the name of the component right there. Everything gets somewhat scoped to that component, and all the styles sit within it. Does that make sense? This is something I generally don't see, right? We build a component, and then somehow we have styles within it, or the component name is in the middle. What if we just do component element modifier, right? And another concept, very similar, is introducing, instead of a component element modifier, what if at the very top of our application, we introduce a unique identifier for our application. So we house all of our components in an ID because there's, let's say technically in this application, there's only one application instance. So you have our components, but you also scope the entire application with an ID that's identifiable. Can anybody guess why this may be useful? We understood the idea of scoped, right? This idea of scoped classes, right? Why would it be useful to scope the entire app with an ID? And why do we choose a class for a component? Shout it out if you know. Yeah. Can you repeat that? That's exactly right. Yeah, so the ability to create sub-apps, right? So imagine you have these components, right? And you want to use this component in a different area, right? What if you namespace your entire application with an ID, because generally IDs are more semantic for one instance, and we use classes for components because semantically, components can be or may be rendered multiple times, right? So if we namespace our entire application with an ID, right, if I put the same component in a different context, right, it can get themed differently. It's a very simple way to have theme support, but also, since an ID on an element gets high specificity, if we bring another library, we naturally get a little bit more specificity with our own styles, right? So in this case, you could see that all of our classes here are prefixed with a to-dos app. Does that make sense? Because that's the entire instance of our application, which you could see here in the public. It's called to-do app, and everything gets injected inside of that. Make sense? Cool. Make sure I didn't forget anything here. Namespace, application, namespacing, yep, unidirectional styling, and let's see how we did that here. So before, our list, right? Our list itself was positioning itself. Our list items were actually telling margin bottom, they were saying, hey, I don't want anything to get close to me, right? So we bubbled that out, right? Our app here, you can see, it's talking to the child itself. In CSS, essentially it's cascading. It's kind of global by nature. We're just able to do that. We don't need that particular interface. But you can see here, I extracted out the to-dos list class within the app because the to-dos list is sitting within the app, right? It's telling it, hey, I want margin top 50 pixels or margin top and bottom 50 pixels, and I want it to be centered. And the max width, the list itself doesn't want to say how wide I need to be. Just by default, I have it 100%. The parent tells it, I want it to make sure that it's 800 pixels wide. And you can kind of see this is the idea of writing kind of more empathetic components, right? They're just responsive, but the parents are allowed to modify the behavior with quite ease. Make sense? This whole idea of unidirectional styles? And very similarly, in the to-dos list, you can see that the to-dos list items were affected by the list itself. The items don't say, hey, things above me should not be more than 10 pixels closer to me, right? We're not using margin within the list item. We use it in the list up top. So that's our first pass of this conversion. And interestingly enough, a lot of the applications that I run into, right, I see a lot of times I see a UI element, and it has styles that are easily scoping, they're going beyond its own scope, right? I'm sure maybe many of you, including myself, I've done it several times. I think about these sibling components, and I just see clearly that this component is affecting the styles of this other component, right? So this basic practice, we don't need inline styles. We don't need this particular stuff. Just this basic idea of unidirectional styles can kind of help us get there, right? And these are basic principles I think are constant throughout time. If we're working with CSS, you can follow these basic principles and write a better application. All right, so the next section we have, let's see where we leave off on our list here. So these little asterisks, it means that it's kind of pseudo-fulfilled, and the check mark means that we actually fulfilled it in that particular refactor, right? And pseudo, what it means is that we solved it by some clever naming strategy. We app namespace, we component namespace, we did some unidirectional styling, but we kind of pseudo-fixed it, right? We still have the issue with no global namespace, right? But maybe in your applications, this idea of no global namespace, because the contract that you came up with, you don't need to have these absolutes that we're going for, right? This might be more than enough for your application, right? So that's just kind of one of the things that I'm talking about, is having these guidelines and seeing what's needed within your team. We obviously achieved unidirectional styles. We don't get dead code elimination. We don't get minification as far as minifying our CSS classes. We don't get shareable constants. We get somewhat of deterministic resolution, pseudo-fulfilled. We get somewhat of isolation because our components are requiring their own styles in and their namespace. Isolation, extendable, and documentable and presentable, we'll talk about a little bit later. It's a really cool tool to help you, as you're building these components, be able to do that at the same time. In the next section, we talk about CSS preprocessors, right? For those of you who work with CSS, how many of you work with a CSS preprocessor? Please raise your hand. All right, good, most of you. Can anybody shout out what's the one that you generally use? Wow. Did somebody say less? All right, good. They were much louder than you guys. You guys need to yell out. Yeah, SAS or less, right? Can people just, now there is no shyness here, right? Almost every single one of you uses a CSS preprocessor. What I just explained, how would you use a CSS preprocessor we're not gonna be able to go anything above our contract now, but what would you do to help us maintain the standards that we've already adhered to? All of you guys use CSS preprocessors, so think about some common things that these preprocessors offer us to help do what we're doing here in a little bit more elegant fashion. I'm sorry? Nesting? Great. Can you explain why nesting would be useful here? By the way, this group right here, most phenomenal audience. You guys should come up here and talk because you guys are awesome. But I'm sorry, what is that?
I mean, it should be useful because it's just giving the styles to the children.
Yes.
But it might be less useful maybe because it's not very implicit when you go down and look at a deeper level. It looks like it's only talking about that child and not the entire.
Yep, absolutely. But you mentioned nesting. Nesting, we'll actually talk about how it's very useful here. Dead on. Anything else? Emulates HTML structure. Oh, I like that one. I didn't even think about that. I'm a very visual person, and I think when code visually looks nice, it's easier to consume, right? It's almost like art. That's a really good one. I didn't even think about that. Thanks for bringing that up. Another one? Just think about this. You look at this page, right? You see a lot of repetition, right? A basic principle, right? Try to remove as much repetition as possible. You mentioned nesting. So what is that? We see to-dos list, could be nested down. We can get a little more aggressive. We can do the ampersand, right? To-do list item. We can just do the ampersand so we don't have to replicate to-dos list, right? A lot of useful things. Another one is variables, right? We talked about how this thing could be themed in different contexts based on the application ID. What if I turn the ID itself of the applications, it's the constant, right? I set that at a global level. So then, with flip of one variable, right, you can change this entire thing, and we kind of see how that works. So let's see here, styles. So we extracted our globals. We want to clearly say that these are our global files. We require them at the top level. Why? Because we want to adhere to this whole idea of unidirectional styles. Since it's at the very top, I don't ever want to see a global style within a component. Again, it breaks that whole idea of unidirectional styles, right? We should... I'm sorry? Yeah, exactly, right? Font sizes. Oh, if I increase that, we should put a variable for that, make it easier. But I won't be able to see it on my screen. So I guess there's many more of you than me. So maybe I should not fight back here. I thought you were saying that you can make your font size, like based on the rem and m, make them responsive. What is that? Oh, that's actually with WebStorm it doesn't work. But look at this. With the little pinch one, it actually works, which is cool. But under the command plus plus should work. I hate that it doesn't. All right, so this whole idea of unidirectional styles, we're still adhering to it, right? It's still somewhat simple. We've extracted all of our global styles, put it into a global file because we want to make sure these are global and they only get required at the top level, right? Then, next up, we introduce this idea of a theme, right? And this is where I define our app constant, right? We call it a to-dos app. But you can imagine that you have a different theme, and everything within your styles gets this prefix without any type of repetition. So if you go to our components, you could see here, our SAS, we interpolate on that component, which is called to-dos app, and our classes all got nested, right? And as the gentleman up here mentioned the nesting, we did the same thing here, right? Makes sense, right? Is that pretty useful so far? Maybe some of you already employ this in your current projects, but some really basic principles that kind of help you write better UI, right? Another thing we did here, we introduced, because it's been so easy to build upon this architecture, if you go through the exercises, you'll see that it's so easy to introduce a new component. We just introduced a new component called to-dos list info, and all this does, it's another list element that just captures the state of the to-dos and telling how many are completed and how many are not completed, right? Very similar. It's got the to-do list item, we set it at the top, and it takes some basic classes, right? And you could see in the app.js, since it's the parent, it's the one that renders the to-do list item. It generates all of our to-do list items. And at the end, we put a to-do list info. Can you guys see why we extracted out the list from the items themselves now? Right? Instead of creating another list or somehow injecting that list, the list info, right, somewhere and then hopefully try to style it, we just extracted out those two different functionalities and be able to just inject another list item in there, right? Straightforward. Now, can you guys do that contract? I'm not sure if you were paying attention clearly or you could see it. Do you think that contract that we went over, the things that were fulfilled and pseudo-fulfilled, do you think we fulfilled anything higher than that? Yes or no? Did we get any extra functionality but all the work that we did here? Were we able to introduce dead code elimination? Were we able to introduce shareable constants? Did any of the things that were pseudo-fulfilled, like no global namespace, were they actually fulfilled now? Yes? Raise your hand. No? Raise your hand. Man, it's really binary. Maybe? Maybe? All right, good. Yeah, actually, we didn't do anything. We literally didn't add any extra functionality. But yet, I think we did do something that I didn't capture in that contract, but I'm not sure it's something that's really something you want to kind of discuss with your team, but developer experience or developer UX, right? It's much more elegant, much easier, right, to write this type of code and maintain, right, than I think the previous version. So if you find yourself in a project that you're using CSS and you want to use a CSS preprocessor, I think these are some basic principles you can take away and write some decent components, right? And as long as you as a team have a clear contract and adhere to that, you can write really good scalable code within your organization, right? But we didn't really come here to just basically pseudo-fulfill. Let's say we work in a set of constraints that we will actually need to have deterministic resolution, because we have a lot of external libraries, or we have a large project. We actually need to have shareable constants because our app is extremely interactive, right? So we start approaching in our CSS modules, right? Now, Max did a great job yesterday explaining CSS modules. It's just a way to kind of locally scope your classes, right? Do you want me to go over that again? Unless some of you were here yesterday, some of you were not. Should I explain that? Please raise your hand. If not, we can save the time and go to something else. Raise your hand if I should explain it again. Okay. I'll quickly do it. So this idea of CSS modules, right? Let's look at the code really quickly. It'd be easier to kind of talk about it. Actually, you know what? We should go through this because this is an area where the idea of unidirectional styles, and maybe I'll need your help on this, because I couldn't find a clear solution. There are many different strategies that I employed, and I found one of them to be somewhat decent, but this is a point where maybe you may want to break this whole idea of unidirectional styles, and it sucks. I decided to continue with it. It's a little bit more on the extreme end, but you'll see why it's a bit difficult to adhere to that standard. So, actually, I forgot one bit of code here, so I should probably fix that. We no longer are using this idea of class names. But what you do, you write your CSS the same way as you did before. I decided to go with a camel case convention because what happens, now you require styles and give them a name. And within this component, right, instead of doing class name, instead of actually tying it to the actual class name that you wrote, you import the styles and you reference it off of that object's key. And what's kind of happening underneath the hood, you can kind of think about it this way. I think it's a very clever solution. Let me see if I can find this. It'll be a little bit easier to see here. Cool. So you can see here, right? Up top, we have this style called title, and it renders the word hello world in an H1 tag, right? But actually what's happening underneath the hood, right? Our CSS is being converted, and since we're writing our templates in JavaScript, we're having this kind of, you can kind of think about it kind of like a dictionary lookup or a hash object where it's mapping the CSS names to a unique hashed value. So underneath the hood, title is getting mapped out. We can give these semantic names. In your Webpack loader, you can give it, say, I want the name of the component or the path, and ideally, you want this unique hash, right? So when you reference it, you're not referencing the CSS class itself directly. It's being, through a level of indirection, it's being mapped out to something that's unique. Does that make sense? It's a pretty clever idea, right? You can kind of think about it. You can do this yourself without a build tool, right? You can think about creating a large dictionary in your code, right? And you create unique keys in this object, right? I'm sorry, the unique keys are the values. The keys are the semantic names. So if I have a footer class, right? I have footer dash something, and I give it a unique hashed value, and I just reference that in my code. But instead of building this and managing this large object with CSS modules with a nice build tool or a CSS loader within Webpack, it does this thing behind the scenes for you. What's powerful about this is that you actually get locally scoped CSS. Because these names are all completely scoped to that component, you don't have any type of name collisions. And can somebody help me understand, or just kind of try to think about why it's so much more difficult now to have unidirectional styles? Where before, if you recall, we had to-do list, and in to-do list, the CSS, or the SAS file, it had a class called to-do list item because it was manipulating the child components, right? Why is that more difficult now? Actually, nearly impossible. Can anybody guess why it's nearly impossible now? Can you please speak up? I know you don't have a mic. Yeah. Yeah, that's exactly right, right?
So the class names are not unique now. They might change, so you never know what they'll be in future.
That's exactly right. Yeah, it's a generated unique name, and when you go into production, the name could change, right? The only way you can have these classes actually scoped properly, you have to actually import them. And CSS modules offers this word called a compose, where you can require other styles and compose them, right? You can merge them with your current styles. But you know what sucks about that? Is that if you want to build encapsulated, well-isolated components, if you're having one component require the styles of another component, what are you doing, right? That's not isolation anymore. You have absolute dependency between two components, right? So if you want to use compose, I love that feature, right? You require the styles of another file, and then you extend your own styles. But again, deep, deep dependency. I can't have a list item by itself unless I require this other thing. That sucks, right? So which one do you give up? I don't want to have this deep dependency. Do I use this composes word, right? What do you do in this situation? I wanted to go more on the extreme end. I wanted to adhere to the idea of unidirectional styles. So how do I do this? What do? You go to this next idea that we employed, right? This idea of extendable, right? Where your components provide an interface for them to be consumed and be able to get manipulated by. Bless you. So when components, right, have particular styles applied to them, maybe some things should be affected and some things should not. So what you do, you provide an interface to the to the parent components that consume them to be able to change them. And how does that work? Can anybody guess in React? What do you do to provide an interface for another component to consume? We do this all the time with data. How would you do with the styles? I heard somebody. Yeah, props, right? You pass in your styles via props. And the thing is, we do this with inline styles, which we'll see, but it's kind of strange to do that with CSS. You're passing a name, right? You're literally passing a name. But there are many different strategies. I found this one to be the one I just wanted to employ for the purposes of this book. And let's see what that looks like. So if you go to chapter 8. Don't worry, guys. We'll do some live coding here. And I hope your laptops are ready so we can have some fun. So this is not it. Here we go. Can anybody see that? Yeah? Okay, cool. So to-dos list info, right? These components now, they provide an interface for other components to be able to manipulate their behavior. Because with CSS modules, you can actually get protection now, right? Because you can't reference that particular element because it has a unique class, right? Now, we actually provide an interface of what things are able to be changed. This is great now because our components, when you build it in a particular fashion, and you don't want people to actually manipulate things in a dangerous way, now you provide an interface for things to be changed, right? So let's see how that looks. So in our styles up here, just like before, we had a to-dos list and a to-dos list item. We passed those particular keys to our to-dos list, and up here, P styles, which is short, I just called it prop styles, right? You're merging the prop styles and the internal styles together, right? So you can see in the class name, right? You have the styles to-dos list, and then you merge it with the prop styles to-dos list, right? And can you guys kind of guess from the code why I'm doing prop styles second and the other one first? I'm not dancing, huh?
Because the parent overrides.
I'm sorry, I didn't catch that. I heard something about scaling. Well, think about it this. I'm so sorry, I can't. For inline CS? Overriding, thank you. I heard scaling, my apologies. Yeah, that's exactly right? You don't want your style to take precedence over the styles that are being passed in. You want the consumer of your component to take the higher precedence, right? There's something a little bit quirky here. Why? Is because CSS modules, right? I'm not passing the actual styles down. I'm passing the unique value from the parent down. So you're running prone to this issue that you have actually class things being applied, right? And it's a bit non-deterministic because if you open up JSBin or just your favorite editor here, if you apply two completing classes on an element, right? Sometimes it's kind of hard. It's hard to know which one is actually going to take precedence. If you have background color red, background color green being passed down, and you're applying both of those classes onto the same element, who wins? Can anybody guess? Which one? That's what I thought. Thanks, by the way. Thank you so much for being brave and confident enough to just yell that out. That's what I thought. I'm like, oh, nice, perfect solution. We're in business. It wasn't the case. It sucks. You won't believe this. It's probably simple, but I had to experiment with it. The last style written in your style sheet, right? I was like, come on, how come it can't be the order of your classes? This would have been a perfect solution. I maintain unidirectional styles, right? But it's actually the order. This is the whole idea of non-deterministic resolution, right? You're not sure how these styles are actually being loaded into your page. So it's the last one. Even though it could be the first one, I can have 10 classes after it, but because if that class name is defined at the end of your style sheet, it wins. Sucks. But anyway, I still wanted to employ this idea of unidirectional styles to give it a try. And of course, there's a fix around this, right? You just increase your specificity at the parent level, so you just have two hash values passed down. But again, this is what I was talking about. You're kind of extreme as far as following this. So in many situations, because I wanted to adhere to this standard of unidirectional styles, as much as I love CSS modules, I started considering maybe I shouldn't use them, right? And this is the idea that I'm talking about, that I don't think we should be tied to particular technologies or toolkits. It's good to know the principles by which you analyze everything with. To have these clear guidelines helps you decipher what to use and when to use them. And one of the reasons I also wanted to employ this is because the next level of this, we introduced inline styles, right? Because with inline styles, it's easy because instead of passing class names down, actual strings, you're passing the styles themselves down. So let's see how that works. With minimal amount of work, we're passing our styles down via style because it's provided to us in our current Webpack configuration. We follow the same, we didn't change anything. But with inline styles, I actually got unidirectional styles now. Right? It worked. And Max mentioned this yesterday. Inline styles out of the box, they don't provide you a lot of the complex CSS things that you need. Media queries, animations, right? Pseudo selectors, they're not provided to you with inline styles. By the way, has anybody here used inline styles in production? In a large application? Nobody. See, this is crazy. Yeah? That's in production? That's amazing. What was your experience like? Laughter? Is it good or bad laughter? All right. Yeah, actually, I had a really interesting task. Like, I had a project, and we need to build everything with inline styles, but that's what they wanted. And you'll see in the next chapter, I just built this little nice theming library for inline styles to achieve what we needed, and I had a lot of fun. I actually had a lot of fun building it, but I don't think I would use it. But what's cool is that it gave me everything that I needed. And in fact, as Christopher Shadow mentioned, and including all the other things that I added onto his contract, it fulfilled everything. I got unidirectional styles, I got dead code elimination, because with inline styles, you can actually say which styles are referenced, which ones are not, so you can remove those particular styles, right? You have constants that can be shared between JavaScript and inline styles, obviously, right? So you get everything. But what was interesting, that it just didn't feel right to me. As much as I love JavaScript, it just, at the end of the day, still didn't feel right to do inline styles. But we used it, I loved it, but it still something feels a little bit iffy about it. And we'll talk about that soon, why I think CSS is probably still the better approach, and maybe CSS and JS I think has a lot going for it. Things like style components are definitely something to pursue because I think they have a much brighter future considering how much browsers have had many, many years to optimize CSS parsing and rendering and inline styles haven't had the same treatment. Right? And CSS Next, it's amazing, right? So I think it's kind of, if it was me, I would double down more on CSS itself and tools that at least compile down to CSS over something not. But anyways, inline styles, and there are some situations that are very useful, which we'll see. We'll do some live coding together with. But something that was said yesterday that I'd like to kind of make clear, with inline styles, you do not get pseudo selectors, you don't get media queries, but very simply, there are many libraries out there that makes inline styles fully fledged. Has anybody heard of these? Has anybody used them? The gentleman in the back who uses in production. Do you use a library to make inline styles more full-featured? No? So a simple one, it's quite robust, it's built by Formidable Labs. It's called Radium, right? And with Radium, you just wrap your entire app, this thing called style root, and we can actually inject CSS into our global. We normalize, we inject our global styles now, and in our to-dos list item, we could see here in our styles, we actually have hover states. We get all of this. A few things like toggling, maintaining steady, still have to do it in JavaScript, but it's pretty much there. And with actually I didn't have to add any extra work when I already had inline styles working. It was just that theme wrap, the style root, and your components, they get enhanced with this little Radium higher order component function, and that's it. You have that. So in cases, and we'll kind of talk about where inline styles could be useful, if you have, like, let's say, a single page and you have a lot of dynamicness and that need to change on the fly, inline styles works flawlessly, and we'll see that here in just a short bit. So, anyways, I'm sorry, guys. Obviously, I'm keeping this super high level. If you feel the exercises go extremely low detail, and I just don't want to go that deep level for our talk here. But you can talk about it. Talks about how all these different strategies are employed within the different strategies to kind of maintain the same type of principles. This is the part that I'm most fascinated about, and I think it's really important. And if you're working with React, I don't see why you shouldn't be employing this. Angular, I don't believe it has it. Last time I have checked, they haven't been using. They don't have a tool like this. I don't think Vue does. So if you want to build a project like this and contribute to the open source community, I think it's awesome. And here it is. Well, before we get there, let's talk about this one. Let me just install these dependencies. Chapter 9. In this chapter, what I wanted to do was, we talked about theme support, right? I wanted a way to have a theme, and I wanted to have variables, and I wanted to be able to have users change the entire site, because I love real-time capabilities. I love 3D graphics. I love that real-time interaction without some sort of complex build process, right? And I wanted the ability that a user can click on an element or change a particular profile setting, and the entire application state changes. It's much more dynamic, and you don't need any sort of refresh. With inline styles, this is super easy. And I built this little library called theme wrap. You can kind of think of it as like a GIF wrap, but for your app. It just provides a theme. And all you do, you wrap your entire app with the theme wrap provider. I think we saw something very similar to this. Max built this for styled components. I'm passing the theme that we had from earlier. Same exact theme, and all of our styles now become a function, and they get theme passed in, right? So if I change any of those variables, like the primary color, right? The user wants to say, you know what, I don't like blue, I like red on my application. They just change that primary color variable, and the entire app just reacts without any sort of refresh at all. It's a pretty pleasant user experience. So once this loads, we can kind of go through this really quickly. So you can see here, all the components now, we kind of decouple this entire dependency of requiring our theme and our variables in through every single component. They just become functions, and by having everything wrapped inside of a theme wrap provider through React's context, everything has our variables provided as long as they're connected. So just experiment with this really quickly. Any questions so far? Has any of these concepts, have you run across them? Have you employed them yourselves? Or is there something that maybe you just find like really strange about some of the concepts that I've talked about? Do you think something like unidirectional styles is something you would use? Yeah. Yeah, there's two people. By the way, thank you for making this more of a conversation. I hate this one-way conversation, so this is good.
Yeah, I have used these unit action styles, but the problem that I run into them that when to make generic components and when to make these unit action styles, right?
Yep.
So where you have a button component, you have a navbar component, and then you are using them in particular different pieces of your application. Then you are writing unit action styles at that point of time. Then sometimes it makes sense that you write those unit action styles, but you are overriding those base styles. So sometimes I feel that just to leave all those generic styles and include them in your unit action styles so that it makes more sense because you are overriding them anyway most of the time.
Yep.
That's a problem that I run into.
Yeah. No, that's actually that's a practical concern, right? And we don't want to talk about theories here. That's something we run into all the time.
Exactly.
So, but again, this is what I was thinking, is that instead of being, like you mentioned you're building an application, right? And I understand if that's your objective is to ship out an application, That's your objective, right? Maybe you don't want to build such generalized components, but I'm just thinking that, hey, while you're already in the effort of doing this, what if at the same time you're creating generalized enough components with same defaults, right? With decent defaults, and then you provide an interface that when I bring this component into my application, I just override what I need, right? So that's the way I think about it, right? I think to myself, hey, I'm building this. This is reusable, and I want to build another site that has a similar functionality. Let me just create a general one, right? That's kind of what I think about.
And again, that's a problem that comes up, that you think, we actually think that we are making unified styles. Then we think to make them generic, right?
Yes.
How many times you're going to make it generic? That's the main problem that comes up.
Perfect. I love that, because the next one is the idea of presentable and documentable. Really plays well to this. It's good to build your components in isolation, because from the beginning, you think about that, right? And I completely understand that it takes a little bit more effort ahead of time, but if you're working with a team of 2 or 3 people, that's okay.
That's okay,
right?
Yeah.
But we all know, right? When we work a lot, in my experience over the past couple of years, when I just travel around and work with different teams, one of the biggest pain points that I constantly encounter is that one individual thinks this way, one individual thinks that way, but if we have that clear guideline, and I know it's a little bit upfront work, but it just makes it so much better. And more importantly, we have our application, which is awesome, but all the building blocks are also shippable products, right? They can be consumed, and that gives me great joy, right? So I always think about how much joy do I get from this, which gives me a tremendous amount, and then some components are absolutely crap. I don't want it to be reusable at all. I don't even make those general. But this is that's a really, really good question, and I really appreciate the practicality of it. I just think about, what does it take to make this thing general, and then I bring it into my context and manipulate it. The problem is, what I've seen, it's easier to make a decision if you build a component by isolation already, because you're already in the right context, you're already in the right environment, right? And then you think about, how am I going to bring this into my application? Versus what I've seen is that you start with this large boilerplate code, and man, good luck trying to make that generalized.
You just cannot do that.
Yeah.
It's so difficult.
And you're afraid of just breaking a lot of stuff. So I just think that, again, having a clear guideline, clear contracts amongst yourselves, the organizations and the teams that you're working with, from the get-go, really, really helps.
But don't you think when you're making isolated components, we have already defined but we have exactly done that when we were making those generic component classes, right?
Yes.
So isolated components, the difference is with the component, you have multiple components combined.
Yes.
And you have created a whole new component, composable component that
Yes.
consists of more than one component.
Yes.
You have made it generic. Now you want to think how to integrate that into different components.
Exactly.
Rather than just building, the straightforward components like button and all that Bootstrap another application does. But the problem that comes is if you want to make them generic by writing into your application, you have to override them.
Yeah, good luck with that, right?
Exactly.
I mean, I won't mention which library, but I was just using this a couple of weeks ago. Override some of I was using a modal, right? And the moment I kept switching the device, it was so heavily tied to how the body tag was employed that it was just a non-usable modal. And this is for a large library, right? So I think about, man, this thing is built for the open source community, but it just doesn't have that empathy that I was looking for, right?
Exactly.
That for it to be able to work for many different contexts, and it's just flexible enough, right? So I just think for a lot of these large applications, if we just start with the right foundation, the right setting, it helps us get there. I'm not saying we should aim for perfection in the beginning, but at least the right trajectory will get us there.
At least just make a design patterns before we go ahead and make shippable products, so that we all agree to certain amount of directions and the UI contract that you just gave.
Absolutely. And I think these concepts, this contract that you lay out in the beginning, are, from a business standpoint, from a designer standpoint, are intelligible and it makes sense. So designers can also think about the same sorts of things, right? And it's easy to pull requests and actually build into your project. So, and again, I think that right trajectory is huge.
Exactly. Thank you.
Of course. All right, so we talked about this live reloadable theme, right? So we were just talking about design. I think whoever's a designer here, this is probably a designer's worst nightmare, is this list that I just created. This is why you should not let an engineer design anything. So yeah, anyways, you saw the original one was quite grayscale. I like just simple shades, this black, white, this looks good to me. But this one, this person wanted to get super fancy, right? They have the primary color red, secondary color is green, tertiary color is blue. They love colors, right? But every time you click on this, right, what I'm doing is changing all the themes variables, right? And you can imagine that you have an entire application with a few clicks of some basic configurations, your entire app just changes. So I think this is something really cool. It's super easy, and just look into the code. It's theme wrap. It's so simple to build something like this, right? And I think inline styles, if you need something like this, if I need I just think about it, if I need a single page, and I need some customizable features for a user to change, this is great, right? I don't need some complex build process to be able to change my styles on the fly. Cool? I know this is kind of a pretty hideous UI, but it is what it is. All right. And I didn't get your name in the back. Saeed? Zahid? Zahid? All right. Sorry if I missed. I have a hard name too, so my apologies if I butchered that. So this will help what you were getting at. So you brought up a very good point about oh, it's already here. npm run storybook. For those who are React developers, how many of you use Storybook? Right? What's your experience like with it? If I'm sorry, I would love to hear.
Hello?
Yeah.
Yeah. I use Storybook as both a dev environment to play around with the new component that I was building, and also to ship it out as a static page where other people can check it out. And I also used knobs and React docs to generate a documentation. So it's pretty easy. You just write the comments in the prop types and it generates the docs for you.
That's exactly right. So this actually answers, I think in a very direct way, the concern that you were bringing up, and I think the solution that we're talking about here. I think if you start with Storybook here, let's see how it works. It's really easy, right? It provides an interface, an elegant interface, where you can build your component in absolute isolation, right? And you can see the dependencies. Is it affecting things outside of it? Because it's by itself, right? It's really easy to think, it's much more clear to know what you're doing, right? And also, out of the box, it gives you documentation. So now, from the get-go, you're building components that play well in other contexts. And I like to just kind of show that here. It's really, really simple. So, for example, our components here, and one thing I love, probably many of you follow, I co-locate everything that's component-centric inside of that directory. So, styles. We have it called story, and I just have that file called a story. And what this is, I create a story for a to-dos list, and I have this thing called add with info, the default view. Here's what it is. Renders children. I generate some children here, and it's there. This thing accepts custom styles, and these are the keys that it requires, right? And that's it. I created 3 stories, I documented this, I built it this way, and now I can give it to a business, I can give it to the designers, and more importantly, how many of us have massive amounts of UI elements in our code base, but even as developers who know the code, we don't know what those components are, right? I have to go talk to somebody, say, hey, oh, wow, you already wrote that? This is crazy, because of lack of documentation. This way, your documentation is perfectly aligned with how you're building the code, or building the component. So really simple. You can see that I just created a few stories here. Let's see what this looks like. Just a few moments. this is something that whether it's Storybook or something else like similar to this, I highly recommend employing this right from the get-go of your project. All right, we are in action. There you go, right? So this is the default view. You see I have a story for to-dos list. It renders its children. It accepts custom styles. Maybe I shouldn't accept these styles because these are awful. To-dos list info, you can't see it because, see right here, immediately I could see I did something wrong here, right? It's right behind this. So that means this particular element, it has text aligned right or float right, right? This is something clear. You wouldn't even notice this as you're building it, that you did something that could have broken its principles, right? I'm like, oh man, I didn't think about this. I put the text align on the component itself, right? Immediately evident that I did something wrong here. And by the way, this is literally within the code. As I'm building my components, I build them in this interface, completely by itself. So here it is. Here's the to-do list item. It accepts this. Here's the completed state. Obviously, the default styles are ugly. And this one accepts custom styles via props. Accepts custom styles via the other props, so completed ones. And at the end, it handles a click. You can see this toggle to do at the bottom. And one of the last chapters, it shows you how to just build this up. It's super easy. But what's cool is, look at this. You get documentation. Your prop types, everything is provided for you here, right? I could see that here's the handle clicks. It accepts P styles. It's not required, right? Here's the code to generate it, right? Already provided to you as you're building the components. Pretty useful, right? So this is one of the strategies that I've been employed within our projects. Maybe you don't have such strict guidelines that you have to adhere to these guidelines that you're setting out in the beginning of the project, but this tool has been amazing in building proper UI components, and I highly recommend just introducing it in your toolchain. So I hope this little journey of building a simple application through different strategies, not so much tied to the technology, but the principles, right? There's a lot more, honestly, this is obviously a short amount of time, but there are a lot of different principles that are on there, and I just try to explore them and see what works for you. So I hope you found it useful. I hope you're able to use it in the future. Whether it's right and wrong, please give me the feedback. I can save time, others can save time, and we can build better user interfaces together. Thank you so much. I know, obviously, I engaged you guys so much throughout the conversation, but any questions? Yeah.
Yeah, first of all, really an interactive talk. Thanks a lot for that.
Thank you guys. You made it interactive.
It was a pleasure having that talk with you. I have some questions about the React Storybook.
Yes.
So like we create with BEM, we create block, then we create element, then modifiers.
Yes.
So modifiers are used to, for variants of the same block or element component. So with React Storybook, I can create a block or an element, and I can create different stories that act as modifiers.
Yes.
Exactly. I just have to pass the CSS for that.
Exactly. That's exactly right. Right. And by the way, obviously at the end of the book, we were using inline styles to document it. But it could be anything, right? It could just be just traditional CSS. And that's what I'm trying to get at, is that I think we're all chasing the next bleeding edge technology, but sometimes certain things help us achieve our goals faster, right? But with what I love about Storybook, it's just a way to build in isolation and provide a documentation from the get-go. Absolutely. If you want to use to follow the BEM approach, you can do that. You can document, say, here's the top level, here are the elements that you can modify, provide that interface, and here are the modifiers that you can switch. That's a great example for that.
Thanks. For these modifiers, if I'm creating a story, would I be adding those modifier classes to it, or I don't need to do that because all those styles are obviously applied in the inline style level?
Yes. No, I would create a story personally. It takes so little, and you're testing it anyways. You want to see if the modifier is working, right?
Exactly.
I recommend every single thing that your component can do, document it. Because you as a developer are going to enjoy coming back to your own code base right? Because we all know that. Forget about other people's code bases. Even coming back to your own code base 5 or 6 months later can cause a lot of pain. So documenting every single one, and instead of looking at the source code, sometimes it's just nice to look at the visual interface and all the different things that it can do. I recommend writing a story for every single functionality.
And it works with every custom React component, or I think you have to create a React component and then apply your stories to it, right?
Exactly. It's within React. And that's what I'm saying. It's such a great tool that any of you who's interested, we should build this out for other things as well. Or just figure out a way to make it more generalized.
It surely looks really promising, because the problem that we comes up with creating BEM classes, we have to take care of ourselves to create all those modifiers that don't create problems with or don't overlap with other modifiers. So, but this is doing, you just have to create stories.
Absolutely.
And it really helps us. It really trims down all our effects.
Yeah, and I just love that once you have a particular set of guidelines, you just include that. And more importantly, I just love the fact that it provides you isolation. So I don't have to build a component within a context. I build it knowing exactly what I'm doing. I become so much more aware of what this component is actually doing. Because a lot of times I just do things willy-nilly, and then I realize later on, like, wow, this thing had much more effect than I expected it to do.
Exactly. And the other thing is just my personal opinion, that we really think that creating inline styles like atomic design methodology,
Yes.
or using tachyons as a framework, basically having all those CSS logic in your HTML as inline class names or styles.
Yes.
We really think this is the way to go. Just like we have these, we have style components and we have web components. So most of the component styles are either added into the same block level as a component or the inline styles.
Yeah.
So
No, I think honestly, I mean, I'm sure there are people that have used inline styles much larger, but I worked with it for a very large project for 8 months. I loved it, but even at the end of the day, I just didn't think it was the right solution. And I think even when Christopher Chaudot talked about it, it was just explaining, he was outlining some of the issues that they were running into and why it's a possible solution. I think CSS has a brighter future. One of the biggest things that I chose inline styles is because I wanted shareable constants. I want to be able to have interactive applications. With CSS Next, you can actually literally change your variables through JavaScript. So I think CSS, or I think CSS and JS with styled components or other libraries like it, are super powerful, and they're only going to get more powerful.
I think we have gone from a phase of creating BEM classes and then have structured HTML with class names with BEM or other methodologies to writing CSS and JS with style components and other similar methodologies, and also this React storybook. The web has really grown up.
Absolutely agree with you on that. But it might change. So I love change and I love learning. So we'll see where things go. But my opinion, I got to work with inline styles and I love writing everything in JavaScript. But I think having JavaScript code, being compiled onto CSS is better than having just purely inline styles. That's my opinion.
Exactly, I agree with you.
Cool.
Thanks.
Of course. Any more questions?
Hi, great talk, first of all.
Thank you so much.
My name is Deepak. Okay, so first of all, thank you for making the book available for all of us. That is really kind of you.
It gives me so much pleasure because I had such a great time.
I hope it helps a lot of us.
Absolutely.
Okay, so from the U&I contract, one thing that really intrigued me was the unidirectional styling that you talked about, right? So you talked about converging to the lower level, so that the parent has it, and then we converge it to the lower level so that the styling gets direction in a particular direction. So I just want to ask, when I'm making a particular component and I want to have a certain styling that is growing outward, like it has an outward convergence, should that be my parent component? Like if I want to nest components inside, and there's a basic component that I want to have a certain outward converging styling, should I make that as my parent component and then nest inside?
Yeah, that's exactly right. That's the approach I've been taking. I'm really tinkering with this idea and I'm trying to take it to the extreme. But yeah, I think about it in the same way that I think about data now, right? Data should be just funneled down, and I think about my style should be funneling down. And I know it seems easier, right? In the same way that before we had components just randomly mutating the data of another sibling component or had no type of interaction with one another. I think if we treat our styles in a similar fashion as data, If we really stay true to that, I think it answers your question, right?
I believe like theoretically it sounds very good. Like, okay, a particular component is not, getting into the way of another component, how that is behaving. But like, as we go on writing more and more components, do you believe that, modularizing it so much that even when I have to write a component that has that has a single outward converging capability, I have to convert that into a into an individual parent component just to achieve this particular functionality?
And I think this really comes down to intuition. And I think one of the best tools that we have as humans, as developers, is our intuition. And I'm of the opinion that your intuition is honed down by experience, right? So you're right. If we think theoretically, right? Right now, I just stand here and I want to think about all the truths of the world. I'm like, yeah, break all the components down to their basic atomic level. But when I come to the real world situation, my intuition changes a lot faster than this theoretical concept. So I think you naturally find a balance as you're experiencing it, that you realize, yeah, I have a to-do list item. Should I make the text itself into another component? Probably not. And in fact, I probably will have the list and the list item together because I don't have another list in my application. But I think that really goes down to intuition, right?
Yeah, makes sense.
Yeah.
Thanks a lot.
Any other questions? Looks we're all clear. Good to go. So thank you so much, guys. I appreciate it.
Thank you so much, Farad. And that was a really great talk. And now it's the time to break for the tea. And we'll try to, as we are ahead of time, thank you for that, Farad, as well again. So we'll try to come back here at 4 o'clock so that we can start with the remaining talks and party as well. Cool? So let's get back here at 4 o'clock and let's start with the schedule. Thank you so much. here comes the last keynote of the awesome JS Channel conference. So I think I should welcome Andrew. Most welcome on the stage. Thank you so much. Whoa. All is yours.
Is it working? Can you hear
It
me?
is
Okay,
working,
cool.
yeah.
Whew. Hello. So this has been a pretty good conference, right? It's been great. It's my first time in India. I've had a really great time. Everyone's been like really welcoming and very friendly. I think that was my biggest takeaway is everyone that comes up and talks to me is like the nicest person I've ever met in the world. It's pretty cool. Well, hi, I'm Andrew Clark. I work at Facebook. Specifically, I'm on the team at Facebook that's responsible for a library called React. Just so I have an idea, if you are a React developer, if you use React in your work, and you've used it to like shift products, could you just like raise your hand real quick so I can have an idea? Wow, that's bigger than I thought it would be. I kind of thought this is actually the first non-React specific conference I've ever spoken at. I've only actually ever been to one other one than this one, and so I kind of thought when I came here, like, oh no, what if no one's ever heard of React and I have to, like, are my slides going to be too boring for someone who doesn't use React? And then I got here and like everybody uses it, which is really cool. That's really great to see. You know, it wasn't so long ago that if I had asked that question, none of you would have raised your hand. You know, when React was released a little over 4 years ago, it didn't exactly set the world on fire at first. The reception wasn't that great, and I think, well, yeah, the part of the reason it wasn't that great when it was first released is that compared to most of the popular frameworks at the time, React was just weird, right? Did people think that React was weird when they first saw it? Yeah, I did. And it broke, you know, a lot of received conventional wisdom about what web development was supposed to be at the time. A lot of conventional wisdom that had been built up over decades. And so if you went to a meetup or a conference like this one, and you wanted to talk to other developers about React, the arguments both for and against React tended to focus almost exclusively on this idea of developer experience. So on like the anti-React side, the common refrain was like, why are you putting HTML in my JavaScript, right? Why are you violating the separation of concerns? And you'd hear this even from some of the more sympathetic voices. You know, React seems cool, but JSX is just gross. It's an abomination. I don't want to use it. And then on the pro-React side, it was all about how React's declarative and composable nature allowed developers to manage the complexity of building user interfaces. Oops, I keep going one ahead. Oops, sorry. Oh no, this clicker. I'll figure out how to use it here in a second. There. Managing complexity of building user interfaces. I recently started teaching the class at Facebook that we give to incoming engineers about React. And it's not just user interface engineers, it's like anybody who wants to take this class can take it. And indeed, to this day at Facebook, when we teach new engineers React, what we focus on is the developer experience, right? The primary feature of React is not the quote-unquote virtual DOM, which is a term I don't really like to begin with. And it's not the particulars of our reconciliation algorithm, for instance. Those are just details, right? The primary feature of React, and what all of these early arguments that we used to have about React would focus on, rightly, is that it helps developers manage complexity. By allowing, oh, it's going two at a time, I'm sorry. By allowing us to, maybe I'll just use a space bar, it'd be easier. Allowing us to model states rather than transitions, right? That's the core promise of React, and that's what makes it really great. So, 2017, React is clearly no longer a niche framework, as we can see from all the hands that went up that surprised even me. It still has its detractors, of course. It has still people who aren't fully on board. But at this point, we have enough adoption and we've won enough converts that even the detractors have been forced to take us seriously, right? We've officially arrived on the scene. And there's no better evidence for React's influence than to look at how the wider JavaScript landscape has changed in the last few years. Things like declarative programming and unidirectional data flow, things that were a little bit weird maybe a few years ago, these are no longer outliers. They're no longer weird. These are mainstream concepts. Frameworks that predate React, like Angular and Ember, in the most recent versions have evolved in a decidedly more React-like direction. And of course, you can also see React's influence in newer frameworks like Vue, Inferno, and Preact. And these libraries clearly are in the spirit that was pioneered by React and offer many of the same benefits and even in some cases the same API. So what I think we've observed over the past few years is a convergence among the JavaScript libraries and frameworks, a convergence around developer experience. The major libraries have become more and more similar to each other in a lot of ways. They offer a lot of the same benefits. And as a consequence, it's become maybe a little more difficult to choose among them. Who here has had trouble trying to decide between React or Preact or Vue or any of these frameworks? Anybody? Yeah, I feel like I've gotten several questions at this conference about that. It can be tough because like the baseline quality of all these libraries is really, really high. It's actually pretty hard to make a bad decision. But recently, I would argue that we've entered the beginning of a new phase. And it's one that's marked not so much by convergence in developer experience, but rather divergence in another area, and that is performance. The focus, I feel, this is a feeling that I have, has really shifted recently to performance, and this is very exciting to me, and it's a good sign that the JavaScript ecosystem is maturing. And what I think is I believe that we'll start to see frameworks differentiate themselves by the performance trade-offs that they make. So for developers, choosing between frameworks is going to be largely about choosing which framework best optimizes for the particular performance characteristics that most align with their needs. So if we think about performance, what are some of the ways that we can make our apps faster and more responsive to users? Well, one is you can optimize your code so that JavaScript engines can run it really fast. We heard there's a great talk earlier today about just that. You can minimize the amount of code that you send to the client by choosing really small libraries and just like writing more efficient, smaller code in general. And this is the value proposition of something like Preact, which offers fewer features, but in exchange gives you a smaller bundle size. And with code splitting, you can also split your app into many bundles so that you only ship the code that you need to render a particular view. And with tools like Webpack, that's become a lot easier. Another thing you can do is you can shift work from runtime to compile time, both so that the code is faster, and then in some cases so that you can ship less of it, right? There's an interesting new framework called Svelte. Has anyone heard of this one? It's based entirely on this idea of like having no runtime and just doing as much as possible at compile time. And there's a Facebook project called Prepack, which is not a UI framework really, but it's very much in the same spirit. And then, of course, there's also caching. You can use caching to reduce the time spent fetching resources over the network, for example, using service workers. Now, this isn't a complete list, but these are just like some of the most common strategies that we use to improve performance in modern-day web applications, and we've heard about pretty much all of these at this conference already. Now, what's interesting about this list is that all of these strategies kind of belong to the same category, right? All of these are really about reducing the total amount of work that it takes to load and render your app. Whether that's reducing the amount of time it takes to load resources from the server or the time it takes just to render the code once it's already loaded. But at Facebook, our JavaScript engineers realize that this isn't the only way to improve performance. Reducing the total amount of work is not the only way to improve performance. We observed that there's a whole other category of performance strategy that is at the root of many of the hardest, trickiest problems that we face. But it tends to receive less attention than some of the more obvious things that I just listed. And it's an area that JavaScript libraries today aren't really that well suited to address. And to illustrate this idea, I'm going to give you an example of a real-world problem that we recently faced at Facebook. So recently, the videos team at Facebook was attempting to diagnose a performance problem they were having with video streaming in newsfeed. So video has become very important to Facebook in the last year or so. Under certain conditions, playback was stuttering, and they needed to figure out why. So if we think about the way that the video player works, is it fetches a small chunk of video from the server, and it adds it to the end of the stream. And it needs to do this periodically, of course, over and over again for the length of the video to ensure continuous playback for the user. And if one of these chunks takes too long to add to the end of the stream, it's going to run out of video, and the playback will buffer so that it can catch up. I think we've all experienced this before, right? Clearly, we want to avoid this. So you can think of it like this. For each small chunk of video, we have a deadline, which I'm going to represent with this red line here. by which time the video needs to be fetched and processed. The top part of our timeline is the network, and the first thing we do is we ask the server for the video. This network request takes the bulk of our total time. The bottom part of our timeline is our JavaScript thread, and that's where we execute the code to append the video to the end of the stream. And this is on a separate thread from the network, but of course we can't start processing the chunk until we receive it from the server. So there are a variety of things that could be happening to push us past our deadline, and one is just like the network takes too long. It takes too long to get the video from the server, and we push past our deadline. That's obviously the first thing that you probably want to check if you're having streaming problems, is the network. And this is what the videos team did, and they were able to rule this out pretty quickly. In this particular case, even when the network was really, really fast, we had plenty of time left over to process the video, they were still observing this problem. So that's not the issue in this case. The second thing that you'd want to check is this bottom part of the timeline, the JavaScript code. Is the code to process the video executing too slowly, taking too long to run? And they were able to rule this out as well. The JavaScript for the video player is actually like really, really lightweight and small. It's mostly just a thin wrapper around native browser APIs. So there's not much room to optimize this bottom part. There's not much room to optimize this code because it's already really tiny. And even if we optimized it to the extreme, it's not going to account for why we're missing this deadline. So the problem isn't the speed of the network, and it's not the speed of our processing code, then what could it be? I didn't hear that, but I assume it was smart. Platform? Yeah, maybe. Sorry? Could someone repeat that? I couldn't really hear it that well. Memory. Yeah, maybe. Any other ideas?
Maybe the UI has not reflected the change.
Yeah, maybe the UI is inconsistent. Maybe we're doing the work, but the browser hasn't caught up or something yet. Okay, so those are all really good suggestions, but it turns out that the real problem is that this bottom part, this green thing right here, that's our processing code. The real problem is that code wasn't even getting scheduled. It was never even beginning to start executing because it was being blocked by other JavaScript work that was already running, right? And because JavaScript in the browser is single-threaded, when we receive video from the server, if the thread is already executing some other task, then we have to wait for that task to finish before we can even begin processing. And this is exactly what was happening. So specifically, what was blocking the video player was the rendering of the comments interface under each post in the newsfeed. It was the comments that were slowing that were interfering with the video buffering, which was a pretty interesting result. Maybe not the first thing that someone would think of, right? So the comments are blocking video streaming. Not good. We could try to solve this by just making the comments interface faster, right? That's one solution. And of course, we should absolutely do this. We should absolutely try and make our code fast all the time. We should use all of those strategies that I laid out on that slide a few minutes ago. We should do everything to make our code as efficient and fast as we possibly can. But of course, there's a limit to how much we can do this, right? There are diminishing returns. There's a limit to how much just making stuff faster is going to help in situations like this one. Because if you think about it, the core problem here isn't just how quickly the comments render, right? The core problem is there's no way to interrupt these large blocks of work with a higher priority task like video streaming. There's no way to interrupt it. So fundamentally, problems like this, these are not fundamentally speed problems, but a problem of scheduling. Another way of saying this is that it's not the amount of work that is the root problem, but rather the order and the time in which we're doing it. More specifically, what this video streaming example illustrates is that synchronous scheduling blocks work. Whenever you block the main thread, what you're blocking is things like scroll events, and that leads to like scroll jank, right? Input events, which leads to delayed feedback. You're blocking animations, and that leads to drop frames. No one likes that. And really, you're blocking any other JavaScript that you need to execute when you have these large blocks of work. And yet, unfortunately, blocking the main thread with these large synchronous blocks of work is really all too common in JavaScript apps nowadays. Newsfeed happens to use React, but virtually every JavaScript library out there today suffers from the same issue. This includes the ones that do really, really well on speed benchmarks, because it really doesn't matter how efficient your code is if you're going to schedule lots of it in an uninterrupted sequence. So what we've come to realize is that this problem lies at the heart of so many of our performance challenges. And yet neither React nor any of these other JavaScript frameworks today provide great ways to address it. So let's imagine what we would do in an ideal world, how this timeline would work in an ideal world. So what we really want to do is we want to split these yellow chunks of work, split that giant block into chunks, and interleave it with other tasks, right? So now in our example, when the server responds, we can interrupt the comments interface, process the video, then resume rendering. And this strategy of working on multiple things across the same period of time by periodically yielding to higher priority tasks is a type of concurrency called cooperative multitasking. This is not a new concept that we have invented. This is found all over the place in other domains of software engineering. But the reason this strategy isn't more common in JavaScript apps is because it requires you to write code in a particular way, such that it can be split into chunks and executed asynchronously rather than synchronously. I like to think of like synchronous scheduling as like do it now scheduling. It means you have to do it immediately, right when the user right when the code is right when the instruction is given. Historically, this hasn't been easy to do using the major frameworks, is to switch from synchronous to asynchronous. And we want to change that. As it happens, React's declarative component-based API already provides the perfect abstraction for splitting work into chunks. We can just split it at the component boundaries. So, the React team realized a while ago that async rendering was something we really, really wanted to add to the library, and that it had the potential to solve a lot of really interesting problems for us. But it turned out that adding async capabilities to the existing or original implementation of React was really hard. It just wasn't designed from the beginning to work that way. So this happened, several years ago we had this realization, before I was on the team. And after lots of research and planning, starting last year, we decided to do something really ambitious, and that is we rewrote React. We rewrote React. And over the last year, we rewrote it from the ground up with a new architecture that's designed specifically with async rendering in mind. The code name we used for this project was React Fiber. You may have heard about this in other talks that we've given over the last year or in blog posts, for instance. But now that we're preparing to release this to the world, we're going to just drop the fiber and we're going to call this React. This is just React now. Internally, this new version of React schedules work using cooperative multitasking, like I described. But externally, it presents the same exact component API that you already know and love. And this means that we have the potential to solve complex scheduling problems like in our video streaming example with hopefully minimal changes to our code. The first release of React that uses our new engine will be React 16. And just a few days ago, we released a public beta so that developers can start adding it to their apps and help us find any bugs or inconsistencies before we cut the final stable release. And so far, the reception has been really positive. I'm really excited about this release. It's the culmination of a lot of really hard work by the entire team over the last year. So hopefully maybe you've read the blog post that we released a few days ago, and the issue. And I'd love to just share with you a quick summary of features that are going to be in this React 16. The first one is support for fragments. What are fragments? So a fragment is a group of sibling components. Have you ever had the desire, I feel like maybe you have, to return multiple components from your render method? Anyone? So what do you have to do now if you want to do that? You got to wrap it in the container. I have a feeling most of you have experienced this before. And this is annoying, right? Like, can anyone name some reasons why this is annoying?
JSX is internally create element, and one function can return only one argument, so it returns one tree, one component.
Sorry, I didn't really understand.
Okay, so we write JSX, like our component tree in JSX, and the moment you cannot have two sibling
JSX,
JSX,
just syntactically, JSX doesn't allow it. Yeah,
Yes.
that's one problem, of course, yeah. Is there any other reasons why this is annoying? Stack rendering. Okay, it's recursive. Any other? What else was shouted out? You just don't need them. Why am I adding junk to the DOM? Another common one is like tables, right? If you want to like return 2 rows of a table and you wrap, that's just going to mess with the layout if you're trying to wrap it in some other thing. Or flexbox, right? These containers are not transparent. They're going to affect the layout if you try and do, if you're using a layout system like Flexbox. So yeah, really annoying. And the truth is, like, it just happened to not be that easy to implement in the previous version of React. It was a very, like, I think it might be like the first and most requested feature of React is to add support for returning multiple components. And it just happened to be really annoying to implement in the previous version. But now, all you have to do is return an array. And this is, this has long been one of our most popular feature requests. In the future, for now, you're going to just return an array. In the future, we're probably going to add some sort of special syntax to JSX, so you don't have to like do array, comma, or comma, comma. But for now, we do support this, and yeah, I think it's going to be pretty cool. Similarly, you can now also return strings from render too, which is not the same as arrays, but similar, kind of similar because a lot of times you'd have to like wrap things in spans, right? And now you don't have to do this anymore, which is really nice for things like internationalization or any kind of abstraction that you build over strings. So no more unnecessary spans either, so that's going to be really cool. Okay, also coming to React 16 is improved error handling. This is a really exciting one. We released a blog post a few days ago all about this, and I think this is what most people have been most excited about, it seems like, over the last few days as they've been trying out the beta. So the way this, I can explain this, the way this works is that when JavaScript throws an error nowadays, a few things are going to happen to your app depending on the nature of the error and where in the program it is thrown. And I'm talking about really any JavaScript app here. Sometimes you throw an error and it just totally crashes the app, right? And the user has to refresh the browser, and that's not good. Other times it might cause like a momentary bug, like some weird inconsistent behavior, but then like after a while the app just kind of recovers, right, and just keeps working as if nothing happened. So for example, when an error is thrown inside an event handler, that event might not be like processed the way you're expecting, but because it's in like a separate event, the error is not going to like bring down the whole app. So that's another possibility. And then the other one is that like the error happens and it leaves the app in this broken, inconsistent state and it just like stops working. And some parts of the UI might still be responsive. Like for instance, you might be able to type into a form field, but then when you try and submit it, nothing happens. Also, a really bad situation is like the UI just starts showing this incorrect or inconsistent data. And this is maybe the worst case because, you know, especially if we're working on something like a budgeting or payment form where accuracy is just really critical because not maybe immediately clear to the user that an unrecoverable error has occurred. So if you think about it, this kind of weird behavior is a bit unique to the web platform. Most other environments don't attempt to like keep running your app in a corrupted form after you throw an error. And we found it caused a lot of really confusing bugs in React that just like made no sense. Has anyone ever gotten like a really cryptic, confusing like internal error that got logged to the console when something weird happened, like you return null or whatever, and you're like, what the hell is that? That doesn't make any sense. That's really annoying, and that's because it's like there's some broken thing inside of React, and we weren't surfacing. It was corrupting some internal state, and so it surfaced itself in these really weird, confusing, cryptic things that weren't immediately clear how to solve the problem. So we want to fix this, and we're doing this by introducing a new behavior for unhandled errors. So now we wrap all user-generated code in try-catch blocks, so that if any component throws an error, it's not going to corrupt React's internal state. So now if a component throws an error inside the render method or a lifecycle, React's just going to unmount the entire application from the DOM at the root component. This might take some getting used to, just unmounting the whole app. But we actually think it's better to force the user to refresh the browser than it is to allow them to use a broken app or present them with corrupted data. It's better just to like unmount the whole thing and force them to restart. But if you don't like this behavior, and chances are that you probably don't want this to be like the actual behavior that you use in your app, we're also introducing a new way to capture and handle errors in your components called error boundaries. And error boundaries work the way try-catch statements do in normal programming language. They give you the ability to isolate errors to specific components and their children. So when an error is thrown inside an error boundary, the boundary is given the chance to render something else in place of that broken subtree. You know, same concept as the try-catch. So if you don't want your entire app to unmount at the root when an error is thrown, then just wrap certain parts of your sections of your app in error boundaries, and you can specify specific behavior for what you want to happen, and like render some sort of special error view. So in production, this gives you the ability to gracefully recover from errors that would have previously taken down your whole app or caused it to fall into an inconsistent state. And in development, it also gives you some React is going to give you some additional information that is really useful for debugging, including a full component stack that describes exactly where the error was thrown in your React component tree. So to be clear, this isn't like a JavaScript stack, which you'll also still get that. This is a component stack that shows you exactly which parents, what the parents of your component were, which is really helpful. Our engineers at Facebook have really enjoyed this feature. So right, yeah, like a try-catch statement, but for components. It's going to be pretty cool. Another big feature, portals. Portals are pretty cool. They allow you to render a child component into the DOM node of your choosing, while still maintaining all the other properties of a React child. And the API looks something like this. This is useful for features like pop-ups or modal overlays where the structure of your component tree is different from the structure of the DOM. Portals are not a new concept. People have been implementing portals in user space using lifecycle methods for a really long time. But previously, they haven't really worked perfectly with things like context. Now, because it's such a common use case, so we use it all over Facebook, we've built this feature directly into React, so you don't have to do any like lifecycle hacks. And you can just trust that these portals are going to work perfectly without any caveats, context and all. So yeah, that's a brief summary of React 16. Return fragments and strings from render, improved error handling, and portals. Now, we've been shipping alpha versions of React 16 on Facebook.com and Messenger.com to 100% of users for months, actually. It's actually pretty stable for a beta. And we're really, it's actually very stable for a beta. I always joke that before we released this beta, we were like, well, maybe we should do a sync to Facebook.com one more time to make sure there are no more bugs. And I was thinking, so our testing process is just ship it to 2 billion people before we release a beta. So you can be pretty confident that you're not going to run into any like horrible errors if you try out this beta. We take it pretty seriously. But please try it out and report any issues you find. We're really excited to get into your hands. And we'd really appreciate it if you can help us out. Has anyone noticed anything missing from this list? Sorry. I'm sorry, I'm having trouble hearing. Yeah. Async rendering. Well, I spent like the whole intro of this talk talking about async rendering, but it's not on this list. Wasn't that the whole point of rewriting React, is to enable async rendering? So yeah, it's true. React 16.0 is not going to enable any of the async rendering features. All scheduling is still going to be in the synchronous mode like before. And the reason is we want to focus on, first, on getting everyone over to this new implementation. This is a really big change to make. Even though, we've been running this in production for a while and we're pretty sure it's very stable and it mimics with, as closely as possible as the previous version so that there's no bugs. It's still a very big change to just swap out the entire core implementation with a new thing. So our first release is really just focusing on getting everybody over to this new implementation. And then after we do that, we can start to make some really fundamental changes. And the truth is, async rendering is a really big change. And over the next few months, our goal is to find a way to enable these new async features with minimal frustration on the part of developers. We take incremental migration really, really seriously. And the way we're going to do this is we're going to provide an API to opt into async rendering per component. Then that component and all of its children get to use the non-blocking asynchronous scheduling instead of the synchronous scheduling that is the norm today. And we're currently experimenting with this internally, for instance, to solve the video streaming problem that I showed you earlier. And you can expect this to be enabled in an upcoming minor release of React 16. It's actually part of the beta in an unstable flag, but I'm not going to show it to you here. If you're really adventurous, you can go find it. So even though we're not quite in the async promised land yet, we're getting there, but we're not quite there yet. I want to give you a sneak peek of some of the potential features that lie ahead. We think that async React is going to open up a whole new class of really interesting problems now that we have the potential to solve interesting problems that we now have the potential to solve in ways that weren't really possible with the previous implementation. The first one I want to talk about is this concept of off-screen or hidden prioritization. So one of the key features of async React is the ability to give certain updates or certain components priority over others. So for example, say you have like an input event, right? Like a keyboard event, let's say. And you have another update that's triggered by getting some response back from the network. Which of these would you say is more important? Which of these updates is more important, the input event or the one that came from the network? Input, right. Because if it takes a few extra milliseconds for the network event to be rendered, not a huge deal. But if it takes a few extra milliseconds for your keyboard press to trigger some sort of response, that's not good, right? That's going to feel really bad. So input events just have much higher priority. So async React at the core, one of the core features is the ability to prioritize updates. And we have priority levels for a variety of use cases, but there's one in particular I want to focus on, and that's this off-screen priority. Off-screen priority is just a really, 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 really low priority given to components that are hidden from users or off the screen. And you might ask, why would you want to render a hidden component? Can anyone think of any reasons why? Why would you want to render a component that's like not visible? Yeah, like a sidebar. Yeah. So the reason is that so that once it is made visible, once you do like click some button or click some toggle or click some drawer, once you do that, the content is already in the DOM and ready to display without any additional rendering work, right? There's no pause in between you clicking the button and the thing sliding out, and without any lag in the UI. So if you implement this strategy today, where you like pre-render something that's hidden, the problem is that hidden content has equal priority to the visible content. And that effectively means that those hidden components are stealing resources from the visible ones, which makes the initial render slower. But with off-screen priority in async React, hidden components are only going to be rendered after all the visible components have finished rendering first. So I'll give you an illustration of this. Say you have a tab switching interface, where only the active tab's content is visible. So you want to render the inactive hidden tabs into the DOM before the user switches to them, right? So there's no pause, to avoid any noticeable lag in the rendering. But you don't want those hidden tabs to steal resources from the visible content and make the initial render slower. So off-screen or hidden priority gives us the best of both worlds. And this same concept can be applied to a lot of different use cases, like modals or pop-ups. One interesting use case is list components. So high-performance list components, pretty much all of them will use a strategy called windowing. And this is how mobile apps, like on iOS or Android, if you ever see like a list view, they all use this windowing strategy. And that's where in a large list of items, you don't render every single item. You don't render every single item. You only render the ones that are in or near the visible window. And that includes its overflow buffer of components below or above the visible window so that they're ready to display once the user starts scrolling. So very similar to the tab switching example or the sidebar example. And deciding how large that buffer, that overflow buffer should be, is going to involve a similar trade-off, right? If the overflow buffer is too small and you scroll too quickly, you're going to see these gaps. You're going to see these like white spaces. Or you remember like in iOS, like in the first versions, if you like scrolled really fast on a web page, you'd get that like checkerboard pattern, right? A similar idea. Like you might start seeing gaps if you scroll too quickly in these lists. But if the buffer is too large, then you have the same problem we were discussing earlier, where now you're stealing resources from the visible items, and like the scroll performance of the visible or the performance of the visible things is going to suffer. So as in the tabs example, with async React, we can render more hidden items into the DOM without stealing resources from what's visible. So finally, code splitting. This is another feature that is already possible to implement today using Webpack. But it has the potential to be even better with async React, and I'll try and explain how. So with code splitting, rather than load all of your app's code as one large bundle, certain parts are only loaded as they are needed. So for example, in a single-page app with many routes, it doesn't make sense to load the code for every route on the initial page load. Instead, with code splitting, you only load the code for the route that you're currently viewing. So the trade-off is that it makes the initial render much faster, since there's less code to load, at the expense of making transitions a little bit slower, because they now involve fetching that additional code. So one of the things to consider when code splitting is where you draw the lines where you split. If you draw them too coarsely at the route level, which is what most people tend to do nowadays, it limits the amount that you can split your bundle, right? Because like one route might still be really, really big. It also means that you can't render anything to the screen or start rendering any of the work until every single component for that route has loaded. On the other end of the spectrum, if you split things at a very granular level, like say you just split every single possible component, right? Well, now maybe you can start rendering work even while the network is still loading some dependencies. Excuse me. But the problem now is you get this like weird cascading effect. Have you ever seen like a view where like things are popping in at like different times, and so you like get all these weird relayouts, and it causes this really janky waterfall effect, and it's bad for the user experience. Do you know what I'm talking about? Yeah. That's not good either. It creates a really jarring user experience. And it also requires multiple render passes and possibly like a lot of layouts and browser paints, which can be bad for performance. So there's like always this trade-off between like how coarsely or how finely that you code split until you find the ideal balance. And there's really no way to escape this fundamental trade-off between a smooth user experience in which related components pop into the screen at the same time, right? And the ability to start rendering even while some dependencies are loading. You can kind of only get one or the other right now. But there just so happens to be a certain implementation detail of async React in this new engine that we have that we can use to mitigate this trade-off, and it's called the commit phase. If anyone watched Lynn Clark's cartoon guide to Fiber from ReactConf earlier this year, then you might already know what this is. But in case you forget, I'm going to give you a recap. So the way it works today is when you render a tree of components, the way React works is it calls the render method and associated lifecycles on a component, and then it updates the DOM. And we're going to repeat this process as we traverse through the tree. We render, update, right? So on and so on throughout the tree. Now, if we're doing all of this synchronously, this update the DOM as you go approach, update the DOM for each level of children in your tree, that works just fine if you're doing it synchronously, because the whole tree of DOM nodes is going to get updated in a single frame, because we're just doing everything synchronously and we're blocking. However, in an asynchronous world, this isn't going to work, right? Updating the tree as you go is not going to work, because what happens if that rendering work is split over a large period of time, like say several dozen milliseconds, which is what we want sometimes. But what happens if we're updating the DOM as we go, that update could be interrupted, right? Or it could be even aborted entirely, leaving part of the tree mutated, right, the purple lines, and the other part of the tree untouched. So that's not good, because now your UI is inconsistent. We don't want that. So instead, what we do to avoid this problem in async React is rather than update the DOM as we go for each level, we just compute the update that needs to be made, and we store it in a list of changes, and we keep track of that list of changes. Then only once the entire tree is completed, we flush all the updates at the same time, all at the end, in a special phase we call the commit phase. And because this commit phase happens at the very, very end, all at once, that means now we can abort rendering without letting the DOM get into an inconsistent state. So we aborted, but none of the purple happened, so nothing actually touched the DOM. This is perfectly fine. Okay, so that was a little bit technical, so I'm going to get back to the original point. So what does this all have to do with code splitting? So having a commit phase like this gives us the neat ability to start pre-rendering components. And that means to go through and call all of their render methods without actually mutating the DOM until we're absolutely ready to do so. So now, with code splitting, we can fetch resources from the server and then do rendering work at the same time without having things appear on the screen at different times by deferring the commit phase until all the dependencies have resolved. So again, this gives us the best of both worlds. So, how am I doing on time? Ooh, pretty good. So what I've just shown you is just a small taste of some of the features that we hope to bring to React in the near future. Again, these are just some of the ideas, though, that we're investigating. And I hope I've given you a sense for how the React team thinks about these types of problems and how we think scheduling is a really important area that React and hopefully or maybe other JavaScript frameworks will start to focus on in the next few years. We really think we've only just begun to unlock the full potential of what's possible with React. This new engine, React 16, I think is going to provide an amazing foundation for us to really start innovating in this space. And I'm especially excited to see what the React community builds once we put these capabilities, these new capabilities into your hands. It's going to be really great. So that's it for my slides. It looks like I have a good amount of time for questions. If anyone has questions, so we can do that now. Thank you.
Hey. So I read in the blog post that React 16 is also slightly kind about checksum matching.
Say that again, sorry. Checksum matching, is that what you said? Yeah.
And so currently in React 15, if you're doing server-side rendering, what you'll end up doing is you'll render everything on your server, push it, and then even the components that will not change, you'll still have to ship the JavaScript for that in your bundle because otherwise the checksum wouldn't match, right? And then React DOM would be inconsistent. So now that that's not really a problem, can you actually not ship all of the components? Like, can I just say that I'm going to ship this part which is dynamic and all of the static part, I'm just going to ignore it because...
Yeah, that should work. And the reason is we don't use a checksum strategy anymore. Right. So for anyone that doesn't know, the way it used to work is like you would render on the server, and then this would generate like this checksum hash. And then you would render again on the client to attach like all of the DOM listeners and everything. And you would generate the checksum on the client as well, and then you just compare those two checksums to see if they're the same. And if they're the same, then you're good, and you can just assume everything's fine. And then if they're different, you say, oh, something went wrong, and you have to re-render the whole tree. So we don't use this strategy anymore because, as you said, like if there's one difference, it'll cause the checksums to not match anymore, and now you've wasted all of that work, right? So now what we do instead is we traverse like the whole tree, and we check per component to see if things are the same. Okay. And then the parts that aren't the same, we throw those parts out, but it lets us like preserve the parts that do align. So it's a lot more forgiving, as you said.
So would you consider it a good idea now that you also have siblings? Like you can actually render a different component from another render function of a different component, right? The one, I forgot what's it called, but let me just try to say. Portals, right?
Portals, okay.
Right. So effectively, I can have a different component tree on the server and then use portals on the browser to just give React the control of my dynamic components. Like that could be a huge deal in decreasing bundle sizes.
So why would you want to server render the portal on the?
No, so
wouldn't you just skip rendering it completely on the server? Is that what you're saying?
No, so I would render everything statically on the server.
Okay.
And then only render, like basically I still want the component tree to be the same on the browser.
Okay.
Just that using portals, I would give React the control or knowledge of only those components that are dynamic. Basically the ones that would need lifecycle hooks.
Oh, I see what you're saying. So like, don't attach React to the whole page, just
right.
just in that dynamic part.
Exactly.
Yeah, I think you could do something like that. This is like an active area of investigation. We have like a very basic like streaming server-side renderer right now. Okay. We don't really use server-side rendering at React right now, at Facebook right now, because for a lot of our server rendering we use Hack, just like PHP. Yeah. But we are looking at ways like in the future maybe we can start using this at Facebook. And I think we're going to have a lot more research in this area in the future.
Awesome. That's super exciting.
Cool.
Hello. Yeah, hi.
Who am I looking at?
Hi,
oh, there you are.
How are streams rendered in React 16?
Streams?
Yeah.
Like server-side rendering streams?
Yeah.
I was not involved in writing this part of React, so my understanding is that it's basically like, so stream just basically means you, like as you're doing the work, you start sending to the HTML to the client as you go. So right now it's just like all in order. So like since everything's synchronous and you just do everything in order, as you're rendering, as we're going through the tree, we just, it's pretty basic. We just start sending the opening tags and then the closing tags, so that the browser can start parsing and doing and rendering things even as you're still rendering on the server. So it's pretty basic right now. In the future, we want to do more sophisticated things, like being able to render things maybe out of order, right? And also maybe be able to do things asynchronously. So like rather than have to do everything in one go. This is one area that I'm don't have as much expertise in. But yeah, right now we have a very basic streaming render, and we hope to make it more sophisticated in the future.
Okay. Second question is, it's not related to React, but more of in Redux.
Okay.
Yeah. So what would you suggest to use React router or Redux first router?
I don't know that much about Redux first router. I would say, like, why do you want, what do you say is the argument for why you would want to manage your router state in Redux? Like, what do you think that gives you?
So currently we are using React router,
Okay.
but then we are trying out Redux first router as well. So I wanted your viewpoint of both of them.
Yeah, so I don't know that much about Redux React Router or whatever Redux First Router, whatever it's called. There are so many different Redux routers. I experimented with this at one point. I can't remember what I called my thing, because I just liked, I don't know, ideologically or philosophically, I liked the idea of having all my state in one big tree. But I don't know, I think React Router is a really good library. It provides a really good abstractions for rendering. And I don't necessarily think there are that many benefits to coupling to Redux. But maybe there is some really great benefit that I'm just not aware of. So I would just use your judgment. I also just kind of feel like React Router is a pretty established library that has a lot of users around it. So unless there was like a really cool benefit of this other library, I'd maybe be hesitant to switch to it just because you're trading away a lot of the community around React Router. But again, I don't know this library, so I don't want to insult it without it having even read the docs. So I'm sure it's a great library. So sorry, I can't offer more specific advice.
Thanks.
Hi, what's your name? I'm just joking. I know him already, to be clear.
Two questions. The first one is about the way the commit phase has been pushed all the way to the end. What would the impact of that be on React Native? Primarily because React Native also batches the queries, and unlike the DOM, if you have to send the commit over to React Native renderer, the bridge is expensive.
Yeah.
Now that you've pushed the commit all the way to the end, the bridge is going to starve or wait for a while, and then it's going to get this sudden big chunk of work, which React Native's bridge itself is going to start chunking. So there is these two levels of batching or chunks that happen. What is the impact of that on React Native's rendering engine? Do you guys have tests that you've run? Or?
Yeah, so our React Native profiling is pretty new at this point. We still haven't done a lot of performance tests on it. The commit phase though is designed to be really small. There shouldn't be that much work going on it. The idea is that the bulk of the total work should be happening in the render phase. When you're calling all the render methods and you're reconciling all the children. And the commit phase is really just supposed to be we have this list of effects that need to happen, and we iterate it over really fast, and we do as much as possible not in the commit phase, in the render phase instead. There's really just only the side effects that we put in that commit phase. I can't say for sure what the performance impact will be. You're saying that it's really costly to send this big list over the bridge. Is that what you're saying?
Effectively, what you're doing is waiting for a very long time when the bridge is idle, and then you're giving a whole chunk of work to the bridge, and then the bridge itself is going to wait till it collects enough work so that it can send it over.
Okay.
So it's like two levels of batching, and I'm not sure. So given that now you can't pull work out of the React renderer, you have to wait twice, and that's why I was wondering if you guys had any profile.
You probably know more of an expert on how the React Native bridge works than I am. I'll probably have to shift my focus to this in the next few months, but I don't have a ton of knowledge of how the bridge works. And we also we haven't really done much with the async stuff in React Native. We're going to end up probably using an entirely different async model for React Native than we are for using the request idle callback model, yielding model of React DOM, just because they're two fundamentally different environments. Whereas in React Native, we'll probably have some level of parallelism, whereas in React DOM in the browser, that's not really feasible, just because the APIs aren't there, or the support isn't there for that type of stuff. So this is all to say I don't know quite yet because we haven't measured it, but it's also we probably will have we will definitely have a commit phase, because the commit phase, the most important, the reason we need this is that is for consistency, right? Because if we update things asynchronously and they get interrupted, then now things are inconsistent. But I will say that like in the DOM world, like the commit phase is always very tiny. Like it's meant to be a really small slice of work.
In React Native, the commit phase is going to be the commit plus the bridge cost.
Okay.
The second question was about.
Well, so hold on,
yeah.
just to be clear. So the bridge. So you're saying that the bridge cost is like when we're sending the stuff over. Yeah, I would.
Serializing the JSON, converting it to.
So what I would guess is that because so the way we'll probably do this is we'll put synchronous work, we're going to put on the main thread. So there wouldn't be a bridge cost in this case. And so the things that will have to pay the bridge cost are things that are asynchronous anyway. So it probably is not a big deal.
The second question was about event handlers.
Mm-hmm.
Looks like you're saying that my input event handler is going to be async schedulable.
It will be async, but it will be at a higher priority than.
So what happens to things like event.prevent default, which have to be synchronous?
So
as I understand, you guys are not going to implement passive event listeners.
Well, we probably will. Yeah, we will implement passive event listeners.
Will that be default? Effectively, what I'm trying to say is this going to break any code that I have written where in my event handler?
Yeah, no, we're not. We don't want to break any of your code.
What will happen to e.prevent default and e.stop?
Yeah, so to be clear, when I say like the input events will be asynchronous, I mean like the set states will be asynchronous. The handlers, if they're active handlers, they will still be synchronous. Yeah, there's like two different things. But yeah, there are a lot of interesting consequences around async and input events. Because you want to make sure that when you process the update that this is hard to explain, I guess, but you want to make sure that if you have any pending updates, that they are these pending updates may like affect the. This is really hard to explain. When you call set state on a child, or when you call the event handler on a child, it could cause call set state on like some parent higher up, and then that parent's pending updates will cause once they are flushed will cause the child to re-render and create a different handler. So you want to make sure that you call the latest version of that handler. That incorporates all the changes that were further up, so that you're using like the version of the UI at the time that the user interacted with it. It's kind of hard to describe, but yeah, basically like input events are kind of a special version of update that we'll have to handle a little bit specially.
Hey Andrew, hi. Yeah.
Oh, where am I looking?
Hi.
Oh, yeah.
Sorry. Yeah, I'm just going to ask a little more detail about streams.
Okay.
If you're not comfortable answering it,
I'll tell you if I'm not.
Okay, so there's like two questions basically. The first thing is I was reading about streams pretty recently, and then I also realized that it's going to be particular to Node Server as of now. Is there any roadmap about supporting, say, .NET or
okay.
Java-related streams?
I don't think so. I don't know a ton. So I believe people do like server-side rendering in these other platforms today by like spinning up V8 basically.
So it's something like Java uses, say, Nashon or something like that to server-side render. But then I don't know if that's going to.
And they would just and they would just like call the render to string, and it would just like synchronously return a string, and then you would. Yeah. So I mean, I don't think we will maintain anything for these other platforms. The only one we'll probably maintain is the Node one. But I assume whatever we build shouldn't be too complicated to port this to other frameworks. It's unlikely that I imagine it's unlikely that the React team will maintain these things. But hopefully, like other people maybe you will step up and and build this thing so everyone can use it.
Right. My second question was going to be some sort of a side effect on the presentation and the question that the other gentleman actually asked. So I was hoping that you would sort of touch upon streams per se, but then that was sort of missing from your presentation. And I think the other gentleman, the first question that he touched upon, something about keeping React to things that are very dynamic. So the streams would then help me render my static contents very easily while I'm still working on the dynamic part of it. So is there a possible, say, timeline for you to sort of make streams mainstream?
Like you're asking like how soon we will release something like this?
Yeah.
It's hard to say. It's not on the top of our goals for this next half. So maybe sometime next year. It's hard to make promises. Like right now, our focuses are on this async stuff, and on we have this cool project to try and like move, compile React components to more optimized form. So that's another big area of research. And then in the future, we do want to investigate like more sophisticated like versions of a React server-side rendering. Maybe even like the same concept, but for native, like React Native. You could compile to some sort of serialized format and send it to mobile clients, and then same concept. But all of that, because we don't currently use it at Facebook, it's a little bit further out. But yeah, maybe next year. We'll see.
Right. Thank you.
Yeah.
Hey, Andrew.
Hi.
I'm Chirag. I work with the MyLikeU team at Microsoft. First of all,
Cool.
I'd like to thank you for React, right?
Yeah, well, it's not just me. There's a whole amazing team.
Thank you for the thank your entire team.
Yeah, we appreciate it.
So I had a question regarding the error boundaries that you were talking about. So
Sorry, say that one. Error boundaries. That's what you said. Okay.
So I have a certain vendor module that probably throws an error on certain client machines. So because I capture logs and log entries, and then I know that in certain client machines I get an error from some vendor module of mine. So is it possible for me to set an error boundary around a particular vendor module of mine so that?
So can you describe what you mean by render module a little bit more?
So so basically I have bundled the dependencies that I use as into a vendor.js,
okay,
which is what throws the error at the end of the day. So it's one of the dependencies that I use in my project that throws such an error. So it's like, let me give you an example. If I, for example, were to use some component like React AutoSuggest within my project, and it was to throw an error on certain client machines that I'm not aware of, in the sense that I'm not able to reproduce the condition of the error over there. So I don't have a direct handle of the vendor code that I've included. So how do I go about not letting that make my app crash? Because you said that if there is any exception that occurs, my app would take, the app would crash, and then you'd basically take everything off the DOM, right?
Yeah, so to be clear, maybe I should have been more precise. So that's like what happens if you don't have an error boundary. This is what happens if like you don't wrap anything in an error boundary and the error just like bubbles all the way to the root. Then the default behavior is just to unmount the whole tree because it might be in a corrupted state. So clearly you want to like avoid that. So the way you make it not do that is you wrap certain components, or like your render module, you would like wrap it in a component and make that component an error boundary. And the way you implement an error boundary is just like a normal component, and you add this lifecycle method called component did catch to it.
Okay.
And then when a child throws an error, it bubbles up to the nearest parent that has this lifecycle method. The lifecycle method receives the error event, the error object, and then you can like call set state or do whatever you need to like update your state and like re-render a different view in its place.
Okay.
So it's really just like a try-catch. You just like bubble up to the nearest parent.
Cool.
Yeah.
Yeah, I think that answers my question. Thanks.
Hello. Hi.
Hi.
We love using React components for imperative and non-UI components and using the component lifecycle. So what do you think about using these non-UI imperative code in terms of scheduling, and how would it work? Can we just rely on React and it will handle all our tasks which are non-UI? Like the components which render null.
Yeah. So you're talking about things like, what's the, Ken Wheeler has a lot of projects like this, right? He has like a, what? Audio, yeah, React Audio, like so things where you're like using the life cycles, but you're not actually rendering to the screen.
Yeah.
Yeah. That stuff should all still work. One thing which I didn't mention that React this new version that we have codenamed React Fiber. This new version of React, one thing that is really cool about it is from the beginning, we've designed it to make it really easy to build custom renderers. So, in the beginning, React was just React DOM. There was no difference. And then later we added React Native. We have this thing called React Art. Nowadays we have a renderer called React VR. We have all these different renderers. I think what was the company, like Flipboard or something came out with like React Canvas or something like that. We have all these different rendering targets. And before React 16, the way that you would implement this was pretty hacky because it was like an afterthought in terms of the implementation. We had to use a lot of like injection and stuff like that. But now in React 16 and on, we're going to have this like proper first-class way of building your own custom renderers. So what I'm really interested in is to see if like a lot of these experiments that don't actually render any DOM can instead be implemented, rather than just like using React DOM and using the lifecycles, maybe they could be implemented using like an actual custom renderer. I think there's a lot of potential. Does that make sense?
Yeah, thank
cool.
you.
Cool. Thank you so much, Andrew.
Just one
Do we have
question.
one? Yeah, sure. Go ahead.
My question is regarding React Fibers. I just wanted to know what is the underlying mechanism under Fibers, like how the scheduler knows when to stop and when to resume.
Okay, yeah. So the codename React Fiber, like the word fiber is it's also a cool sounding word, but it actually came from this data structure. The data structure is called Fiber. It's like that's like really the only data structure that we pass around internally. What a fiber basically is there's essentially like a fiber that corresponds to every single component in your component tree. So you can think of it, this is like the virtual DOM node, right? Except we don't have a fiber just for like divs and spans. We have a fiber for your composite components too. Like every single component in your tree will have a fiber. And this fiber has information on it, like the type of component it is, like a div or span or like a composite component. It's information like the memo, like props that were last used to render it. It has things like a state queue. It has things like the list of children that it rendered. It has a pointer to its parent. It has a pointer to its sibling. And this is the structure. It's like a giant linked list structure, and this is the structure that we keep in memory in between renders. And so the way that it works, another way of thinking about it is that it also forms kind of like a virtual stack frame. So like the biggest difference between Fiber today and how React used to be implemented is that we don't use recursion anywhere in Fiber. Because what we need to be able to do is like pause the execution of rendering like anywhere in the tree. So previously just because we just use recursion and we use like the JavaScript stack, like if we were to continue using the JavaScript stack and when we wanted to like pause and yield to the main thread, then it means the next time when we come around to resume, we'd have to like recreate the whole stack by starting at the top again. Whereas now, because we like don't use the JavaScript stack and we just use these fibers which stay in memory, we can just resume off of whatever the last fiber is that we were working on without having to like go back and recreate the entire JavaScript stack again. So what we do is we basically, when we're in async mode, we have this while loop, right? And we do a unit of work, which is just like a single fiber. We do the work for a single fiber, and like in that phase, we do like reconciliation. We like call all the life cycles and stuff to calculate the next children, and then we come back up to this while loop, and we get a next unit of work, which is probably like its first child or it's the next sibling or whatever. And then on every iteration of the while loop, we check this deadline, and the deadline is provided by request.callback. And the deadline will say like how much time do we have left, and if we have like over like some arbitrary amount of time that we use as a heuristic, if we have enough time left, then we do the next unit of work. And if we don't have enough time yet, then we stop what we're doing, we yield to the main thread so that the browser can process any events or anything that it needs to do. And then when we come back on the next idle callback, we can continue where we left off and keep working on that fiber. So that's the basics of how it works. I tried to give like a very basic summary, but for more details, I'll probably try and write some more stuff on this in the future.
That's what I wanted to know, like what is the underlying browser API, like request idle callback?
Oh yeah, sorry, I could have just told you request.callback. I'm so sorry, I thought you wanted to know about the fibers. But yeah, it's in the browser we use request.callback. It's likely we're not going to use that same model for native, but yeah, that's what we use.
Thanks.
Yep.
Great
That
talk.
was great. Thank you so much, Andrew, for so much of information. And can we please give some shout to Andrew? Whoa.
Cool.
Thank you so much.
Yeah, no problem.
Okay, so now we are heading towards the end of the
there's a
conference
spider.
day, and probably as many of you know that, yeah,
it.
Party is
I don't
sponsored,
want-
so
should I
we
kill
have drinks, food after the conference is over with all of us together in Shiro, that is in UB City Mall. So we are heading towards that. So probably now is the time for some fun, some feedback to us. So if you see on the get it disconnected. Can you please on? Okay, so here is a link. Everyone, can you please get out your mobile phone and enter a link and one session ID?
Guys, can you take out your mobile phone or laptop and keep a browser handy in that so that we can start with the session? Trust me, guys, it is going to be a very small session and fun for sure.
That is tinyurl.com/jschannel17. Session ID is, yep. So we have 3 participants joined. Let us know if there is any issues. And once there are quite a good number of joinees, then we'll start with some session, some fun. tinyurl.com/jschannel17.
Yeah, we have 55, 56,
Whoa,
57.
it is
Wow.
increasing.
Can we have more people join into this URL? tinyurl.com/jschannel17. Session ID MBKW.
Let's see the status. Whoa. When it stops, then we'll be probably starting. 130, 31, increasing. 33. Are we 150? Probably we are 150. I think we are good to start. 149, come on, 150. Yeah.
I think we have more people, more than 160, 170 over here.
Cool.
Guys, please log into this URL, and with the session ID, we're going to have a very fun feedback session so that we can work upon your feedbacks and have a better conference next year.
63. I think now is it got saturated. Oh, 67.
Is there anyone facing issues to log in? We have volunteers here who can help you out.
Oh, sure. Cool. I think we are pretty good. Almost 180. Oh, 180, yeah. Cool. Oh, still it is increasing. Wow, that's great.
Shall we wait for 200?
Shall we? I think we should continue now. Cool. So here comes our first question. How would you rate the relevance of conference contents? And you have A, B, C, D option. You can simply write A, B, or C, or D. A is an awesome as ECMA land. Well, very good, satisfactory, or can be improved.
Please fill in the response in the field provided in front of you. A, an awesome as ECMA land. very good, satisfactory, or can be improved on?
139, 42, 50, 45. 176 responses, 180, 181, 180. I think, 86.
So there are 5 more people who are still pending to give the response. Wow.
We have the count. Cool, 91. Shall we see the result? 192. I think now
I think we can see the response.
Another one, come on. Yeah, I think now we're good to show the result. Oh, very good. 84 as awesome as Ikmal, and 28 can be improved. Sure,
Yep.
you can tweet us. Cool. We are heading towards next question.
The main reason for attending this conference, what was your main reason? A, my company paid for it, my friends were coming, or C, I wanted to learn something.
We know the truth underneath, right? Is it? The count was 191, right? Niket? Whoa.
193 probably, to be precise. We will see how many people were actually learning something out of this conference here. Two more people.
191.
193 we have.
Who are the 2 people? Come on. Where are you?
One more.
Yeah, that guy got scared of me, right? Come on. Oh, yeah, we have. Come on. Let's see the result. 1, 2, 3. Come on. 53. Whoa! 129 for learning. Come on. Seriously?
Some serious learning has happened in this conference today.
Thank you to all our speakers. Thank you so much. Sorry? Oh, yeah. It will be the opposite, right? Cool. For all those 53 people, yes, I'm one of them. Thank you so much. Cool. Topics you enjoyed the most. So it is a free text. You can literally enter anything you want to.
Type in anything you see, or you want. Topics you enjoyed the most in this conference.
Let's see. Well, React. Wait.
Your responses will be shown over here.
React. Gojek. Okay. Dance, workers, speakers, animations, components, UI, V8, React is on the top, native is there, Island is there, ECMA, no?
ECMA, no.
Some random text.
Page,
okay. It's style,
using.
offline, animations, node, engines, tools, reactive, flow.
I
tea.
even see food and tea being given in the response.
Diet is there. Cool.
Wow.
Reactive, Siddharth KP. Oh, is that you?
GraphQL. Yep.
Someone enjoyed the dance? Yeah. Components. V8, React, and native, Reason, components, Electron.
We're still getting more responses
some
here.
chai coffee is there. LOL, wow. Functions.
I think a lot of people enjoyed lunch. That is coming up again and again.
How you enjoyed this? Someone, come on. Fiber, pure, free.
Redux.
Oh,
Yep.
Free? Shirt.
Shirt.
What is that
Wow.
shirt? QL, state, KP, Hindi. Oh, who is that guy? Web Parshuram is, I know you. One ticked. Q. I think now it is freezing. Let's, still people are responding, okay? Okay.
CSS.
Very Villa, got it?
Yeah.
It is like enter. Is it so? Users. Shall we go to the next question?
Yep, I think we should.
Cool. Okay.
So did the conference fulfill your main reason for attending this conference? A, yes, absolutely. B, yes, but not to my full extent. C, no. D, cool. What is this? E, memes. F, performance.
Did it.
Mahesh, can you please zoom it a bit? It's
Zoom.
not visible.
Okay, I'll try to.
Primarily, let's have answers from these three options.
151 responses. Let's see. The reason for attending was learning, right? Majorly people. And after drinks, it would be company. So let's see, 81. Few people are like decided not to reply. When they will request me, then I'll write only, right? Is that so? 187. Freezed. Okay, I think.
We can see the response
Cool.
now. Yeah.
Yes, but
not
not
full
to.
my-
Okay, got it. We'll see. No for 16. Come on. Who are those people, 16 people? Let's talk more. Okay, got it. No issues. We'll keep in mind. Next question. Which topic or theme you like to be addressed at the next GS Channel conference? Random, anything? Anything works? Let's see.
IoT, Node, JavaScript.
JavaScript, come
I think
on,
we
yeah,
covered
JavaScript.
a lot of JavaScript in these 2 days. Polymers, anything.
We are 4. What is that for? AR.
ES7.
Saga, HTML. Okay. Traffic. Wow, that is great.
I can
So
I can even see dance coming up here.
WebAssembly, Docker, ES Next, Preact.
Traffic.
I think Saga host, topic, HTML, C processes. Well, SVG, ECMA, bots. V8 Fiverr workers, Saga, backend dancer, HTML unit, SSR. Cool, pretty good. I think we can go ahead. We'll keep in mind, by the way.
Yeah.
Cool.
So next, moving on to the next one. Would you like to attend the next JS Channel conference? A, are you kidding me? Definitely yes. Maybe. Let me get back to you. So probably give us the answer from one of A, B, or C.
Tech dating 101, yes. Okay. A few other Gojek, Angular tech dating. Got it? $148.50. So are you excited for the next JS conference? Yes? No? No? Yes? Come on, thank you for that. 184. Yes, you can do. Remaining people? They decided not to. I think we can go to see the result. Maybe.
Maybe.
Okay. Are you kidding me? Definitely yes. Come on. Yes, thank you. Let me get back to you. Okay. After the dinner, probably. Okay. Going to the next question. Which keynote speaker would you like to see in the next JS channel? Maybe. Okay. Sarah?
So Max Weber,
Mark. Zuckerberg.
Zuckerberg,
Okay.
wow.
Thank
We'll
you
keep
for
in
that.
mind.
Thank you for that. Probably Andrew can help us with that.
Andrew can help us with this.
Are you promising that? Okay.
Wow.
Parshuram, Sundar, Sia, Gojek. Oh, Gojek. Come on. I know. Gojek, you are sponsoring it doesn't mean that. Okay. Chris, Preeti, Kenny. Oh, Kenny. Yeah, that is required. I'm up for that. For Kenny Sebastian.
Yep.
Cool. V8. Come on. Who's that guy? Baba.
Yeah.
Saloni.
Yep.
Okay, got it.
I even saw Modi.
Anjana, Saloni.
Yeah.
Oh. I'm getting you guys. But I did not write that. DHH, Ryan. Chris, Ajay, Queer, Karan, Sid, girl. Okay, I'm getting you.
No.
I'm getting you.
No, I see Modi also been written here.
Ramdev, that is the best one. Ramdev Baba. Come on. Papa, who's that? Gore. Okay, God. Who wants to see God on the stage next year? Huh? Paul. Okay, let's see. Refresh the choir cards. Reza. C. God. Said. TJ. Gil. Okay.
Elon Musk.
Bike. Who wants to see bike? Come on. Addy. Leah. Sriram. Hmm? Abramo. Tendulkar, come on, who's that? Who's that Tendulkar? Luis, Ali, Bike, Mark. Okay, let me refresh once more. Modi.
Gandhi.
Wow.
It's all political ground now.
We may come into the news tomorrow. Some India news. Tyler, Aman, Tule, Faradji, Kent, WP. I should refresh once.
And see the responses now. It has gone above 1,000.
Osman, Bab, AA, Ice, QP, Karthik Gandhi, Sian Pai, okay. Cockford. King, LOL, GF. Oh, your GF? Who's that? Cool. I think we should move to the next question. Next question, probably. Is there anything else you would want to share with us? Dinch. Sunny Leone. You don't know the spelling. You don't know the spelling.
Shetty.
Okay, Shetty. Leon, Mahesh, Kejriwal. Boo. Okay. Boo.
Mia.
Thote. Okay. Sunny, Shetty. Uber, Hacker. Eminem.
Eminem.
Yes.
Rajnikant.
Kejriwal. Cool. Dinchak. Yeah, that is a good choice. Bilzerian. I'm getting you guys. I'm getting you. Kejriwal. LOL. Shh. Messi.
Shaktiman.
Goodies. Yeah, I'm up for that. Job Snow. That is Jon Snow, dude. Host. Angular. Rajnikant. Yeah. That will be like accent. Pooja. Nothing. Life. Good Snow. Good Snow? Sina. Bahubali.
So maybe even we should get Kattappa also with him.
Probably. Modi, Sina, Bahubali, Punk. I think I should refresh it.
Refresh.
Pooja, Trump, Arnab, accent, Shetty, the fuck, Thote, John, Jerk. Okay.
Okay.
I hope that was not for me. SpongeBob, MJ, Mama. Okay, Get, Sampu, Played, Shh, Crowdfire. Awesome. Oh, thank you. Bed.
Whoa.
Is that what you learned today? Huh? Was that for it? Come on. King. But who wrote that Sunny Leone? Who wrote that one? Shetty. Okay, I can see this one. On the middle. Crowdfire. Movie. W3, Somit. Okay. I think now we should move. We can move to the next question. It's about organizers. How about the organizers? As in us, you can check the options.
A, B, or C. Amazing, mind-boggling, or super awesome.
Please. Please. Please.
Please choose the best one you like.
Please. Shetty, these are the customized option. We are sticking to these 3 options only. So I hope you like this probably. 56 responses. WWF. What are the customized options? W. Shetty.
They are coming from the previous response.
Okay. Amazing. Okay, these are the only 3 options you have. You have all the dimensions to rate us, probably. And thank you for that. Let's see how good or bad we are. Depending on the responses, we'll judge how we perform these Tuesdays. In this question, the number of responses is not that quick. See?
Yeah.
I'm seeing that pattern, you know?
So I think they are confused which one to choose.
We clearly mark these 3 different dimensions of rating us, you know? So the counter is so slow. Come on. Come on, guys. You should and you can. Rate us. 112 only?
I think half of that.
But to the people who are not still rating us, we know who you are. It's not anonymous, so we can track you. We can track you. Who other people did not rate us. So we aware of that. So whoever answers this question has the only ticket for the dinner. So choice is yours. Choice is yours. 119. After speaking a lot, then also it is 120. Sorry? Did you say anything? Okay. 126. 27. I think most of the people are so confused about those 3 things that they are still deciding and that what exactly should I rate to. Cool, I think...
we should see the response.
Sorry? I think we can continue with the answers. Oh,
wow,
okay.
Amazing.
Thank you so much. Amazing, we are amazing, and we are super awesome, and we are mind-boggling. So this was AND operator, all these 3 options. So thank you so much for that. Cool.
So moving on to the next one. Are you ready for the party? Again, Sunny came up.
Go. Yes, Sunny. Okay, nahi. Chutiagiri. Okay, Sunny, please. Okay. So you don't want party.
Yeah, I think
you
the
want
response
Sunny, please.
clearly says this.
Okay. Accent. Okay. Fuck. Okay. Shan, please. Oh, I was just reading out. So sorry. I should have F star star star. Chutia. Okay. Doggo. Okay. Daru. Okay. Gojek. Okay. There is some icon I'm not getting what exactly is that. So leaving up to you guys. Some American. Okay. That brown colored. And another one, some finger is someone is showing. Okay. Thank you so much. Old. Char. Let's see. Bhulaegi. Kaun bhulaegi? Karu. O. Time. Police. Rock. Park. Kar. Okay. B. Mia. Okay. Shan. Please. Okay. Cool.
I think we are done.
I think we are done. Thank you so much.
Thank you so much for the valuable feedback.
Cool. That was great. Thank you so much for at least bearing with us. Cool. So I think now the next section goes towards like we want to give some small moment to all of our speakers. Just a reminder so that they can remind us throughout their life probably if they want to. So I think we should really call them.
Yep. So probably we can So basically, we'll be giving out a few mementos to the speakers who came up to the conference and made this whole 2-day conference a really learning stage for us. So I would like to call up on stage Andrew Clark.
Some 2 minutes speech probably. Yeah.
On what topic?
About the conference, about us, about the experience probably, if you want to speak.
It's all right. No, as I said at the beginning of the talk, I was just very impressed is the wrong word. I was very delighted at how friendly everybody at this conference has been. I've been to some conferences where people just kind of like group off in their own groups and like don't talk to anybody and they don't want to socialize. Clearly, like their company just like paid for their tickets and they went to this conference. They didn't really want to be there. But everyone here seems super enthusiastic, super friendly. Everyone's just awesome and super delightful. So that I liked about it, and yeah, the food was by far the best I've had at any conference I've been to. That was great. It was actually one of the things I was looking forward to the most, and it delivered. And yeah, and just the organization in general. Can't think of any like complaints at all. It was very, very professional all the way down. Is that 2 minutes? Did I do my?
Thank you, Andrew. Thanks a lot.
Yeah, I'm trying to. Yeah, it was a really great conference.
Cool. Thank you so much. That was so kind of you. So we just want to give you one moment from our side at JS Channel India. So can we get one picture? Well, feel like a winner?
Put a spell on someone with this thing. It's like.
Thank you so much, Andrew, for coming here. And we were really grateful to have you here. Thank you so much.
Yeah. So next we would like to call upon Farhad. Can we have a round of applause?
Farhad, do you want to tell something about your experience or anything?
Yeah, absolutely.
Yeah, sure.
Obviously, I already said my major thanks. Thank you so much for the organizers. Thank you all for all being here, just being under one roof and having this moment to talk about the things that we all love to talk about. Thank you so much for the Indian garlic naan. I ate so much of that and I feel it here. So that's phenomenal. Thank you so much for everything, guys. If you ever, I hope our paths cross again. If you ever guys come near my home, I hope that I can show the same type of hospitality as you guys have shown me here. Thank you so much again. Appreciate it.
Thanks a lot, Farhad. Thank you. So next, Parshuram, I would like to invite you on the stage.
Anything you want to talk?
Sure. So I think this is like coming back home to me because I started my career in Bangalore like 1 billion years ago. And back then, I'm old, I'm seriously old. So back then I didn't have so many front-end engineer friends. And I was able to meet a lot of great people, learned a lot of interesting things from you guys, specifically front-end engineering problems that are specific to this country, this sort of an environment where the network isn't as reliable. So it did help me understand and get a completely new perspective. So thanks a lot for that. And along the way, I've been able to make some really good friends.
Thank you so much. That was so kind of you.
I would like to call next Sanket on the stage. Sanket Sahu.
Yeah, it was actually a great experience. For me, actually, it was for the first time at this scale. So I really thank JS Channel for accepting me as a speaker here. And I had a wonderful time talking to people here and in the lobby. Thanks a lot.
Sure, thank you so much.
Thank you. So next, Jay Santosh. Yep, he's here. Can we have an applause?
Whoa.
So super impressed with the array of problems that people have and trying to solve, especially like talking to so many of you. It was very interesting talking to each of you, and yeah, super impressed by the community and always proud of Bangalore community. I've seen it grown from how it was 4 years back to now, and it's super great. Yeah.
Thank you so much.
Thank you. Thanks a lot. So next, I would like to invite Francisco on the stage.
Thank you. Exactly what Andrew said. This was amazing, and I'm so happy that I had a chance to be here. Everybody was super friendly. I loved the food. The organization was great. The other talks were just amazing. I was really impressed with all your questions that you had after my talk. It was great to talk to you, and hope I get a chance to answer some more questions tonight. And a big shout out to Girls Who JavaScript here.
Thank you. Thanks a lot, sir.
Thank you so much.
Thank you. So next, Sarah, I would like to invite you on the stage.
Okay, so Andrew stole all mine, so he's dead to me now. But actually, I just wanted to say, this is my first time to India, and I think like the food has been amazing, and the people have been amazing, and all of the conference attendees have been just super wonderful and really welcoming. So thank you so much for that. Actually, I'd like you to give yourselves a round of applause for being such wonderful attendees. Something that I really enjoy about this conference is kind of the spirit of open source that I've been seeing again and again. I am a CodePen picker, so if you make anything from this conference that you're really proud of on CodePen, make sure that you tweet it at me, and I'll make sure to pick it. Okay, thank you.
Thank you. Thanks, sir. So next, I would like to invite Vinci Rufus on the stage. Vinci Rufus. Oh, okay, fine. Thank you. So moving on to Max Schreiber.
Whoa. Whoa. Cheers. Come on. Whoa.
Thank you. I've been to lots and lots of conferences in the past 2 years, and nowhere have the attendees been as great as here. And I mean that. Give yourselves a round of applause. Like, the amount of good conversations I've had and the questions that have come on stage and everything have just been amazing. So it's been awesome to be here. Thank you for having me.
Thank you. Thanks a lot, Max. So moving on to Siddharth, I would like to call you on the stage.
Whoa. Hey, so it is really, really nice to be here, and you've been a lovely audience, of course. And just like one thing that I would want to point out is that we work in this very, very quirky language and community, right? And that has led to a lot of innovation, so just don't stop building stuff. I've had like so many conversations about different problem statements that I didn't even know exist. So yeah, just don't stop building.
Thank you.
Thank you so much.
Yep. Moving on to Rahul Roth. Oh, I think he has left.
No.
Mukul Jain. He's here.
Yeah, well, thanks James Channel for having me here and giving me the opportunity to give spoilers of Game of Thrones. No, really, jokes apart. You guys are really awesome, and it was a learning experience. Thanks, guys.
Thank you. Varsha Saha.
This was the first time for me as a speaker at any conference, and as soon as I entered the room, I immediately felt so comfortable with so many great people around me that it was not difficult at all. And also as an attendee, I learned so much from such great speakers, such experienced speakers, and All the audience was wonderful. Thank you so much.
Thanks a lot.
Thank you so much.
So moving on to last but not the least, Preeti. Preeti Gase.
Preeti.
Everyone stole all my answers, but I'll still try. So, first of all, I want to apologize for some of the technical difficulties. I hope you still followed the presentation. 2, I want to thank Andrew for being the first man on stage with me for the dance. 3, I was really surprised and encouraged and honestly inspired by how much curiosity and passion you guys had, and like the questions that came up. Like there was so many questions that I couldn't finish lunch. Both days, but it was really fun hearing your questions and answering them. And lastly, I'm excited to come back, honestly. I didn't realize how big the ecosystem here is in Bangalore in India, and I'm excited to come back again some other time and do more of this.
Whoa.
Thank you.
Thank you so much. So, thank you so much, everyone, for being here, for being so nice to us. And now is the chance that I'll like to call all the volunteers of GS channel, and probably Abhinav, can you please come on the stage, and other volunteers as well, just to show that these are the group of people who have been working. So Abhinav is one of the key member for organizing this all stuff. Cool. So these are the great bunch of people we have been working from last 7 months to make this possible. Thank you so much for your support, and I hope that it went well. So going forward, what we have been doing every year, that everyone comes to the stage and we get a group picture so that we can be there always. So can we everyone get on the stage, please, so that we can get a picture?
Manish, I think we are too much in number. We can gather over there, and photographer can come on the stage and take a big picture from there.
Yeah.
So I request everyone to come forward so that the photographer can take a group photo for everyone with the speakers. Can speakers come in front? All the speakers, please. Guys, please gather up at the back so that everyone comes up in the picture.
We can sit from front side, yeah? We can sit from the front side. Yep. Come on, give some shout, please. Whoa!
So maybe photographer can help us to organize so that everyone comes up. Thank you, everyone.
Thank you, everyone.
Let's meet at Shiro, UP City at 6:37. What is 6:30? So the party starts at 6:30. Shiro, UP City next to this hotel.
First floor.
First floor, yes.
See you everyone there at the Shiro, and let's talk more and eat more, drink more.
And drink more.
Yeah, drink more. Thank you so much, everyone. And let's wait for next JS Channel conference. Thank you so much, everyone, for being here. Whoa.
No, we'll have photo on the stage. Yeah. Group photo. So can I request speakers to come on the stage so that we can have a photo?
More pictures. Can we request the speakers to come on the stage? And volunteers? Whoa. Thank you so much, everyone. Thank you so much.